back in here. Another video. So, today we're in Code Wars, and the name of the exercise is Split Strings. It is a 6 Caillou. I'm not even sure how to pronounce this. I guess it's Caillou. Whatever it is. You see it on the screen. Alright, explanation-wise, and also going to do this one today in Python, as you see selected up here, Python. That would be the language today. Complete the solution so that it splits the string into pairs of 2 characters. If the string contains an odd number of characters, then it should replace the missing second character of the final pair with an underscore. So, it's got a couple of examples down there. So the overall thing is that you're going to get a string as the data type, and you're going to chop it into chunks basically of 2 characters and return a list of strings, as you see. And yeah, the chunks are going to be 2 characters each, and if you have an odd number of characters in the original string, the last element will be 1 character and an underscore, as you see. So this is kind of a basic thing where you're taking in a string and breaking it into chunks of a certain size. A pretty good skill to practice, absolutely. So let's look at these examples and kind of develop a strategy here. Of course, you're going to be chopping it into chunks, like I said. So you're going to go by 2s. You're going to, take this A, B, and then this C. Of course, there is no second character for the C, so then you would append the underscore. In this other example, you can kind of see that it's an even number of characters, and so it's just going to be 2 by 2 going forward. Yeah. So if you're pretty familiar with Python, well, an approach to this is like, thinking about it in terms of what programming constructs could match up with this, with the need here, solution-wise. And if you're pretty familiar with Python, programming construct could be the range loop, where, in the range loop you can you can skip by a certain amount. Like I can go 2 by 2 or 3 by 3, meaning I can as I iterate, I can go 2 ahead in a string or a list, or 3 ahead or 4 ahead via the step option of the range. Of course, you can do this in other languages as well. Like a regular, like a C for loop or a C++ for loop. You can just increment I by +2, +3, or whatever. But in Python, you can use the range to do this jumping thing. So I'm going to employ that to facilitate this solution. And yeah, I'm really gonna jump by 2s, where I'll kind of draw this out a little bit for you using one of these examples. Let's say I could start on the A in this example, jump 2, end up on the C, jump 2, end up on the E. And then what I can do is I can capture A and B on that first, C and D on that second, E and F on that third. And these would be individual iterations of a loop, where I would get A, or I would land on A, look ahead to B, get those 2, then land on C, look ahead to D, land on E, look ahead to F, And really, you can do the look ahead with slicing, because with slicing, you're not going to go out of bounds, and I'll probably cover a little bit about that when I start talking about the code. And I'm actually going to start doing that right now, because got a little bit of a strategy here, so I'm going to drop some code. Yes. Let's get the cursor handled. All right, I'm just going to do it right in the codewars interface since this is a pretty easy problem. So first, from doing this before, I know that I need to check the incoming string for emptiness, because if the string is empty, I'm just going to return an empty list. So I'll do that real quick. If that string is empty, going to return empty list. Just kind of get that sort of validation out of the way. So now I need to create some pairs, or create the pairs. The pairs or the chunks, as it were. And really what I'm going to do is I'm going to loop using the range loop and loop by twos, or I guess iterate by two, so I can get to, jump, get to, jump, get to, jump. And I'll go over how to handle the odd situation a little bit later. But I'll create an empty list to hold the chunks, and I'll just call them chunks, even though maybe not the most appetizing word, but we're not eating here. And so I'm going to loop, trusty for I and range loop, and we'll do the length of s. Yeah, so, and I'm going to use the step option here. So whenever you use the step, you've got to have 3 arguments. So start with 0 as the beginning of the list. The length of the list is going to be the stop or the end of the range, and then the step is going to be 2, because I'm going to be jumping by 2, like I was saying before, to get these nice little 2-sized chunks. That sounds weird. Okay. So in the body here, what am I going to do? I'm going to use slicing in the body, where I'm going to get a slice of two characters and then append that to the chunks list. So I'll do that. And then the slice is going to be S, and it's going to start where we are at I, and then it'll go I plus 2, because you probably know that the upper limit of a slice is not inclusive, so it'll include I and I plus 1, not include I plus 2. So it'll be a 2-character slice, giving you I and I plus 1. So I'll just throw that over here in the comment. Of course, elements I and I plus 1 of that string. Yeah, I plus 2 is not included. So yeah, it's going to get those. And the cool thing about slicing is that when you slice, you don't have to really worry about not that you should worry anyway about anything, but you don't have to worry about being out of bounds, because slicing, it will not cause an out of bounds error if you address a slice that goes past the length of your string or the length of your list or whatever. And this is going to go out of bounds, actually. It will, for the odd numbered or the odd length string. It's going to go out of bounds. But when it goes out of bounds with a slice, it's only going to include the remaining character or the remaining elements. So it's kind of like a safety net. So I don't have to do any kind of bounds checking. I can just freely go ahead and do this, and when it gets to the end, it'll just include the remaining character, and it's safe. So yeah, try that out on your own. You know, if you do a slice past the end of a string or a list, it's solid. It's just you're not going to get any errors, and it's a good way to kind of not have to be so meticulous about your indexing, even though you really should learn how to be more meticulous, because it makes you a better programmer. But anyway, if you're trying to save time, whatever, trying to knock out an exercise, you know, keep it moving with this. All right, that's enough. Next line here. So getting the chunks in this list or in this loop. When this loop is done, I'm going to have my chunks, and really the remaining thing is going to be dealing with the situation where there's a possibility that if the string contains an odd number of characters, that the last element is going to be by itself. And if it is by itself, I can just tack on the underscore. So I'll do that. I know I'm leaving out a lot of kind of consideration or maybe some figuring out that maybe has to be done, but I'm trying to do a fairly quick video here. So I'll just make it conditional. I'll say if the last element of my list is only one character, then I'm going to tack on the underscore. See if chunks, let's see here. Now if the length of chunks, if I can type here, if the length of chunks, the last element of it equals 1, it's only going to equal 1 or 2. So if it equals 1, I am going to concatenate an underscore onto it. Yes, yes. And I think that's it. Return chunks. My beautiful chunks. Okay. Yeah. And like it would be in this case, if you got that element or the character by itself, tack on that and you're good. And it's always only going to be the last one because of the parameters of this this exercise. So you can be you can just check for 1. And I have no idea what's going on outside with that engine revving. Okay, like this one, you know. And yeah, I think it's good. So I'm going to run it through and see what I get. All right, pass the test, and we pass the attempt. Correctamundo. Beautiful message. So yeah, this one is done. And that means this video is done. So got a little solution here. If you take a look at this solution, you could also do it, or at least I think this part, definitely with list comprehension. So maybe you want to give that a try afterwards and maybe come up with your own alternative solution. I did a solution where I'm looking ahead as I loop, where it's like bam, look ahead, here, look ahead, but you can also look behind, where you could start one ahead, look behind with slicing. You can't, well, it's more difficult to do without slicing. So, but you can look ahead or behind. Anyway, there's other ways to do this. I'm going to stop rambling. Here's the end of the video. You got your solution. Hope you all liked it. And I'm out of here until next time. I'm sure after that snazzy intro, y'all are pumped up to do some coding. I like that one. All right, here we are, back in Code Wars once again. And yeah, all my videos aren't going to be Code Wars, but a lot of them are right now, so it's still good. All right, index capitalization. And this is a 7 from Code Wars. Today I'm doing it in C++. So if you want to check out some C++, stick around. If this ain't for you, click on another video. C++ be the language. All right. Given a string and an array of integers representing indices, capitalize all the letters at the indices. So here's some example calls and runs. And yeah, this is going to be a function where you're going to get 2 arguments First argument being a string, second argument being an array or vector-like thing that is going to have indices. String and a vector of indices. And what you're supposed to do is at all of these indexes, whatever you want to call them, at these spots in your string, you are supposed to uppercase your string. So you see here in this first example, A, B, C, D, E, F. And you look at 1, 2, 5, at indexes 1, 2, and 5, we have B, C, and F uppercased. So, fairly simple idea, but good practice for some of y'all. Looking at the next one, same string, A, B, C, D, E, F, a different vector, and it's going to be 1, 2, 5, 100. And so we have the same stuff capitalized, and yeah, there's no index 100, so this 100 is basically ignored. So this is telling you that you're going to get some weird indices that are not in your string, and you got to kind of handle that. So you got to build in some way to not try to go to index 100 when it's not there in your string. And yeah, we're gonna build that in. We're gonna bake that into the code, so it's gonna be all good in this neighborhood. So the last part is that input will be lowercase with no spaces. So you don't have to handle any weird input. Very good, very good. So a good thing about strings, to be able to do this exercise, a good thing about strings in C++ is that they are mutable. You can change the content of a string. So I can just take the string that I get and I can uppercase it in place. I don't have to create another string like I do in some languages, or have to build a string like in Java or whatever. So it makes it a little easier where you can just modify the string in place. So as is commonly done, to solve this, I'm gonna loop through the string, and for each character in the string, I'm gonna loop through the list of the vector of indices, and if the index of this string matches one of these indices, I'm going to uppercase it. That's really how it's gonna go. Yeah, so loop through the string, then loop through the indexes, and if the index of the string matches one of these numbers, I'm going to uppercase. That is a simple explanation on this one. So I'll just list it out a little bit. Loop through the string, less than s dot length. Yep. So I'm looping through the string, and then what I'm going to do in an inner loop is loop. I'll just do the short way. Loop through indices, and I think the second argument here is a vector. Let me I'll make it a little bigger for y'all in case you can't see. Yeah, you loop through the indices, and so another loop, and I'll do a size t. I remember I get errors sometimes, or warnings, when I don't use a size t and compare that to the size of a vector. All right, I'm getting crossed up here. IDX s dot size. Yeah, the vector's name is IDXS. And J plus plus. So here, yeah, I'm looping through the indices. Maybe I'll do a little separation. This will be a fairly short exercise, I think. Okay. I'm all about the spaces. Okay. So what happens here is if the index of S matches really a value, whoops, if it matches a value, then we found this index in the original string, and then we can modify it. This is actually the logic that can keep you from indexing using a number that's not in, or an index number that's not in your string, because we do a match where we loop through the possible indexes, and if the index in the string doesn't match an index value in the vector, then it ain't gonna go. So if there's no 100 index in my original string, I'm gonna be safe here. So getting back down to line 11, I'm gonna do an if statement where I'm gonna say, you know, if the element of IDXS, which is that at index j, if that value equals I, which I is the index that I'm in the outer loop, which is the index of the current character. Yeah. If it matches, then I'm going to uppercase this character. Uppercase, uppercase. And because strings are mutable in C++, you can just say, you know, this element equals this, and it changes. Yeah. Once I do this uppercasing, I'm going to break, because once I found a match on this particular turn, I don't need to keep looping through the indexes, I think. I don't know about duplication or whatever, but this will work. So inner loop's good, I think. Outer loop is good. I think everything's good, because that is going to match the characters at a certain index to the indices to be uppercased. So then we just return our string. And I will test it. Looks good there. Let's look at our error. Is it size T? Yeah. Yeah, I don't know if length is a size T or not, but anyway, it works. Attempt. All right. Accepted solution. So what I'm going to do here is try to get this on one screen. So if you guys want to pause and analyze, you can. Well, yeah, it's pretty much on one screen. If I make it a little smaller. There we go. Yeah, if you all can see that, you can analyze it. So yeah, loop through the string. For each character in the string, I do a full loop through the indices, and then if a value in the indices matches the current index of the string, I will uppercase the string at this certain index, uppercase it, and then leave, or really leave the inner loop for the next character. So this is the solution to index capitalization, and my name is Dean. I didn't say my name before, but it don't really matter. You got a solution, you saw some code, you saw an explanation, and I am out. See y'all on the flip side. All right. Here we are with another Code Wars exercise. And this one today is sum of digits digital root. Here we got that right here. And you may be asking, what the hell is the sum of digits digital root? Well, let's look at the explanation here. What we got here, it says a digital root is the recursive sum of all of the digits in a number. Going further, it says given n, take the sum of the digits of n. If that value has more than one digit, continue reducing this way until a single digit number is produced. So looking at the examples down here, what you really end up doing is you start with usually a multi-digit number, and you're going to get the sum of the digits until a one-digit number is produced. So we look at, let's skip down to 942 here, because this is a decent example. 942, we break it apart into 9, 4, and 2, add them up, 9 plus 4 plus 2, and we get 15. Then we take 15, break that apart into 1 and 5, and then we get 1 plus 5 is 6. 6 is one digit, so it's done. And if you look at all of these examples, the end result is one digit. Yep. So they all eventually reduce to one digit. So that's going to be the objective here. This is a cool one because it brings up a kind of a classic algorithm in sort of the beginner space in programming, which is this algorithm answers the question, how do you take a multi-digit integer and break it apart into the individual digits? So I'm going to break apart from this exercise before I actually get into the exercise and show you guys just the algorithm to take a multi-digit number and break it apart into single digits. And then we're going to use that algorithm to go ahead and solve this problem, because it's useful to understand the algorithm by itself and then go ahead and use it to solve the problem. So I'm going to bring in PyCharm over here. Our trusty PyCharm. That's how I'll do it, really. So let's think about the idea of taking a multi-digit integer and turning it into a list. And I'm using a list because it's a convenient way to have separate things in a data structure. And then I can, of course, use that for whatever I wanted. In this one, we're not really going to use a list in the problem, but just want to show you how this is done. So let's say we have an integer x, and we'll do multi-digit. We'll do 5432 as our multi-digit number. And so how do you break this apart so that you can isolate the 5, the 4, the 3, the 2 for whatever purpose? Well, I know what doesn't work. Converting to a list does not work for integers. You know, if you try to do something like this, lists, I'll run this and I will get that error message. I don't know if you guys have ever tried to do that, but you cannot convert a integer into a list. It don't work. So what you're left to do is use sort of a mathematical algorithm to do so. And really what we can do is we can loop and isolate the digits through a mathematical process. And here it is. Actually, what I'm going to do first is create a list to hold the numbers. So I'll just call it a list digits. empty list. Then I'll do while. What I'm going to actually end up doing is I'm going to tick off, or that's a strange sounding thing. I'm going to basically, I'm going to pull, starting on the right side, I'm going to pull the digits one by one off of this number until it's 0. I'm going to start by pulling off the 2, then the 3, then the 4, then the 5, until it's 0. And really the way to do it, well, I'll show you here before I explain. Append, and then a way to isolate the digit in the ones place is to do a modulo 10 on a number. If I do x modulo 10, it's going to give me a 2. It just so works out that when you modulo 10, you get the ones place of a number, meaning the number all the way on the right side. You get the ones place. I'm going to take that and I'm going to append it to my list of digits. And once that's done, I've got my 2 isolated, and then I am going to I'm going to actually remove the 2 from the multi-digit number, so then when I loop around, I can get the next number. So I'm going to do this operation to remove the what this line in effect is going to do, it's multiplying the integer, sorry, it is dividing the integer by 10, and that is going to remove the number in the ones place from the number. So on the first turn, doing line 11, it's going to produce 543 because the 2 is going to be removed, and then it'll loop back around, and then we'll do the same process with 543. Yes, yes. And see, this process will continue until it's 0. It's going to take off the 2, then the 3, then the 4, then the 5, and it'll be appending before that. And really what you're going to get in the resulting list, it's going to be 2, 3, 4, 5, because the numbers are coming off from the ones place, so they're going to be coming out in backwards order, basically from the original order. And so let me go ahead, didn't mean to kill all of that, but I guess you guys can rewind if you want to see it again. Oh well. I am going to print my digits list. Whoops. Digits. And we should have 2, 3, 4, 5 as our result. Yeah, 2, 3, 4, 5. Now you see the digits of 5, 4, 3, 2, they are now isolated in a list. And then I could take these, and if I wanted to get a sum of them, obviously I easily can, but this is how you can isolate the digits of a multi-digit number. And this is a useful algorithm in the kind of beginner exercise space. You're going to see a lot of exercises and assignments that where you're going to incorporate this. So yeah, make note of it and remember it, and play around with it, because it's super useful for this thing. Now, if I wanted to just, of course, wanted to have the digits in original order, I just reverse the list, hitting the list reverse function, or, some other means. List reverse is pretty easy though. But yeah, so I can do that. So now that I've covered this, I can now take this idea back into the code wars exercise. So got a little aside there, but now let's dive into this. And I also didn't tell you guys that this is a Python. I'm doing Python today, so kind of got ahead of myself and just got into the code, but oh well. Yep, Python. So let's get into the training interface. Dive in here. And so, already explained the exercise. The objective is to take a number, break it apart into its digits, add them together, get the sum, and see if the sum is one digit. If it's not, loop around, do it again until it's one digit. So I got my header here, so I'll dive in and get started. I'm actually going to use a list to hold the digits. So I'm going to create an empty list to begin. And then I'm going to start right away in isolating the digits. I think I can say that. While n is greater than 0. And I'll do pretty much the same algorithm that I had before. Modulo 10 to get the ones place. Then I will remove the digit from the number. And then, let's see here. What I gotta do is, so yeah, once I get this to get it all together, I'm gonna get the sum. Whoops. And so, what I'm going to actually do here is I'm going to recurse because not curse, I'm going to recurse. See, I'm going to use recursion because part of the definition says the recursive sum of all the digits in a number. So it kind of gives you a clue that you could use recursion possibly to solve this problem, because what I'm going to do is I isolate the digits, get the sum, and then if the sum is not one digit, then I'm just going to do it all over again. So recursion kind of fits into that. And if you guys don't know what recursion is, it is a function calling itself. So I'm going to call the same function that I'm creating over and over again until I get my desired result, which is a one-digit number. So moving on here a little bit, once I've got my sum here, I am going to do a conditional statement, which will also end up being the base case for the recursion. And you know, some of you guys may know what that is, some of you don't, but in recursion you got to have a base case or an ending condition of the recursion so that your recursion actually stops. But anyway, I continue. So if my sum is not, or actually not, I'm misspeaking here. If my sum is less than 10, meaning if it is one digit, I'm going to return it. If it is not one digit, I'm going to call my same function again. Yeah, interesting here where, what is going on here? Yeah, so yeah, this conditional is worth isolating a little bit, where up to here, you know, the while loop and getting the sum, I've got my sum of my digits. then down here in the conditional area with the if and else, I say if the sum I got is essentially, if the sum I got is 1 digit, then I'm going to return that 1-digit sum because it's the ending condition. But if it is more than 1 digit, I'm just going to call the same function again and do the while loop over again to further, get to drill down, I guess, recursively and get that 1 digit eventually. So when I call this function again, I just go right back to here with my new number and do it all over again. So let me erase all this stuff. I feel like John Madden here, Telestrator. All right. So I think that's that, really. This should work unless I've mucked up some variable naming. So let's go down here to the bottom right and do a test. Oh, pass the tests. And then you do the attempt to pass the real set of tests. And that passes. So very good. Got my digital root completed. And I'm going to make this a little bigger, so I should have done that originally so you guys could see, but I ain't redoing the video, so but anyway, you guys can see it now, where a quick little run through of this again is take in a number, make a list, an empty list, and then with that multi-digit number, while it is greater than 0, I'm going to get the digit in the ones place, put it into a list, take that digit off, loop back around for the next or the remaining digits, do it again for the next, and remove again. Once that loop is done, I'm going to get a sum of the digits. Then if the sum is less than 10, meaning it's a 1-digit number, return it. Otherwise, I'm going to call this function all over again. And yeah, so also I think with an alternative to doing the new sum less than 10, I could also do, I think, if the sum modulo 10 is not equal to itself, something like that, then it works. But I'm not going to try that. This works, so I'm going to go with it. All right, so this one works, and I did a pretty beefy explanation. So I'm going to bail out of here. So y'all have a good day. I'm done with this one, and that is it. See y'all later. Yep, we're back again. Hope you all are having a beautiful day. I know I am. Once again with Code Wars, and today's look is counting duplicates from Code Wars, and I'm going to do this one in Python. I know it sounds kind of weird, kind of resetting myself here a little bit, but yeah. This is going to be a Python exercise called counting duplicates. Let's dive into it real quickly. Count the number of duplicates. Write a function that will return the count of distinct case-insensitive alphabetic characters and numeric digits that occur more than once in the input string. The input string can be assumed to contain only alphabets. Not sure what that means, but well, I do know what it means, but it's kind of a weird wording. Assumed to contain only letters, really, upper and lower case and numeric digits. So the string's only going to contain letters and digits. So, count the number of duplicates. Looking down at the examples here, taking a minute to look at that, really what you got to do is you're going to get a count of the characters that have duplication in the string. Look at the second example here. It's a pretty good one, where you have two A's, two B's. You get a 2 from that because A is duplicated and B is duplicated. It's the number of characters that have duplication in the string. I know there's a lot of ways to word this and think about it, but that's kind of a way to think about it. The number of distinct characters that have duplication. Looking at this next one, double A, B, uppercase B. This is a case-insensitive exercise. So the two B's, lower and upper, these count as duplicates because we're supposed to be insensitive to the case. So two B's are two B's. So it means the B's are duplicated. Looking down at indivisibility, you see you have a bunch of I's in it. And so, and there's no other character that appears more than once. I occurs 6 times, but we're not counting the number of occurrences of a certain character. We're counting the number of distinct characters that have duplication. And I is the only character that has duplication, so we would return a 1. Only character that has duplication. So it's really how many characters in the string have duplication. And yeah, getting into these exercises, it's really all about attention to detail, where it's like you got to key on the details or else you're not gonna come close to a solution. Let me erase the writing here. So then it's like, what's the approach here? So, whoops. The approach that I came up with is to really, I'm going to use the data structure of sets to find duplication here, where I'm going to turn the string into a set, removing all duplicates. Then I'm going to loop through the set to find how many duplicates of a distinct character are in the original string. And then I'm going to count how many there is. So I am going to, but yeah, actually, before I get into this, I'm going to show you guys how, really what I mean about using a set to kind of, as a duplication remover. And if you haven't been introduced to this idea, it's a very useful one in Python, where, and I'll bring in PyCharm here. For instance, let's say we've got a list that has some duplication in it. So we have duplicate 1s, duplicate 3s, duplicate 2s, and duplicate 4s. Actually, everything is duplicated in here. I'm going to use the set function to remove duplication, because the set data structure in Python, it does not allow for duplication. So when you convert something to a set, it removes the duplication from the structure. So if I do this, call the set function on the list, and then I print that set, you will see that the duplication is removed, just 1, 2, 3, 4. And I can take it and turn it into a list by using the list function. And then print that one out. Turn it to a list. And then I have a list with no duplication. So you take a set, or take a list, call set, remove duplication, turn it back into a list. I'm going to employ this to do the solution where I'm going to create a set from the string, because you can also turn strings into sets. I'm going to turn the string into a set, loop through the set, and then for each item in the set, I'm going to get a count of that character in the original string. So it'll be like how many A's, how many B's, how many C's, and for any count that is greater than 1, that means there's duplication. So then that will count as a duplicated character. Let's get into the code. Get back into the I almost said PyCharm. Get back into the codewars interface here. And I'm getting a duplicate count. So I got to store that somewhere. So I'm going to create a variable to store the count. Make it equal to 0. And because this is going to be a case-insensitive kind of search, I'm going to remove different cases or from the string, really making the string all the same case by just converting it to lowercase. So I'll do this. This really just makes it so that as I'm going through, there's no different cases. So the string will be case insensitive, basically. I'm not going to have to differentiate. It'll be good. Next, I am going to create a set from this string, because I'm going to then loop through that set and then find out how many of each distinct character is in the original string. And I'll do a for each loop through the set. And then for each character, so S is going to be a character from the set, I am going to get a count of that character in the original string. So, and I'll put it in a conditional. I'm going to say, if the count of this character in the original string is greater than 1, I'm going to increase my duplicate count, because let's look at the possibility of A. Let's say if let's look at this string. If there's more than one A in this string, I'm going to increase my duplicate count. Well, there is more than one A, so I'm going to increase my duplicate count. And then I would go to B, because B would probably be the next letter in the set. Going to use the count function. If the count of that character is greater than 1, I'm going to increase my duplicate count. Because that means there's duplication, so I'm going to increase the count. And that is really all there is to do. There's not much more to this thing. I'm just going to return my duplicate count. And we're good, because this loop, for each character that is duplicated in the original string, it is going to increase the duplicate count. And once I've got that full count, I just return it, and good to go. Great, passes there, passes there. Impressive, absolutely. So yeah, that was a pretty short and sweet solution here, and sort of made possible by using the set to take out the duplication and then looping through the set and comparing each character in the set to the original string, and if that character from the set occurs in the original string more than once, increase the duplicate count, and then I'll have a count of how many duplications are occurring in the string, and then I return that. Good to go. Exercise solved, solution done. And with that, I'm done. So talk to y'all next time. We are out. Yeah. Back in here like swimwear on this beautiful fall day. What's up? Another Code Wars exercise, and this is find the vowels, and gonna do this one today in C++. Instruction wise, it says we want to know the index of vowels in a given word. For example, there are 2 vowels in the word super, the second and the 4th letters. So given a string super, we should return a list of 2, 4. So looking at the examples, the idea is you get a string and you return the indices of the vowels, but there's a little bit of a catch because the indices you give are not 0-based indices. They are 1-based. So you may end up doing a +1, and that's really what I'm going to do. Let's look at yo mama, my favorite term, of course. And also the vowels include Y. That's another thing. So a lot of these exercises don't include Y as a vowel, but this one does. So you look at yo mama. The Y is included as a vowel, and you see a 1 here. You know, normally, of course, this is index 0, but in this exercise, it's index 1, and the O is index 2. So not 0-based. These are 1-based. And another thing here is that it includes upper and lowercase letters, so we've got to accommodate for that. So we do have some uppercase drama where we've got to match vowels in the uppercase as well as the lowercase. So with that intro and those instructions, I'm going to get started on this one. Got my function set up over here. They're nice enough to give me a vector already, so I'll use that vector for my return stuff. What I'm going to do first is create the set of vowels. I'm going to create lowercase vowels, A-E-I-O-U-Y and Y. Yeah. Because I've got to match uppercase and lowercase. And so, yeah, I'm going to use this string of vowels to match against the word that I'm going to loop through. What I'm going to do is I'm going to loop through the characters in the word, then loop through the string of vowels, and if the character in the word matches one of the vowels, I'm going to record the index +1. That's what I'm going to do. So I'm going to first start. I keep always saying first, but I'm going to do this, and I'm not going to use int. I'm going to use size t. Size t is an unsigned integer type. It's going to loop through the word. Is it? Wait a minute. Word size. Yeah, word is a string. Is it? Yeah, coming in as a string. Just verifying here. Well, size t will work as well. And it's word I++. All right, coming in here. And I'm looping through. So yeah, these are both strings. I'm just kind of resetting myself here. Inside the inner loop, I'm going to check for equivalence. If this character of the word equals one of the vowels, I am going to add it to my vector. Didn't say much about this, but this vector that they provide here with the exercise, I'm going to store my indices in the vector. So I'm going to do that via the beautiful method pushback, oddly named in my opinion. And so I'm gonna append or push back the index, but the index or the indis, it's kind of funny. It's going to be the index plus 1 because we're not 0 based, we're 1 based. So we're going to go plus 1. So I'm going to do that. And at the conclusion of these two loops, I'm going to have my indexes or indices plus 1 to return. And the return statement's already here, beautifully provided by the author of this exercise. So this might be good enough to go. Looks good. With the test and try the attempt. Yeah, looks good. All right. Well, that puts a wrap on it. Looks good, works. You guys take a look at the code, do your own better version, and tell me about it. Or not. It's up to you. But hope you liked it. And with that outro, I am out. See y'all later. What up, what up, what up? Bring it from the bottom. Thank God it's Saturday. No, I'm not Eric Thomas. I'm here back with you with another exercise to check out here. Today we're looking at count the divisors of a number from Code Wars. Once again, this is a Python exercise. You see good old Python right here in the selection. And yeah, this is count the divisors of a number. This is a pretty simple exercise, and it'll be a pretty short one, but you know, it's good practice for some of y'all out there. Maybe good practice for me explaining it. Looking at the explanation here, or the instructions, really you can just really drill down into the examples, because this is a simple enough idea where, given a number, we're going to count the number of divisors in that number. Basically, the numbers leading up to that number that are evenly divisible, I guess, by it. Or I don't think I said that right. But these are the divisors. It's still pretty early in the morning here. For 4, we got 3 divisors, 1, 2, and 4. For 5, we got 2 divisors, 1 and 5. So the divisors will always include 1. You know, everything is evenly divisible by 1 and itself. So actually that's another point where we're going to include 1 and the number. So this is inclusive, because sometimes when you get divisors, it's going to be like the in between. Maybe it's 1 up to the number not including, or the numbers between 1 and whatever. But this will be, I guess you could say, all inclusive. So you get the divisors, but really you're just counting the divisors in this situation. So we're counting the divisors and returning the number of divisors. We're not actually returning the divisors themselves. I will erase here. Is it working? Yeah. I'll start with this code, because this will be, I believe this one will be kind of short and sweet. So get my cursor back here. Going over here into the work area. I'm going to first create an integer to hold the count. Make that equal to 0. And I got one more thing to erase over here. Just want to tidy that up. Housekeeping. Oh yeah, I'm gonna make a count equal to 0. And then I'm gonna do this in a while loop, because I feel like while loops are, well, in Python, the while loop, the condition is very configurable, whereas in the for loop, the condition's not configurable at all. So really for this, you got to use a while loop in Python, because we're going to loop and get the divisors, of course, right? So with while, you've got to kind of manually set your I, your iteration variable to something. So I'm going to start with I is 2, because I already know that 1 is going to be a divisor, so I don't even need to get 1 as a divisor. I can just start with 2 and see if 2 is the divisor. Start with 2, because 1 is already a given. And also because of that, I remember my count is going to start at 1, because 1 is already a given. Meaning that 1 is a divisor already, so we can always start our count at 1, because that is for the number 1. Number 1 is already going to be a divisor of everything, so our count can start at 1, and I can start at 2, because we don't need to check if 1 is the divisor, because it is already. So we'll start the while loop, and we'll loop while I is less than or equal to n. N being the argument here, of course. And the equal sign is here because we want to be inclusive. Remember I said inclusive. We want to include the number itself, and really thinking here, we already know that the number itself is going to be a divisor. So I could actually just tack it up to 2, count up to 2, and then make the equals not equal, or like that. That's what I mean. I'll just go ahead and do that. And see if this works. Okay, so how do you find divisibility? Divisibility is found with the modulo operator. Remember the modulo is the remainder of a division between two numbers. Well, if you do a modulo operation and the remainder of the division is 0, then that number is divisible. So we can set up a condition for that. You guys love the typing sounds, I'm sure. The type of the keyboard is pretty close to the microphone. So yeah, our number n, if n modulo 1 is 0, meaning if n divided by I is, if n divided by I there's no remainder, then it is divisible. And if it is divisible, I will increase my count by 1, because that means it's divisible. No need for an else, because if it's not divisible, it will take no action. What is left is to increment I by 1 so we continue the loop. This is a common thing that some people forget, where if you don't have this, you will have an endless loop. I'll put a little comment there, little question mark up there. And this is pretty much it, because once this loop is done, we've got our count of divisors. And I will just return this sucker and see what we got. Oh, this is funny, yeah. I wonder if you guys caught that. Coming back and forth between languages, I was doing C++ or Java instead of Python, where I was declaring my data type, where I don't need to do that in Python. So I wonder if you guys caught that early on. This has been sitting there for a while. We all make mistakes, hey. All right, 2 should equal 1. Yeah, I forgot about this, because I think this would be in the case of 1. So let me change that. I think if I change this, this will be taken care of, because this failed because of 1, and you don't want to count 1 twice, you know, so you guys figure it out. All right, that works. I'm the teacher, right, and I'm telling you to figure it out. But I'm a little pressed for time, so can't explain it all. You guys can sign up on my program if you want a full explanation of what I just did. Alrighty, that's a good one, and that's done. And I'll do an erasure real quick. And yeah, there's a complete solution. Got the green, so we're good to go. Got the dopamine hit, ready to go, ready to face the day. You guys have a good one. I'm out of here, and this is another exercise. Toodaloo. See y'all on the flip side. Yeah, I'm back. Once again. What's up, people? Next, I'm going to do a code wars exercise called disembowel trolls, a very pleasant sounding exercise. Code wars exercise in Python here. This one's got one of those amusing backstories. Trolls are attacking your comment section. A common way to deal with the trolls is to remove all the vowels from the trolls' comments, neutralizing the threat. Your task is to write a function that takes in a string and returns a new string with all the vowels removed. And then they give an example right there of this string incoming would become this string. Essentially, you're just removing the vowels from the string. So, and Y is not a vowel. So that's really the task here. It is take an incoming string, remove the vowels, and then return the string without the vowels. Everything else is intact in the string as you see here. So that's what we got to do. Yep. So, you know, it's a little on the simpler side. So this should be a pretty quick one. So I'm going to go right into this editor area. And so the task is to remove the vowels from the string. The incoming parameter or argument will be this string. And I'm going to go through it, remove all the vowels, and keep it moving. So what I'm going to do is I'm going to create a string for the destination string, because I'm going to loop through the string and copy the non-vowels to the new string. So I'm just going to call this new string, new string. Absolutely. I'm going to make it empty right now because I'm going to populate it with non-vowel characters as I go. And really what I can do is just go ahead and start looping. So I'm going to use a while loop for this, I think, just because I feel like it. I could use a for loop, but while loop is fine. So I'm going to start my I iteration variable as 0, because I'm going to use I to loop through the entire string. And I'll do the while setup. I'll do I less than the length of this string. I don't know why there's an underscore at the end of this string, but I'll keep it. And so in the loop, what I'm going to do is I'm going to copy over the non-vowel characters. So I'm going to create a condition here where I'm only, I'll say basically, if this character that I'm isolating is not a vowel, then I'm going to copy it to the new string. And here's how I'm going to do it. I'm going to use an if statement. I'm going to say if this this character, which is string index I, if that character is not in this string of vowels, and I'm going to do a string of vowels that contains the lowercase vowels and the uppercase vowels, because as you see over here, this includes uppercase and lowercase, so you've got to handle uppercase and lowercase. So I want to exclude lowercase and uppercase vowels, so I'm going to do it like that. So see, Python creates this kind of cool shorthand syntax where you can just kind of, you can search for something in something else by doing in or not in. So it's very, it's easier. So I can just say if this character is not in this string, do something or don't do something. In my case, I'm going to do something. If this character is not in that string, I am going to copy it to my new string via concatenation. Love the word concatenation. Sounds like a dance or something. And yeah, I'm going to concatenate this character to the new string, and my return statement's already here, so that's all good. And this sucker is good to go. I believe. I'm going to test it. Oh, I made a mistake. Can you spot the mistake? A common mistake with the while loop. I did not increment my I. So I get an endless loop. So I got to do my I plus equals 1. Rookie mistake. Oh, okay. What did I do here? Oh, I'm returning the wrong thing. Hopefully you guys caught that. Yeah, I'm returning the original string, of course. So gotta correct that. And there we go. Because, yeah, the new string is the so-called modified string. And I gotta return that instead of the original. Why do I, yeah, I'm not gonna return the, you guys get it. I don't need to explain it. Tested, attempted. Yep, we good, we great, outstanding. So we can move on from this little evolution, this challenge, because we got great, and we are good to go. Outstanding. Happy night, happy flight. Good stuff. All right, that's it for me. Hope you liked it. I'm out of here for today, and enjoy your day. See you later. Okay. Gotta love that intro. Love it. It's fire. All right. Today, gonna look at an exercise called vowel count from Code Wars, and this is an exercise that'll be done in C++. If if you're wondering about the language. And I'm going to keep it on the easier side today for y'all. Going to go more on the fundamentals route. So that's how we're going to do it. And so explanation-wise, it says, return the number count of vowels in the given string. So the assumption is that you're going to return an integer containing the number of vowels in this string that you're given in the function. We will consider A, E, I, O, U as vowels and not Y. Who considers Y a vowel? Weird people. And the input string will only consist of lowercase letters and or spaces. So you don't have to deal with any uppercase drama. Good stuff. I can get right into the code because this one is not going to be that complex. What I'm going to do is, overall philosophy-wise, I am going to loop through the input string character by character, and then I'm going to do an inner loop, a nested loop, I guess you could say, where I'm going to go through every character that's a vowel. So I'm going to make a string of vowels. I didn't really explain that well, but I'm going to go through the input string character by character, and then in the nested loop, I'm going to go through a string consisting of the vowels. I'll be comparing each character in the input string to each character in the vowels, and if there's a match, I'm going to increase my count. Yes. So first thing to do is create a string consisting of the vowels, A, E, I, O, U. You can put them in whatever order you want, doesn't matter, but it kind of, you may naturally put them in that order just like me. So then I'm going to make my loop, my outer loop, and in this outer loop, going to loop through the input string, if I can type it all correctly. So in this outer loop, I am going to, for each iteration, I'm gonna isolate on one character of the input string, and then I'm going to take that one character to the inner loop, and in the inner loop, I'm going to compare that one character to each character in the vowel string, and if it matches one of those characters, I'm going to increase my count of vowels. And I didn't say this before, but line 6 contains an integer variable called numVowels that will hold my vowel count. So back into the inner loop, vowels. Yes, the inner loop, of course, going to use a different variable, and I'm going to loop through the characters in the vowels string. I'm going to do a conditional statement here, an if statement, that's going to say if the current character of the input string equals the current vowel that we're on, then I'm going to increase the count of vowels because I've found a vowel. Input str index I equals vowels index j. Index j there is very important because in the inner loop, the j loop, I'm going through the vowels. In the outer loop, the I loop, I'm going through the original string. So yeah, if these match, then I'm going to increase my count. And I'll do plus plus. I can do plus plus or plus equals. I'm going to do plus plus in honor of C plus plus. There we go. Okay, looks good for now, or not for now, maybe forever. So yeah, outer loop, inner loop, comparison. If they match, do the count. And once the loops are done, my correct count will be in numVowels, and I return that because it says right here, return the number of vowels in the string. So let's test this one out, see what we got. Oh, I am using the wrong kind of quotes. I go back and forth between languages and I forget that. And what? Num count. These are the things you encounter when attention to detail is not followed. All right, we passed the tests. Now let's pass the attempt. All right, good stuff. Passed the attempt. Outstanding. So yeah, here's your code. So you guys can take that to the bank, try this one out yourselves, and see how much better you can do than I did, because this is far from the most efficient or best solution. So y'all give it a try and see what you can do. Maybe place it in the comments. I don't know if I ever get comments. We'll see. But that's it for me. Till next time, we out. Yeah, I think we are back. It's been a while. Maybe it hasn't. Who knows? But we're back. And I'm looking at today, highest and lowest, a Java exercise from our friends at codewars. Absolutely. So in this assignment, you're given a string of space-separated numbers, and you got to return the highest and lowest number. So looking at the samples here, we have method name and we have a string with space separated numbers, and we must return the highest and lowest, where it'll be in string form, highest space lowest. Notice here the input is in string form and there's numbers in there, and we're going to return it in string form with numbers in it. So somewhere in that process, we got to convert these to integers so you can evaluate them as numbers, because the idea is to return the highest and lowest. How do you determine that in string form? Yeah, you can totally do that in a way, like with the ASCII conversion and all that, but not going to mess with that. Going to instead use turn them into integers and do it that way. I know there's a text way to do it, but blah blah blah, not going to do that. I've already got my method together, so you guys can do other stuff on your own. It is a free country, at least today, and the one that I'm in. I understand that other people may be watching from other countries, but hey, whatever. Let me get this thing started. So over here in our training area, the editor area, I'm going to throw up some variables. I'm going to make integer variables for the highest and lowest because I'm going to store them in there, and then I'm going to return them as strings later on. So I'm going to create some variables for highest and lowest. And what do I make these equal to? Well, I'm going to do the classic find minimum or maximum of a data structure algorithm. So when you do this algorithm, if you're trying to find the max, you set it to a very low number, and when you're trying to find the min, you set it to a very high number. In Java, we have these constants in the integer wrapper class called min value and max value. So I'm going to set highest to integer min value. I'm going to set lowest to integer max value. And the idea being that, so let's take lowest for instance. If I'm trying to find the lowest of a, the lowest value in a data structure, if I can speak, I make this variable the highest it could possibly be, and then as I go through the structure item by item, I compare the lowest variable, the contents of it, I compare it to each number. If that number is less than my current lowest, I will assume it. So like as you go through here, if you compare lowest, which is right now the highest possible value, if I compare it to 1, is 1 less than the maximum possible value in Java? It totally is. So lowest will assume it, and the lowest will be 1. Then I go to 9. So lowest is 1 right now. If I compare 1 to 9, 9 is not lower, so it's not. So then I go to 3. Is 3 lower than 1? It's not. Is 4 lower than 1? No. -5 lower than 1? It is. So then lowest would be 5. And you go through all of them sequentially and you find the lowest. So there's a little kind of quick brush up on this algorithm. And yeah, I'm going through it pretty quickly and not showing you any visuals, but if you got that, you got that. Maybe you know it already, but you're going to also see it in code. So I'll keep it moving. Okay, so I'm going to create a string for my final output. I'll call it final string and make it equal to an empty string. And then when you look at this input right here, it is going to be numbers separated by spaces. So because it's going to be numbers separated by spaces, it is an ideal thing for splitting. My method here is I'm going to take this string, split it by spaces, so I can access each number by itself, and then I can compare it to highest and lowest to find the highest and lowest. And I know I'm glossing over stuff because this is kind of a quick video. And so get over here. Numbers.split. Yeah, so the string here is going to be called, or is called numbers. And I am going to use the split function, or method actually in Java. I forgot that. Yeah, these are methods in Java. I am going to split the string into an array of strings. And then I'm going to go through that array of strings one by one and find the maximum and minimum values. And I am going to loop to do so. So I think I already said loop, but here's the loop. It'll be length without parentheses because it is an array. All right, so in here, I'm looping through the array of strings, and these are numeric strings. For each one of these, I'm going to make them an integer, and then I'm going to compare them to highest and lowest to see if they are the highest or lowest. So I'm going to create an integer. I'll call it temp and or TMP. I'm going to convert it to an integer. Parse int. There's a few ways to convert to integer in Java, or Java as the Rastafarians call it. Alright, so now I've got it as an integer. Temp is integer representation of one of these values. I'm going to compare this value to the highest and lowest and see if it's greater than or less than, depending on which one I am comparing it to. So if it's greater than highest, highest will become it. It will assume it. And I can sort of copy this a little bit, even though the variable names aren't the same. I could say if it's less than lowest, then lowest, oops, lowest equals it. Yeah. See, a little run through is get it, turn it to an integer, and if that integer is higher than my current highest value, my current highest value is going to be it. If it is less than my lowest value, then my lowest value is going to be it. This algorithm is all about assuming. It's like if you find something closer to what, or if you find something less than or greater than the highest or lowest, it assumes it. That is a terrible run through, but you know, maybe you guys can pick it up a little bit here. All right, so having gone through here, when the loop is done, the highest value is going to be in the variable highest, and the lowest value is going to be in the variable lowest. So what I can do then is return a string representation of these two, just like you see over here, where the highest and lowest. I'm gonna do that. Code right here. So these highest and lowest are integers right now. So I'm going to change them to strings. It'll be highest, and then concatenation, so yeah, it's supposed to be highest space lowest, so I'm going to do that right now. And I think that is my return set up, and looks okay. Looks like I cannot expand this, so I'll kind of scooch it together so it can be seen in one piece here. I think this does it, so I will test it out. Looks like it does, and I'll clear up my drawings. Test passes. Let's look at attempt. Alrighty, I'll allow the oxen free. That's good. We got this. So there's the completion of the highest and lowest in Java from codewars. I enjoyed it. I hope you did. And that's it for me. Gotta bail out, gotta pay some bills, so I am out. All right, once again, we're back. Thank God it's Monday. Maybe it's not Monday where you're watching from or when you're watching it, but 1 out of 7 chance. We'll see. It's Monday right now. Okay. The exercise today is break camel case from codewars.com, and it is a Java exercise. So flexing the little Java skills today. This one's on the simple side. The exercise is to complete the solution so that the function will break up camel casing using a space between words. And generally what camel casing is uppercasing uppercasing the first letter of each new word. It really is camel casing. And there's camel casing that'll start with an uppercase letter in the beginning, and there's camel casing that'll start with a lowercase letter in the beginning, and all subsequent first letters are uppercased. So like it could go something like this, where it's like uppercase to begin, and then the next word uppercased again. Or we could do where we start lowercase in the beginning, kind of like this one, and then uppercase each subsequent. There's a variation. But getting back to the idea of the exercise, what's supposed to be done is break up the camel casing, putting a space between words. So in the case of this one right here, where you have camel casing, of course the second word is camel cased, and the idea is to put a space there in between the words instead of having them be one word. We're breaking camel casing really by putting spaces in between the words instead of having the words joined together. The second example, we have a single word, and of course when you have a single word, you don't need to break it up. There's no camel casing here, so you just return that word as is. So it's going to be kind of a detection thing where we're going to be looking for uppercase letters in our string, and then if there's an uppercase letter, I'm going to insert a space, and then well, really I'm just going to insert a space, because after that the input ends up being the same. So that is how I'm going to approach this. Going over to the training area over here, or the solution area, I guess you could say. Got the method set up where input is going to be the string that needs to be uncamel cased. I'm going to first create a string to hold my uncamel cased output. So I'll call it this, uncamel cased. Make it equal to an empty string. I'm going to populate it with my changed string. And one of the simpler ways to do this, of course, you could use string builder and do some manipulation. I don't use string builder very much in Java, so I kind of do more of a manual way, where here I'm going to take the original string and I'm going to copy it to a new string, inserting the changes that I want as I copy. So it's like old string to new string, and then as I do the copying, I'll do the modification kind of in process. So to be able to copy from old string to new string, and uncamel cased will be the new string. Copying from old string to new string, I'm going to loop through or iterate through the old string character by character, and then copy over the pieces that I want, inserting things where I want to insert them. Yeah, that doesn't sound very good, taken out of context, but it won't be. All right, looping, and so while I is less than input dot length, and this being a string in Java, length will have parentheses after it because the string length in Java is a method, so parentheses are there. I++. All right, so generally I'm just going to copy over a character from old string to new string, but there's going to be a difference where if I encounter an uppercase letter, I'm not just going to copy it over. I'm going to insert a space before it, then copy it over. So for each uppercase letter that I encounter, also for each uppercase letter that I encounter that is not the first uppercase letter in the entire string, I'm going to insert a space, then I'm going to put that character in. It is going to look like this. Conditional statement, I'm going to say if let's say, oh yeah, so I need to check for an uppercase letter, as I just said. So to be able to check for an uppercase letter, I'm going to use the isUppercase method of the character wrapper class. Character is uppercase, and going to use charat to get the character. Charat returns, it's a method that returns a character, so it fits right in. So if that character is uppercase, another condition will be if this character is not the first character in the entire string, because if the uppercase letter happens to be the first letter in the whole string, I am not going to insert a space in front of it, because that is not a camel casing situation. That is not a situation where I'll break camel casing. The first letter of the whole thing is not appropriate to insert the space, so I have to exclude that condition from my insertion, if that makes sense. No way it does make sense, but it makes sense to me. It may make sense once you see it in the code. So how I'm gonna not insert the space at the beginning is going to be an index check. If I am at index 0, which is the first character of the whole string, I am not going to insert the space. I ain't going to do it. So if I is not equal to 0, yeah, because 0 being the first index of this string, I'll do an else, I'll do an I will do an else. I'm going to leave this block open because else will, there's something going to be there. And no, it's not else. That is another language. Okay. If I'm not at the beginning, and the other thing, I am going to, whoops, I'm going to do my copying to this other string, concatenation really, and here's the space insertion. I'm going to do a space, then I'm going to concatenate, whoops, the character at that spot. So I'm just, instead of copying over one character, I'm copying over two. One, the space insertion to break the camel casing, and then the uppercase character that really is the reason for the condition. All right, so that's done. And now I'm gonna code for the condition of the normal condition where there's no uppercase, it's just a normal copy over or concatenate over. So I will drop it here and just grab the character. That's all that needs to be done here. Return that uncamel cased. This one is ready to ship, I believe. Do a quick check. Beautiful birds outside. All right, looks good. clear out the drawing stuff and do the attempt. All right, attempt is good, the code looks good, and this is a viable solution. So try this one out yourself, see what you can do, see how much better than mine you can make it. There's a lot of better ways to do it. There's always a better way to do it in code. But with that, my time is done. So hope you enjoyed Break Camel Case. If you didn't, keep it moving. And I'll talk to you soon. Late. What I got for you all today is a look at a little program called Rock, Paper, Scissors. This is my take on the classic programming assignment / exercise / video that you're going to see a lot. I'm sure there's hundreds of YouTube videos showing someone's version of Rock, Paper, Scissors. Here's mine, and I'm going to break it down for you. As you can see, the code is already typed up, so I'm not going to be typing live. I'm just going to break it down. What I like to do a lot of times is before I break it down, I'm going to just run the code so you can see what it does. Then we'll talk about the actual code breakdown. So I'm going to run it here. Starts with, what is your move? Rock, paper, scissors. Type Q to quit or exit to quit. So with this one, I get a prompt and I type in rock, paper, or scissors, and then what happens is I play against the computer, and the computer will randomly choose rock, paper, or scissors on their end, and then they get compared, and the winner is displayed or chosen or dictated, however you want to say it. So I'm going to type in my move. My move will be rock. And you see here that I win, because I entered rock, and CPU's move was scissors. And so rock smashes scissors, we all know that. So it loops back around and asks me again. This program is designed to continually loop until you end. So until I press Q, quit, or type exit, we're going to keep the party going. So I'm going to enter paper this time. And I lose because the CPU's move was scissors. Scissors cuts paper, and there we go. So I'll do one more run here. I'll choose scissors this time, if I can spell it correctly. There we go. I lose again. I entered scissors, and CPU, which is computer, entered rock, or the move was rock. So rock smashes scissors like we saw up above. So that's that. And now I'm gonna do one of these commands to quit. I'll type in exit. And a little message there. Hope you had fun. See you later. Well, that's the operation of the program. So now let's look at the code for this one. Oh. Starting up at the top, we import random because random is going to be used to select the computer's move randomly. And the move is actually going to come randomly from this list right here. I have a list of moves, rock, paper, and scissors. And the computer's move is going to be randomly chosen from those, from that list. Then overall, I have a loop here, not a list. Get those confused with the L's. I have an endless while loop here where the entire game is going to be inside this this loop. And of course, no loop is truly endless or infinite. I'm going to be able to break out of it at spots with the break statement. So Uh, of course, it's not going to be endless, but it's set up that way. So I go into this loop, and the first thing I do is my prompt, the prompt that you saw when I ran the program. What is your move? Rock, paper, or scissors? Type blah, blah, blah to quit. So that's really the first thing that happens in the game. And what is here is input validation, really. Well, actually, no, this is not input validation. Sorry, this is the quit mechanism. So if they enter quit, queue, or exit, print my little goodbye message and break. And break is going to leave this loop. And the end of the loop is the end of the program, because there's nothing after that loop. And then later on here, have a couple of lines where I take the move that was entered via the input function. I take it and make it uppercase, because it's going to be compared against this list, and all the items in the list are uppercase, so I want to be able to match later on. CPU move, this is a randomly generated number between 0 and 2 inclusive, that is going to be used to index into this list to choose a move. For instance, if I randomly generate a 1, it's going to get paper, and paper would be the CPU's move. So it's a randomly generated integer, which is going to be used to index into the moves list. And next here, I have some input validation. This is the input validation, where if what was input, the user move, if that move is not in the moves list, meaning that if it's not rock, paper, or scissors, I'm going to print a message that says, hey, you got to enter rock, paper, or scissors, homie. And once that prompt or that message is put out, I do a continue, which is going to loop right back around to the beginning of this loop. And I'll ask for input again. So continue will go to the next iteration of the loop. Let me scroll down here a little bit. The rest of the code works out in a bunch of if statements. And the first if statement here is for a tie. Oops. Check this out. It says if user move equals moves index CPU move, then you do something. Well, let's take a look at this right here. Moves is the list of rock, paper, or scissors strings. CPU move is the randomly generated number. So this this code right here actually equals the CPU's move. It's going to be rock, paper, or scissors. And if that move is equal to the user's move, we got a tie. And then what it says is we have a tie. You entered whatever you entered. The computer's move was whatever the computer chose. And when you have a tie, well, you're just going to continue, go back around to the beginning of the loop. So there, the tie has been handled. Moving up next is the next series of if statements. Really, you have ifs and nested ifs, and they all follow the same format, really, where it's checking your move. If your move is a certain thing, it compares it against the CPU moves or the computer moves to see if you win or lose. For instance, if your move is rock and the computer move is paper, you lose, because paper beats rock. Paper covers rock. If your move is rock and the computer's move is scissors, you win because rock smashes scissors. We know that. The awesome power of the rock. So these other if statements lay out just like this. Look at the next one. If you got paper and the computer's got rock, you win, paper covers rock. You remove paper, computer move scissors, you lose because the scissors cut paper. This is how these if statements go. And then there's one more if statement down here. It's for scissors. And that's the end of the program. There's not a lot to it. To kind of recap here, it's, of course, create the list of possible moves. Create your create your infinite while loop and prompt for the move. Do handle the quitting, input validation, then we check for a tie, and then we really develop logic for all the moves. You know, if you got this and they got that, here's the outcome. So it ends up being a pretty simple process. And yes, here it is. So let me see if I can get it on a single screen in case you want to screenshot it or whatever or copy it. But here we go with this. This is a little condensed, but yeah, if I take out the spaces, I think I can get it on a single screen. At least I can get all the loop on a single screen. So there's that. And then if you scroll up a little bit, you got a couple of more lines. But yeah, this one's pretty straightforward. Rock, paper, scissors, my version. I want to see how you guys do it. Maybe you guys can take this one and spark some ideas for your own way. There's much better ways to do this. This is kind of a simple explanation way to do it, but you can condense, you can be more efficient. So try it out and let me know. But that's my time here, and catch y'all on the flip side. I'm out. Yeah, welcome back. We are back. Happy fall to you and yours, whatever the hell that means. Today's exercise is find the parity outlier from Code Wars. There it is right there in small type. Yeah. So in this one, you're going to be given a list, which is going to have at least a length of 3, but could be very large, containing integers. You're going to get a list of integers. The list is either going to be entirely comprised of odd integers or entirely comprised of even integers, except for one integer. Write a function that takes the list as an argument and returns this outlier. So I substituted some words there, function for method and list for array, because I'm speaking in Python terms. But the overall thing here is that I'm going to get a list of integers, and they're either going to be all odd or all even except for one number. Looking at this first one, we kind of can see that you got even number, sort of even number. Yeah, they're evens except for 11. 11 is the outlier. And you see there's your outlier. Looking at the next one, got 163, and looks like this is an odd type of list. So 160 being an even number is the outlier. So return the one that's not like the others in terms of evenness or oddness. That's the charge here. So the thing that comes up with this is, how do I determine in a concise way, or not even in a concise way, if a list is even or odd, dominantly, even or odd? you could loop through the entire list and count the evens and count the odds and see, what you got, which one is greater or whatever. You can do that a little wasteful. I'm going to show you two ways of doing this. What I found is that you can determine even or oddness by just looking at the first three of the list. Like, look here, the first three of this and the first three of that. Because this is really about determining evenness or oddness. So within the first three elements, you're going to be able to tell, do you have more evens or more odds? Because if it's all one except for one integer, you're going to be able to tell. Because even if that one outlier is in your first three, the other two will have the dominant trait, so to speak. So we look at 2, 4, and 0. These are all even. So we know that this list is going to be an even list just by looking at the first three. And then you look at the first three in the second example list, 160, 3, and 17, 19. You have two odds, so you know it's going to be an odd list. So I think the way to start this is just look at the first three and do your little counts and see what's if it's even or odd, and then go from there. Because once you gotta determine that it's dominant even or dominant odd, you can loop through again and find that even or odd outlier. And as with all of these, there are more efficient ways to do it, but this is the way that I put it together. You're watching me, so it is what it is. So I'm going to create I'm actually going to get a slice of this original list and just limit it to 3. I'm going to get a slice of the first 3, and I'm going to loop that slice using that good old for each loop. And I'm going to loop through these, and I'm going to actually, I forgot a piece. I'm going to count my evens and odds. So I'm going to create some variables for those. So here in the body of this for loop, I'm going to check for evenness and oddness. If it's even, evens add 1 or increase. If it's odds, increase the odds. By the end of this loop, there's going to be more evens or more odds, so I'll be able to tell if it's even or odd dominated. So once I got that done, I can kind of break it out into a conditional where if the evens are greater than the odds, I'm going to look for an odd. And I'll loop through the original list to look for odds. In modulo 2 equals 1, looking for an odd. And if I find that odd, I'm just going to return the odd because that's the end of what I want to do. I'm not sure my tabs are solid here. And then I do the kind of the same thing on the other side. So I'm sure this can be consolidated greatly, but I'm not going to think through how to do it right now. I'll leave that exercise for y'all. Yeah, so on the odd side, which is handled by the else, looping through, I'm looking for an even. If I find an even, I'm returning it because that is the outlier. So I think this is ready to run. It's ready to pull out of the oven and serve. So let me do this one. And Yeah. Definitely not ready to serve. What am I doing here? Forgetting my if statements. Because I'm thinking about an appointment I have coming up. Alrighty. Yeah, so that looks good. Of course, missing the ifs. That's a little egregious. That looks good. Then it passes the attempt. So ready to submit. I'm going to submit this one because I want to hold this solution because I haven't submitted this exact solution yet. So I'm going to submit it and then come back here, show you guys a different solution, and go from there. I'm going to submit, do the thing, and then I'm going to come right back. And now I'm going to show you an alternative to what I had there. But actually, real quick, just so you can get a look, screenshot, whatever. I don't know what you guys do, but there's the completed code for my first attempt here. I like it. I like the idea of looking at the first three. So there's that. And I'm going to paste in an earlier attempt on this one, an earlier solution really, where I just go through. You look here on the first two lines of the function, I just count up everything. So I go through the original list. I count the evens, then I count the odds, then go through count the evens, and then I do the ternary operator here on line 5, where if the length of odds is 1, wait a minute. Oh yeah. So if there's only 1 in the odds list, it means that the odd is the outlier, so I return it. Otherwise, I return the index 0 of the evens. So if the odds list only has 1 element, it means it's the outlier, and I'm going to return that 1 element from it. Otherwise, the even is the outlier, and I'll return that. So this is more concise, kind of syntax-wise, but I think the one I had before is a little more efficient. I'm not sure. Maybe you guys can let me know. But that's really it for now. I got you 2 versions of a solution. Pick the one you like and then tweak it, play around with it, whatever you want to do. I don't know what y'all do, but yeah, this is it. So I am out of here for now, and I'll see y'all later. Yeah, 3, 2, 1, go. We're back in here. Another day, another video. Yep. And today, back on Code Wars, looking at equal sides of an array. And this is a Java exercise from a good old codewars.com. And let's get into the description. You're going to be given an array of integers. Your job is to take that array and find an index n where the sum of the integers to the left of n is equal to the sum of the integers to the right of n. And if there is no index that would make that happen, return -1. Look at some examples. You're given an array, it looks like this. You're supposed to find an index where the sum of the items on the left is equal to the sum of the items on the right of the index, and you are not to include the element at that index in your calculations, or your calculations, as some people say. Looking at this example, the answer is 3 because it's index 3. 0, 1, 2, 3, 4 is the one at that index where to the left of 4, we have 1, 2, 3. And to the right of 4, we have 3, 2, 1. Obviously the same numbers on both sides, so that's going to be equal. So as it says 1, 2, 3, 3, 2, 1. So in each of these, or in this function, we got to find that index where stuff on the left, the sum of the stuff on the left is equal to the sum of the stuff on the right, not including the element at that index. Looking at the next one. The one right here in the middle. Now, given that array, reading through this, the index solution is 1, which is this one, because in that first position, the sum of the things on the left, which is only 1, and the sum of the things on the right here, they're equal. And you look at these, several numbers over here, how can that be equal? But when you break it down, you look at 50 minus 51, of course that's -1. -1 plus 1 is 0, and then 0 plus 1 is 1. So you got big fat 1 over here, and you got big fat 1 over there. So they are equal sides. So there's another one, another example, and we'll look at this last example just to kind of bring this thing home, and we will get to coding very, very soon. Scroll down here. Last one, as it says in the instructions. Looking at this one, the answer to this one ends up being 0, because when you're at element 0, the stuff on the left side is 0, because there's nothing to the left, given that you're at the first index. And the sum of everything on the right ends up being 0, so you got 0 on both sides. And I know I'm going through this a little fast, but the real kind of meat of what I'm going to do is going to be in the code, so you guys can take time to review the instructions, on your own. Yep, you're on your own, sort of. But yeah, both sides are going to be 0, because these positive and negative numbers over here are going to add to 0, and then on the left side there's nothing there, so it will be 0. And of course there will be situations where both sides, or there's never equivalence on both sides, and when there's not equivalence, you're going to return that -1. So let's start doing some code here. I think we've cleared or gone through some good examples here provided by the sensei, as they say. And yeah, the language here is in Java, so we got our little boilerplate here on the side, method header and all that. Going to be taking in an array. So, and really the strategy here, I'll type it out a little bit. It's going to be to loop through array, and then at each index, so maybe I'll just type it over here. At each index, get sum of left and right of current index and compare. That's pretty much that's the idea. As we move along, look to the left, sum it. Look to the right, sum it. If they're equal, we leave with that index. If they're not equal, we keep going. Keep the train moving. So I'm going to loop, as I usually do about this time. In Java, the length will not have parentheses for an array. Okay, going to put a lot of stuff in this for loop. Going to create an integer, or create integers. for the sum of the left and the sum of the right each time. And I'll do the camel case type joint. Okay. And so I'm going to do, I'm going to do a couple of loops in here, because I'm going to do a loop to get the sum of the left and the sum of the right. I don't know about any kind of accumulation or summing methods for arrays. Maybe they're out there. I don't know them, so I'm going to go for what I know, as they say in hip hop, and do my summon this way. This loop, getting the sum of the left, it's going to be while j is less than I, because I'm going from the beginning of the array up to before I. You know, kind of like if let's say this one is I, my j is going to start here, and I'm going to go up to, but not including I, so I'll probably stop like right here. Not probably, I would stop like right there. So hopefully y'all can see that. All right, keep moving. And sum left is going to be plus equals the thing at that index. And keep it moving with j++. And then I'm going to set up, and I got to do int over here for declaration. I'm going to set up another integer, k, and make it equal to I+1. And here I'm going to do my right side of the thing. While k is less than the length of the array, because this is going to be the right side. It's going to be from just past I to the end of the array. Sum right. ARRK increment. Yep. Looking good. So we'll do an if statement, and now we're gonna compare the sum of the left to the sum of the right. If they equal, we're gonna bail out, returning that index. If they're not equal, we're gonna keep going. And let me see where it's the beginning of the loop. Okay. So after the loop, foreclose, like foreclose on a house if you don't pay your mortgage. So after the for loop, if you go all the way through and you don't have an equivalent sum on the left or the right, it's time to, well, of course you're going to leave, but you're going to return -1 as per the instructions. So we tighten it up a little bit here, so maybe we can get more of this on one screen, or a lot of it. I think I'll have to reduce the type, the size of the type. Yeah, I will. But I believe that is all I need to do. So I'm going to run this one. Yeah, looks good there. Attempt. Looks good there. That passes. And so there is the code. Sum of the left, sum of the right. If they're equal, return the index. If they're not equal, keep looping. And if it gets to the end without finding equivalents, you return -1. I'll reduce the type or the size here a little bit, so maybe this will fit on one view. So if that can be seen, there's all your code right there. I can't expand this window for some reason, or actually I can. Here, yeah. I forgot about this. There's your code. So yes, this is it. This is the solution to equal sides of an array in Java from codewars. Had fun doing it. Hope y'all liked it. If you didn't, oh well. I'll be seeing y'all, I think. Goodbye. Hey there, what up? Yeah, we're back. Back again, back and better than ever. I think somebody else says that, who I will not mention. I'm saying it now. That's all that matters. Back here with another Code Wars exercise. This one is leap years. And yeah, it is from codewars.com, the beautiful people out there. Good stuff, good stuff. So, this exercise, yeah, it's leap years, and it's really determining, given a year for input, is that year a leap year? And really there's some criteria to determine that. Let's take a look. In this kata, you should determine whether a given year is a leap year or not. In case you don't know the rules, here they are. Years divisible by 4 are leap years. But years divisible by 100 are not leap years. But years divisible by 400 are leap years. So you got some rules there. And it shows you a little range there. Yeah, that range isn't going to matter that much in solving this exercise. But yeah, so it's kind of a logic puzzle using conditional logic, sorta. And really, you gotta just follow the rules, where it's just I'll break it down like this. All leap years are divisible by 4. So that's kind of the barrier to entry. So you really could make, you kind of make one box and say everything divisible by 4, or if it's divisible by 4, it's going to come into this box, and then there's some more conditions. So got to be divisible by 4, but there's some other stuff, because if it's divisible by 4, but also divisible by 100, it's not a leap year. But then again, if it's divisible by 400, it is a leap year. So, but really, these are the guidelines that are going to get you to success, and you really got to put these guidelines into code. That's what it is. So, do some erasures here. But the first barrier to entry is divisibility by 4. So all leap years are divisible by 4. So that's right off the bat, I can make that distinction. If year is divisible by 4, and use modulo, for the remainder joint. Checking for divisibility is typically done with modulo in programming. I'm sure most of you know that. Just saying for those who don't. And really, most of the stuff's going to happen inside of the body of this if statement, because years divisible by 4 are leap years, but there's more stipulations here. Second thing, if years divisible by 100 are not leap years, but the ones divisible by 400 are, you're really going to have two conditional statements covering these two. The placement is very important, because if you place them in the wrong places, you're going to get some incorrect assessments, or you're going to catch the wrong thing in the wrong place. Because really, all years divisible by 400 are also divisible by 100. So if you put the 400 in a conditional statement below the 100, you're going to miss years that are leap years. So we have to actually put the divisible by 400 first in order to catch those that are, because all years divisible by 400 are also divisible by 100, so you're going to shut yourself out if you have the 100 first. And now I'll demonstrate after I get the solution out. So if that mod 0, then you got a true. Now, I didn't really say this before. Well, I didn't say a couple of things. This is a Python exercise, and the function returns true or false if the year is a leap year or not. So there's that. And so divisible by 400, yes. Divisible by 100, only no. Return false. I think that says false. Yep. So those are the important ones, really. And yeah, those are obviously the important ones. What you have here is, let's say it's not divisible by 4. What's the alternative? If it is not divisible by 4, the year, it's not a leap year. So the else to the if would be to return false. Falsetto. Yes. And I believe that is it. So let's run this and check it out. Aha! We have incorrectness. Oh yeah, I forgot one case. So got my false, got my trues and false. What about if the year is not divisible by 400, not divisible by 100? There are some other cases. If it's not divisible by either of these, but it is divisible by 4, it is a leap year. Yes, sir. So 2020 was not caught, and now it is. Attempt. Roger that. So we got that, and we see that the 400s before the 100. Now I want to show you, what if I flip these and turn the 100 and 400, flip them up. I'm going to catch the wrong stuff. Yep. And yeah, I get a lot of incorrects because things get swallowed up by this first condition, and they miss divisibility by 400 because all numbers divisible by 400 are also divisible by 100. So it's going to catch. So gotta be the other way. Gotta. All right, we are back in business with some solid good code, and that means it's time for me to go. Adios, y'all. See y'all on the flip side. See you later. All right, we're back with LeetCode, actually for the first time. This is the first time I'm doing a LeetCode exercise on here, and it'll be in Python. And this one is merge strings alternately from LeetCode. The ballers out there. Shout out to LeetCode. Yeah. So, get into this thing. Going to be given two strings, word 1 and word 2. Merge the strings by adding letters in alternating order, starting with word 1. If a string is longer than the other, append the additional letters onto the end of the merged string. Return the merged string. Thank you very much. Let's look at some examples. Word 1 here, word 2 here. And you see the alternating, it's A, P, B, Q. So we're taking index 0, index 0, index 1, index 1, and so on. So yeah, alternating. Simple idea, right? Character from one, character from another. And you end up with that. The curveball sort of is if one of these words is longer than the other. If one of the words is longer than the other, you've got to just tack on the extra stuff from the longer word at the end of the merged string. Let's look at an example of that down below. We got AB, then we have PQRS. Of course, PQRS is longer than AB. So after a while, you're going to, well, not after that long, but after a few, you're going to run out of characters where I guess RS is going to be the extra pieces. Yep, notice that word too is longer. So the RS ends up being at the end. It's tacked on. So yeah, simple enough to start with A, P, B, Q across them. But when you get to RS, the other one doesn't have anything, so it's like, what do I do? So yeah, programmatically, you got to figure out how do you handle that situation where when one is longer than the other. So that's really the major thing with this one. Other than that, it's kind of child's play. Maybe it is overall for most of you guys, maybe. But really what I'm going to do is I'm going to determine which word is longer, and then I'm going to take the part of the longer word that's longer than the other one and just kind of separate it off to the side and tack it on at the end of my alternation, if that is a word. But I must begin with creating a string to hold the combined string. I think I said that right. Yeah, so I'm going to hold the combined string in this empty string right there. I'm going to create a string for, this is going to be for the end of the longer word that I will tack on to the merged string. Then I am going to determine if determine which word is longer. Do that with, I'm keeping it super simple here and not trying to be fancy. So I'm going to go if word 1 is greater than word length of word 2, then here's where it gets a little fancy. So if word 1 is longer than word 2, I'm going to take the end of word 1 where it's longer than word 2 and put it into this suffix variable. So I'm going to take word 1 and I'm going to get a slice of it where the beginning of the slice or the starting point for the slice is going to be the length of word 2, because that'll be the point at which after the length of word 2 we have the rest of word 1. So because word 1 is longer than word 2, where word 2 ends, I want to capture the rest of that so I can tack that on to the end, because I can't alternate with that because word 1 is longer than word 2. And so that's for word 1. If word 2 is the longer one, I will make the suffix for word 2. And word 1 would be the beginning point of it. Yeah, so now I've determined which one's longer. Now I can just go through and do the alternating. Whoop. Alternating. So for the alternating, I decided to use the zip function in Python because zip can deliver, if you put two iterables in it, or structures, or whatever the hell you want to call them, you put two things in it, in this case 2 strings, it's going to, for each iteration, it's going to deliver you corresponding indexes of that string, where I put 2 strings in there, it's going to, for each iteration, give me a tuple that contains both index zeros, then both index ones, then both index twos. So that is just tailor-made for this situation. Here's how it's used. And when this happens, it's going to deliver me alternating, really the alternating characters, kind of tailor-made in X and Y. And then I can just concatenate those to my combined string. Tailor-made. After this loop is over, I'm going to have my combined string except for the suffix or the end piece, if you will, if one word's longer than another. So I'm just going to tack that on at the end, as I've said several times. Tack it on, like that. No semicolon. This ain't Java. I think there it is. Beautiful piece of work there. Even though you can't really see it all because of the large type. Time to run this sucker. Let's see. Yep, looks good for our test cases. The simple ones. Yep, outputs the right stuff. All right, so that's child's play. Let's move it on to the big dog, the submission. All right, passes, just like I thought it would, because I've done this before, of course. So this is good. And there is your code. Hope you like the explanation. But you know what time it is. When the code runs, completes the exercise, that means I'm out of here. So see y'all later. See y'all on the flip side. See you next time. I'm out. Right. Once again, back again with my friends. What's up? I'm back. I'm here. You're home. You're safe. Yeah. So today I am in Online GDB. Shout out to the homies at Online GDB. They make a good IDE browser. That's what it's called. Or browser IDE. Yeah. So today, I'm going to show you guys my take on an algorithm to make change from an amount of cents. So this is kind of a classic, what they call greedy algorithm, where when given an amount of money, you break that amount of money into coin denominations. And we're going to use United States coin denominations because this is where I am. This is the money that I know. Yes. So it's going to be given an amount of cents, just cents. I'm going to separate it into dollars, quarters, dimes, nickels, and pennies. And I'm going to do it in such a way that the largest denominations are going to be taken care of first, hence the greedy algorithm. So, if I'm given 203 cents, it's going to be $2 and 2 pennies. So to kind of set the landscape here, the language is Python, and my change maker algorithm is going to be contained within a function called change maker, or thereabouts. To begin, I've already created a dictionary where the keys are string denominations, and then the values are going to be counts of the denomination. So this is really just going to be easy for categorization. As I break down the cents into denominations, I'm going to be able to count what I've got. So like if I had $2, dollars would be 2, and then the other denominations would be what they are. It's just a way to count the denominations as I get them. It's just a way to have it all together in the same data structure. And yes, let me clear this out, and I'll get started here. So this algorithm is mostly contained within a while loop where, oh yeah, I didn't really frame the beginning here. Yeah, I'll read this part. Why not? I'll put it here, right? Given an integer representing an amount of cents, convert it to an amount of money denominations, including dollars down to pennies. So I'm going to get an integer, it's just sort of a raw number of cents, like 450 cents or whatever. And I'm going to break it down into a dictionary of denominations, where it'll have the appropriate amount of dollars, quarters, dimes, nickels, blah, blah, blah. So that is what I'm going to do. And now I'm going to do that. Got my dictionary, and this is going to be mostly contained in a while loop, like I said before. So I'm going to start my loop. And you can listen to the typing ASMR, absolutely. And I don't need parentheses. It's Python optional. Okay, what I'm going to do is my condition is going to be while the number of cents is greater than 0, because in this loop I'm gonna do it in such a way where I'm going to decrement the amount of cents as I grab amounts of cents from it. So like when I add $1, I'm going to subtract 100 from cents because I've added $1. You'll see how it goes. Didn't explain that well, but oh well. All right, so there'll be several if statements, or really an if and several elif statements. Correction. So yeah, if the cents greater than or equal to 100, that means we need to deduct $1. So we'll do cents minus equal to 100, not that, and then we will, from denom, we're gonna add $1. Yeah, whoops, not that. Forget the autocomplete. See, what happens here is if the amount of cents at this point is greater than or equal to 100, it means there's $1 in there. So we gonna subtract out, and then in my dollars container, basically, which is the entry in the dictionary, I'm going to increment it by 1, meaning that we've got $1 more. Because when you take away 100, that means $1 is added to the pot, essentially converting the number of cents to $1. Kill this, keep it moving. And it'll be elifs, and let's see here. We'll do quarters next. That's the next denomination. So 25. Denom quarters plus equal 1. And from here, I'm going to do some copying and pasting because I'm going to follow a format here, really. I'm going to go quarters down to dimes. Oh. down to nicks. Nickel bag. Down to pennies. Yeah. No 50-cent pieces in this mug. All right, let's check it out. So, see, when it comes in here, it's going to get the large denomination first, being we've got descending here. So, if the amount of cents is greater than or equal to 100, it's going to grab this. So, really the mechanism of the loop creates the greedy algorithm, where if you have highest denominations first, you know with the if and the elif, it's going to choose the first one that's true and leave all the rest. So the highest denomination is going to get grabbed because we are listing them in descending order. Yeah. So on down here, and yeah, should be good. It's going to work. And what I will return, I'll return the modified dictionary at the end. So let's we can do some runs of this. Change maker. And let's do 455 cents. And give this thing a once over, check it out real fast. Greater than 0, blah, blah, blah. Yeah, looks okay. Let's check out the running. All right, 455 is $4, 2 quarters, 1 nickel. Looks good. Let's do something else. So $23.82, $23.82. 23, 3 quarters to make 75. 82. Yeah. Solid. Let's do less than $1. Let's do like 73. Yep. 2 quarters, 2 dimes. Pretty good. Okay. Code looks solid to me. And outcomes look solid. So here it is. Here's my change making algorithm / function in Python. Yeah. And an important thing to note is that you got to use if with elifs, not ifs, because it ain't going to work out right. Let's do that as an experiment real quick. If you turn these to ifs, I like to show the other side of the situation, because of course when you have ifs, these ifs are all really isolated logically. So if any of them are true, they're going to be pursued and going to end up with a little bit of a mess probably. So let me get my big denomination, or my big amount in here again. 23.55, of course should be $23, blah, 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 other stuff. So let's check it out. Okay. Look how this thing changes, where if I'm doing all ifs here, they are not exclusive. So like per iteration of the loop, it's going to grab more of these, where like it'll deduct $1, then a quarter, then like it's just going to be a mess, where you only want one of these branches or things to be pursued per iteration, and see what you end up with. 16, 18, it's a mess. So this is not a correct implementation of a greedy algorithm with all these ifs. You want exclusive pathways, so you gotta put in elifs. So a little illustration there. Now we got our ellipse, we got our correctedness, whatever the hell I said there. Yeah, too many D's. But yeah, now we got enough D's. We got dollars, $23, 2 quarters, 1 nickel. All right, this is solid. I've said enough and I've coded enough. Got to move on to other ish. Got a busy day, always. But yeah, here it is, the change maker algorithm. And that's all I got for you. So with that, adieu. Hello. Good morning, good afternoon, good night, depending on where you are in the world and what time it is when you're watching this. Today, I'm going to go over the change-making algorithm, this time in Java. I recently posted code on doing the same algorithm in Python. Now I want to switch it up a little bit and do it in Java. And here I am in online GDB. Shout out to the folks at online GDB. It is a good online IDE. I'm not affiliated. There's no sponsorship, but they're solid. So what I'm going to do here is I'm going to write a method in Java to where you're given a number of cents. I'm going to break it down into denominations of dollars, quarters, dimes, nickels, and pennies. And to help do this, I'm going to incorporate a hash map, which is a data structure that consists of key value pairs, kind of like a Python dictionary. I'm going to implement hash map, or I'm going to use hash map so that I can store the number of dollars, quarters, dimes, nickels, and pennies in a data structure, and then I can print it out easily. Because I'm going to go through an algorithm that I'm going to take a number of cents and turn it into these denominations. It's nice to have a package to present them from, rather than maybe storing them in individual variables and then doing a long print statement that says, oh, I've got this many dollars, this many nickels, this many dimes. Like, that's a little silly. I feel like throwing them in a hash map or a dictionary is it's a cool way to present them. So I'm just going to do it. Y'all can do what you want. I'm going to do this. I'm going to stay with this, as KRS-One would say. Okay, so I've already got my method set up to avoid a lot of typing or more typing, and it is going to return a hash map, and it's going to take in an integer consisting of cents. And I've already got my hash map set up here where the keys are strings, which are going to be the denominations, dollars down to pennies. The values are going to be integers, and they're all set at 0 to begin. And what's going to happen is as you accumulate things of a certain denomination, that's very descriptive, isn't it? I'm going to increment the 0 up. So like every time I collect a dollar, I'm going to increment dollars. Every time I collect a dime, dime plus 1. So yes. At the end, I'm going to have all my denominations all counted up. All right, enough blabbing. Let's get to the codings. So, and also I'm experimenting with larger type here. So the type is huge. I got to kind of figure out what is the right size for the videos. So I'm kind of experimenting on the job, so to speak. So I've got my hash map done. Next, I'm going to do a while loop and this while loop is going to be the driver for the whole thing. And the while loop is going to say, while my number of cents is greater than 0, I'm gonna do my thing. And what my thing is I'm gonna do a series of if and else if statements. And here's a model of what they're going to look like. And I'll do this for the dollars, and you'll kind of see. All right, let me kind of just stop here and explain a little bit. What you got here is, I'm going to loop, while the number of cents is greater than 0. And if I get in here and the number of cents that I have right now is greater than or equal to 100, it means I have enough for $1. So I'm going to decrement that amount from the cents, and I'm going to add 1 to the dollars entry in the dictionary, thus saying that I've accumulated $1 from the cents. So it's going to follow this model for all the denominations. I'm just going to say if cents is greater than or equal to the amount, I'm going to decrement the amount, and then I'm going to increment the value for that certain denomination. So, and then it'll work out that cents will be 0 at the end, because I'm going to keep tacking down or decrementing the amount of cents. So putting it into the, or incrementing the value in the dictionary, there's a little bit to it where, and maybe there's another way to do this, but this is the way that I know how. I'm going to use the put method, and I got to specify the key that I'm putting into, which is dollars. And then, so put is first argument is the key, second argument is the value that you're putting in, and really I'm just changing one of the key value pairs. So this is not going to be a new key value pair. This is going to be a change, a modification to something that's already there. Also could call it a mutation. But what I'm going to do is I'm going to get the value of the key that's already there, and I'm going to increment it by 1. So the syntax on that last here, it's a little maybe complicated, but I have to get the value, the current value, and get does that. The get method is going to get the current value of the value by the key, and then that value is going to be incremented. So let's think about initially. Initially, when I come in here, the value is going to be 0, and in this case, I'm going to increment it by 1, thus making the value 1. So when I record my first $, I'll decrement cents, and I'll increment the value according to dollars, or $4. And it's going to follow this model for all of the denominations. So I'm going to do some copying and pasting here. And no, these are not going to be all ifs, because if they are all ifs, it will fail. We need exclusive pathways via the else if. If you don't know the difference between a bunch of ifs and an if and multiple else ifs, you got to study that. You can sign up on my program and I'll tell you all about it. But they ain't the same. Homie, we are not the same. Okay, so the next denomination is quarters. Quarters. Yep, quarters is good. Then we go to dimes. This ends up being pretty quick when you copy and paste. Okay, so what's next is I've got dimes. I've got 2 left, 2 blocks, so I'll copy for nickels and pennies. Not doing any 50-cent pieces here. I think I said that in our last video. Nick. And then 1 for the pennies. Very good. Make sure things are matched up and nice. 10, 25, 100, 25, 10, 5, 1. So yeah, it is going to, and this is kind of an implementation of what's called a greedy algorithm, where you grab the biggest denominations first. So you want to have the higher denominations at the top and kind of sort of decrementing down as we go down, because if you have pennies at the top, these have to be in this order for the algorithm to work properly. If they're out of order, your outcomes will be out of order. All right, I think it looks okay, and I return the hash map at the end because this method returns hash map, as you see. Hash map. Denom is the hash map. Now I'm going to go to my main method and run it. And it's already set up to do so. Got a print statement or a print function. And I have make change in the inside there. I do have to supply an argument because it requires one. So I'll give it a number of cents. Let's do 1212 and see what we get. Expand the bottom part and run it. Okay, errors. Yep, got a lot of semicolons. Used to working in Python. I was doing Python pretty much all day yesterday, and my semicolon game is off. Alrighty. Notice these are in a kind of a different order than they're in here. I believe hash maps are unordered. But anyway, for 1212 I have $12, 1 dime, 2 pennies. That appears accurate. 12, 10, 2, 12, 12. Let's go big. Let's do like 130. Oh, I don't know. 1302, 3. Yeah, it's like $130. Yeah. Let's see what we get here. Yep, $130 and 2 dimes and 3 pennies. Accurate. Let's do less than 100. Let's do like 45. Two dimes, or sorry, yeah, 1 quarter, 2 dimes, and that's it. Yeah, 45. This is working, man. Working. So I'll try to get all this in one shot maybe. Let's see here. So you scroll down here, here's your method, and there's your code. Yeah. Well, yeah, just follow along and y'all try it out and see how you can make the code better, and maybe you can do a one-liner in Java to best me with this one. But this one's working, and once you got working code, that means it's time for me to bounce. So I'll see y'all later, and yeah, I can't get this in one shot, so you can kind of follow along as I do my little scrolling, and yeah, that is it. But I'm sure you guys got the main idea, and we'll leave it at that. I am out of here. See you later. back again. This time looking at a code wars exercise called adjacent double letters. I think this is a newer one, and it's a good one. I did this one for the first time a couple of days ago, and I liked it, so I'm putting it on here and giving it some pub. So this one says, given a string which is a word, return true if the word has adjacent double letters, like balloon. And the adjacent double letters are the LLOO. So it's like a string of 4 letters where you've got 2 that match and then another 2 that match. And we'll continue on. For example, yes, a balloon has the LLOO, adjacent double. L's double, O's double. You go down here to this other one. This other form of balloon is false because you got one set of doubles not adjacent to the other set of doubles. So they are separated. Yes. And moving down a little bit more, we see baboon is true because the 2 O's, the 2 N's. Mat is false because only one set of doubles. You need double, consecutive, yeah. And going down here, this one is okay because it doesn't say that the doubles can't be the same, and here they are the same. You got 2 A's and then 2 A's and then 2 more A's, but we only need a string of 4. But this is acceptable because there are adjacent doubles. They just happen to be the same across all 4 characters, but it's all good. So that works as well. So it's good to know that the doubles don't have to be different doubles. They can all be the same character. So that's good. And you can use that as your part of your kind of logic if you want to. I didn't really have to do that, but depending on how you want to craft it, it's up to you. So yeah, overall we got to find, and yeah, this one returns true or false, and it'll return true if we really got to find a set of doubles. So if you find 2 characters that are the same, find 2 more adjacent that are the same. So really for any set of 2 characters that are the same, you need to look at the next 2 to see if those are also matching each other. And that's really the task here. Find 2 that are the same, and every time you find 2 that are the same, look ahead 2 more and see if those 2 are the same as well. So maybe the wheels are turning in your head a little bit because some of you more experienced people, this is a fairly simple one. And so I'm going to start my loop in here. And I forgot to mention that this is a Python exercise, but you can see Python prominently centered near the middle of the screen with my large type here. But yeah, this is Python. And I'm going to do a loop. I'm going to loop through the string, and I'm going to loop the length of the string, and my endpoint is going to be -3 actually, not looping all the way to the end. It is because I'm going to always be looking ahead in my matching scenario. I want to be able to look ahead 4 spaces basically. And if I loop all the way to the end, I'm not going to be able to do that. I'm not going to be able to address like I plus 1, I plus 2, I plus 3, I plus 4. Well, don't need I plus 4, but I plus 3 would be the last one that I would potentially address. But I can't do that if I'm going all the way up to the end. So I create a limit that's going to allow me to look ahead. And actually, as I think about this, what I'm actually employing may not even require this limit, but it's still good to set. I've kind of got maybe a hybrid solution. So I'm using slicing, and slicing doesn't really require a limit because you can actually go out of bounds, so to speak, with a slice, and it's okay. And I'm not going to get into that, but those who know. So actually what I'm going to do here, I'm going to create a slice looking at really from where I am right now, my current element, and I'm just going to go 4 ahead. So I'm just going to look at like every 4 characters, do I have a double-double? That's really what I'm going to do. It's very kind of linear and straightforward. So I'm just going to check for double-doubles at each element, up until I get to into my limit. So here's how that's going to look. I'm going to create a slice, and I'm going to call it slice, and it'll be word, and it's going to go from I, which is the current element, to I plus 4. And what that's going to do, it's going to give me I plus 1, I plus 2, and I plus 3. Of course, the end is not inclusive, so it's not going to include I plus 4, but I to I plus 3, that is 4 elements. And I'm going to look at those 4 elements to see if they are double-doubles. So create my slice, and then I can do an if statement. It says if the first element of the slice is equal to the second element, and the third element of the slice is that's equal to the 4th element. This is really the double-double logic, where it's kind of like this. If this was I right here, let me get the pen out here. If this was I, it's going to say, okay, is I plus 1 equal, which is the second L? Yeah, it is. And if those are equal, how about I plus 2? Or I guess you could say index 2. Is this equal to this? Absolutely it is. So you got to check there, and then that's going to return true. That's really what I'm doing here, is element 0 equal to element 1, and is element 2 equal to element 3. If that and is satisfied, meaning both sides are true, then I've got my double-double. So if I got the double-double, I'm returning true. Good stuff. And otherwise, I'm returning false if I get to the end of my loop and I have not returned true. I'm going to return false. This one is just that simple. And I'm going to pass this one through to see what's up. Is it good? Is it not? It's good there. Impressive. Good there. Out freaking standing. Thought I was going to say something else, didn't you? Nope. Not today. Yeah, set my limit. Get a slice of really the next 4 characters, and then check them for double-doubles on line 4. If you got a double-double, return true. And if you get to the end of the loop without returning true, you return false because you haven't found double-doubles. And it's all good. And whenever the exercise passes muster, so to speak, that's my ticket to be out of here. So I'm good. The code is good. It runs. You got some quality explanation today. You can go into your day satisfied and hopeful. So that's it for me, and I'll see y'all later. Hey, what up and how is it going? Today, we're going to do a little kind of algorithm corner. We're going to take you inside and break down an algorithm to reverse a list manually in place in Python. Of course, we have the reverse function. We have ways to reverse using convenience functions, but I think it's good to kind of see how it is done manually to kind of give you those skills. Of course, the convenience functions are always going to be available, but want to kind of show you sort of maybe on the inside how something like a reversal of a list works, doing it in a manual fashion. You're going to need skills like this as you move forward as a programmer. Just the ability to manipulate lists manually in different ways. So I've got the code here on the slide, so let's dive in here. And first, simply creating a list here. And I want to break down generally how it's going to go. How you begin the algorithm is you find the midpoint of a list. And this list has an odd number of elements, so naturally the midpoint is where you have the same amount of stuff before and after. So this is the midpoint. You find that midpoint. It's at 0, 1, 2, 3, index 3. And then how the algorithm works is you're actually going to loop forward until you hit that middle. And you're going to stop right before you hit the middle. So like while whatever variable is less than the midpoint, you're going to go forward. For each iteration, what you're going to do is you're going to take the current element and swap it with the corresponding element on the other end. So element 0 is going to be swapped with the element at the end. So it'll turn into, like after the first pass, it'll turn into 7, 2, 3, 4, 5, 6, 1 after the first pass. And then the second pass, the 2 is going to get swapped with the 6, giving you 7, 6, 3, 4, 5, 2, 1. And after 2 iterations, you've got the 1 and the 2 swap with the 7 and the 6. So as you move inward, you're going to be swapping. And eventually, it's going to turn into 7, 5, or 7, 6, 5, 4, 3, 2, 1. Yeah, so let's look at the code now. I'm going to set I to 0 because I'm going to use a while loop, so I've got to initialize. I'm going to get my midpoint by getting the length of the list divided by 2 using integer division because I don't want to mess around with decimals, of course. And then, as I was saying, I'm going to loop while I is less than the midpoint. And what happens here on these next 3 lines, this is essentially, or not essentially, it's really a swap. This is a swap of the current element with the element at the other end. And the syntax is just a little complicated, I guess you could say. Well, it looks complicated, not really. Everything's simple, right? And what I'm using is kind of the classic swap algorithm, where you use 3 variables to swap 2 variables, where you have like one variable off to the side as a temp variable to hold the value of one of the variables. Kind of works like this, where you have, let's say you have variables A and B, and you want to swap them. What you'll do is you'll make a temp variable equal to A, then you'll make A equal to B, So they're really, at this point, they have the same value. A will assume the value of B, and then B will assume the value of temp, which was the old value of A. A is B now, and then B is A's old value, so you have a swap there. So this encompasses a swap. And that's exactly what's happening down here in the while loop. And so create a temp variable, make it equal to the current element. You can think of it as like on first turn it's element 0. Then, and yeah, you can think of z of I as A. And then on this next turn, you have z index I equals this conflagration. So let me talk about this. This is a way to generically index the I guess the last elements coming in, where we have z and we're indexing, getting the length of z minus 1. We know that the length of z minus 1, if we isolate right here, the length of z minus 1 is going to be the last element. The length of z minus 1 is always the last element. And then after that we minus I, and this is the changing portion where, of course, I is going to increase as we iterate through our loop. So you will be subtracting an increasing number every time. So like, let's say the length of z minus 1 is 7 to begin, and then I is 0. Of course, that equals 7. Then on the next turn, I is going to be 1. The length of z minus 1, and actually I think the 7 is wrong, but anyway, let's say the length of z minus 1 is 7. It minus I this time is going to be 1, so it'll be 6. And then next time I is 2, it'll be 5. So you see this is decreasing, and it allows you to come inward. I know that 7 probably, it isn't accurate in this case, but the idea holds that whatever the length of z minus 1 is, the changing I is going to make it smaller, moving it inward. Absolutely. Yep. So really, this is essentially the line A equals B. That's what it is. And then on this next line, this would be the B equals temp line, where we have our element coming from the end equaling temp, thus completing the swap. And then here, I plus equals 1, we are simply incrementing the iteration variable in the while loop, just going one step further. So that's how you reverse a list manually. And let me also take a minute to run this code, because nothing's good until it runs, right? So I'm going to pop over PyCharm, and we got the code right here. And this is exactly the same. So let's run this, and need a print statement. Gonna print z, and this will sort in, or not sort, it'll reverse in place, where the result is that z is going to equal the reversed list after this. Got tongue-tied there for a minute. All right, so you look at line 3, you got it in this format, and then it's reversed down here. And let me do another one just to ensure there's no smoke and mirrors here, which why would I be doing any sleight of hand up in here? Okay, here's another list, and it'll reverse this one as well. Good. So yeah, this is how you reverse in place. Starting with this, and we get this. There's your result, kiddies. And that's it. This is how you reverse a list manually in place. You can use these skills for further algorithmic programming excellence. That's my time for today. Hope you liked it. I definitely did. And with that, I'm out of here. See y'all later. Hello, hello, hello. I'm back, and what is going on today is I'm going to talk to you about this exercise. Yes, it's called string array duplicates. It is from codewars, and it is a Python exercise. So let's get in here. Whoops. In this one, the menu keeps coming up. In this one, you're going to be given an array of strings. And your task is to remove all consecutive duplicate letters from each string in the array. So, because of my large type, it's going to be hard to see this, so I'll scroll a little bit. But this is your initial list of strings. And then over here is the transformation. And notice this one over here, a lot, or whatever the hell that says. You move it over here, the consecutive duplicates are gone. The double L is gone, the double T is gone. And then assessee, whatever the hell that means, it is transformed to no consecutive duplicates. So the idea is to get rid of consecutive duplicates inside this list of strings. And there's another example down here where you have double L's, double S's, double E's, N's, S's. They get removed. So yeah, fairly simple idea. Not terribly difficult to think of how to do and how to implement. The extra complication comes from the fact that you have strings in a list and you're going to be cycling through that list. So kind of an extra layer of depth, I guess you could say, but we'll figure it out and we'll do it. So now that the stage is set on this one, I'm going to go into the editing area and do my thing. First, I'm going to create a string to store. Actually, that's not completely correct, because my final thing is going to be a list of strings. But yeah, I am going to create a string because I'm going to create a string to store each modified string. Like once I remove the duplicates, I'm going to store those in a string, or that string, sorry. Once I remove the duplicates, I'm going to store that in a string, and then I'm going to use that string to replace what's already there in the element. There'll be a lot going on in this one. So I'll call this string no dupes. It can be equal to empty string. And also to be able to do the thing of what I'm going to do here is to be able to remove the duplication, I'm going to copy from one string to another, and to ensure that I don't copy consecutive duplicates, I'm going to store each last character to ensure that the next character does not match the previous character. So I'm going to, for each character that I copy over to a new string, I'm going to store that character so that on the next turn I can compare the two, and if they're the same, I'm not going to do a copy. Like if I copy over an L and my next one's an L, I'm not going to do that copy because they are consecutive. So I'm saying all that to say that I'm going to create a variable to store my previous character. And then I can start the looping. And I know I'm not really explaining my entire process, but I'll explain it as I go along, I think. Stay tuned and you'll find out. So I'm going to loop, and I think I actually want to do I here. I'm going to loop through the original list, and it's got that name. And then I'm going to, for each item in the list is a string. And I need to actually loop through the string character by character so that I can remove the consecutive duplication. So this loop is going to be for each, to get to each string, I'm going to do a nested loop to get to each character in each string. So the len of arry index I, because I'm going, the list index I is going to be each individual string within the list. Hope you're following. I'm having trouble myself. So here in this nested loop, I'm going to be doing the copying over from string containing duplicates, containing consecutive duplicates, to the string containing no, or the string that will contain no duplication. So I'm going to do an if statement that says if when I'm copying over is not equal to the previous character, then I'm going to do the copy via concatenation, really. J. Yep. And notice that I haven't really set previous character yet. Like initially when you come in here on iteration 0, previous character is going to be an empty character. Well, it works out because, of course, the first character you copy over is not going to be equal to an empty string, so the copying will work. What I'm going to do next is, let's see, after the body of the if, I'm going to set previous character to the character I just copied over. Yeah. So now previous character is set for the next iteration. So when this loops back around, previous character is going to contain the last character that was copied, and then this comparison will kind of be, it's going to be more apt or make more sense because it'll be the last one copied. So if they are the same, it won't do the copying or concatenation. All right, going back in here. And so once the inner loop is over, I want to reset my previous char to empty because I'm gonna be going into the next string. So I don't want this previous character to contain some character from the last string and have it mess up my next string. So I gotta reset it here. And also, after I reset this, I'm gonna take my newly modified no consecutive duplicates string, and I'm gonna replace the current string that may contain consecutive duplicates. So I'm gonna do this, no dupes, copy, really gonna make it equal to no dupes, because no dupes is my new improved string that does not contain consecutive duplicates. So I'm going to take it, copy it in, or really overwrite the string that was there. All right, and once I've done that, I'm now going to clear out no dupes because I want to make it ready for the next string to do the removal of the duplication, that whole song and dance. Okay. And interestingly, we're almost done with this because that's pretty much the entire process. Once the outer loop is done, I'm just going to return that same array because I've really just modified the array by I've removed the consecutive duplication from each string by really overriding each string with a new string that has no consecutive duplicates. Once I'm done with that, the whole thing is done. So very good, very good. A matchup indentation. I'm just going to take this thing for a spin. Try my luck. That looks good. And that looks good. Correct Amundo. Let me go over this again really quickly before I break north on them, like ultramagnetic MCs. All right. So create character to store, or not character, create a string to store the modified string that does not contain consecutive duplicates. And I also make a string to store the previous character so that I don't write the same character twice in a row. Then I loop through my original array, going string by string. Then I loop through each string, going character by character. Then if the character that I'm currently on is not equal to the last character that I was on, then I am going to concatenate it to my new string. And once I do the concatenation to the new string, I'm going to store the character that I just copied in previous character so that I can be ready for the next character to see if this previous character equals that one. So to avoid duplication on the next turn and the next turn and the next turn. After this for loop, I am going to clear out previous character completely because I want it ready for the next string. I'm going to take my modified string and replace the original string in this slot of the list. And I am going to then really delete my modified string to make it ready for the next string. So all these maintenance activities down here. And once everything is done, I return and get my points and jet the heck out of here. So that's it. See what y'all can do with that. But yeah, this one's good. This one is solved. So explanation complete. And that means I'm out of here. So I will see y'all later. What up, what up, what up? Happy Saturday, or whatever day it is where you are. I'm back here, and I'm better than ever, I think, and I'm ready to go with this exercise. And what it is this is an exercise from LeetCode, and it's called Contains Duplicate 2. And it is a Python exercise. So let's dig in here and see what's up with this thing. Check out the description here. Given an integer array nums and an integer k, return true if there are two distinct indices, I and j, in the array, such that the values of these two indices are equal and the absolute value of their differences is less than or equal to k. Now what you'll receive as input, it's going to be an integer list and an integer k, and the objective is to find two indices such that values are equal, hence duplicate, and their difference is less than or equal to k. So they're less than or equal to k apart. I think that's a good way to say it. K apart. Because the distance between them will be less than or equal to k. Let's look at some of the examples. Scroll down a little bit. Here's your list, here's your k. Looking at this one, you look for duplicates first with this one. So you have 1 and 1, those are the only things that are duplicated. So we have a duplicate, or a set of duplicates. Now let's see if they are k apart. Index here is 0. Index here is 3. Difference in 0 to 3 is 3, and that is a yes. Big fat yes. So that's why it's true. Example number 2. We have duplicate here. This is index 0. This is index 2. That they are 2 apart, so that will not work. Or that doesn't satisfy because k is 1. So 2 is greater than 1, so that those two are out. So then let's look at index 0. Well, next one's pretty obvious. Index 0 and index 3, these are 3 apart, so of course they are not it. Then let's look at index 2 and index 3. 2 and 3 are of course 1 apart, and they are equal, so they satisfy. So this one is true as well. All right, next up, looking at this last one. In example 3, there's a lot of duplication. You got 1s, 2s, and 3s. They are all duplicated. So let's look at the distances. For the 1s, index 0, 1, 2, 3, 3. That is greater than 2, so that's out. With the 2s, we have index 1, index 4. That's a difference of 3, so that's out. Let's look at the 3s. We have index 2, index 5. Also 3 out. I think these are all 3 from each other, the duplicates. So none of these satisfy, thus false. So now you see the lay of the land, where they got to be equal, or you have to find 2 duplicates, and they need to be at least, or k apart, or less than k apart, basically. Whatever the heck k is. All right, let's dive into the code here. And I actually had a for loop already started from a previous something, but I had already started the code here. And so, of course, when you do, maybe not of course to some people, but when you approach something like this, I'm going to loop through the list and really do something per element. And so I started with my for loop, my kind of standard for loop, to go from the beginning to the end. And maybe I don't really need to go from the beginning to the end because I need to find things that are k apart, but actually, yeah, I do. So this is fine. Don't need to reevaluate myself here. Got the for loop header. What I'm going to do in here is I'm going to create a condition using an if statement where I'm going to, per element, I'm going to see if there is a duplicate that is within the range of 1 ahead from where I am to less than or equal to k ahead. So I'm gonna kind of look k ahead. So like if k is 3, I'm gonna look 3 ahead. If k is 1, I'm gonna look 1 ahead. And that is because the guidelines say that I got to find two that are equal, and then they've got to be, their difference has got to be less than or equal to k. So here is what my condition is going to look like. If the current element, and I'm checking for duplication, so I want to see if the current element is in this other range. If it is 1 ahead to k ahead, basically. So I'm going to see if it's in, and I'm going to do a slice where I'm going to do a slice from 1 ahead from where I am, 1 past, to I'm going to go k past. My ending range will be 1. My ending range will be 1 ahead plus k, because remember the absolute, or what I'm trying to find is something that is within the range of k ahead. So the difference in my indices needs to be less than or equal to k. So it is very natural to say I'm going to go from 1 ahead really to k ahead, and that's going to be my range for my checking. And if the same value is in this range, then that is good to go. That's a true. And if I do all of my looping and I don't find a duplicate that is less than or equal to k ahead, it is a false return because I didn't find what I am looking for. So this is really most of the work right here. And I'm just going to wrap this one up. So that conditional really takes care of the heavy lifting. And yet, if I find a duplicate in that range, I'm going to return true. If I do not, if I go all the way through the loop and I don't find a duplicate that is less than or equal to k ahead, I am going to return false, not false, false. Hard to type this morning. All right, I think that looks okay. There's a k. I'm going to run this through the simple test, see what we've got. Oh yes. We got my colon at the end of the if header. All right, good for the basic test cases. These are the same test cases that I went over. Now let's take a look at the submission. Drum roll, please. That always takes so long in LeetCode. It's like suspense. All right, it's accepted. It's all good. So that worked. Runtime be damned. I don't know. Not the most efficient programmer here. You see, it's extremely inefficient, but it works. Maybe you guys can best my my speed here, but I've done what I need to do, and got a little solution here for you, a little breakdown. So that's it for me, really. I hope you guys have a mantabulous, fabtubulous day, whatever the hell that means, and I am out. back again today, this morning, looking at disagreeable ASCII from codewars.com. There's the name, there's the difficulty, there's the site. Right. And we are doing it in Python on this one. Good old Python. Well worn, but well worth it. I'm experimenting with a larger type today, just to see how this goes. Into the instructions. You would like to get the weight of a name by getting the sum of the ASCII values. However, you believe that capital letters should be worth more than mere lowercase letters. Spaces, numbers, or any other character are worth 0. So what the heck does that mean? Let's drill down a little further here. This is one where you're going to be able to tell what's going on by the kind of the examples. So it says normally in ASCII, A has a value of 97, lowercase a. Uppercase A has a value of 65, space 32, 0, 48. To find who has the weightier name, you're going to switch all the values so. Uppercase A is going to be 97, lowercase a 65, and both of the non-letter characters are going to be 0. And it says that up here. Spaces, numbers, and any other characters are worth 0. So there's a little conversion here going on where your lowercase and uppercase letters are swapping values. Lowercase a is typically 97, and then lowercase a here is 65. So the uppercases and lowercases are switching values in this exercise. Really, you're going to be taking in a string and you're going to be swapping uppercase ASCII values for lowercase ASCII values, lowercase ASCII values for uppercase ASCII values, and ignoring anything else. That's really the whole thing. So some of you may be wondering, what the hell is an ASCII value? Well, internally, your system, of course, speaks numbers. You know, binary, hexadecimal, other numbers. Internally, computers process numbers. Text internally in a computer is represented as numbers. And I guess long story short, there is a chart out there called the ASCII table, and I'm showing it right here. And let me see if I can make it a little larger, if it actually works. Yeah, okay. So it can be seen. So you got this chart here, and let's move over to, let's focus over here on the right side, like here. For each character on your system, or I guess you could say on your keyboard, each representable character, there are corresponding numerical codes in several numbering systems. We're focusing on decimal. So on the ASCII chart, an A, lowercase a, is represented internally as a decimal 97. And if you go over here to the right, the uppercase A is represented as a 65 internally in decimal. So that's the conversion. And in this exercise, we have to swap the values where the uppercase A is actually going to be 97 and the lowercase a is going to be 65. And, you know, really for each uppercase becomes lowercase, each lowercase becomes uppercase. We're almost really swapping case in terms of number. And so that's kind of the beginning of it. The end of it is that we need to get a sum of all these values as we do the conversions. So there's a little gist of what's going on here. So let me move this stuff out so we can get it going. So going to be given a string and convert really ASCII values and swap them really, get a sum, and then return it. Very good summation, right? Absolutely. Let's get in here. So I'm going to create a variable to hold the total weight, or really this is going to be the sum of the ASCII values. And I'm going to loop through said string, so to speak. And then for each one, if it's uppercase, I am going to get the lowercase ASCII value. In Python, to convert a character to its ASCII decimal equivalent, you're going to use the ORD function. And yeah, I'm going to use that. And when I use that, I'm going to take the decimal value and add it to my total weight. So it's going to look like this. Here it is, ORD, and I'm going to put the element that I am converting to ASCII, and then I've also got to make it lower, because if it was uppercase, or and actually this is wrong. Let me change this. I didn't realize this. This needs to be is upper, because the is upper function checks for is it uppercase, because I need to see if it is uppercase, and if it is, I'm going to do the lowercase conversion. So if this element is uppercase, I am going to lowercase it and get its ASCII decimal equivalent. Got it? Got it? Good. Let's continue. So you got to do the same thing on the other side. If it's not uppercase, it's lowercase, so I don't really need to do a check for that. Because if it ain't upper, it's lower, or yeah, whatever. Don't need to explain that one to death. If it's lower, convert to upper, get the ASCII, keep it moving. And this is the whole thing, because any non-letter character is going to be a 0, for which there is no action to be taken, because adding 0 to a total doesn't get you anywhere. So forget it. Screw it. All right. Return total weight. Yeah, that's going to be the sum. And let's check it out. Alrighty, did not work. What do we got here? Range, length of name. I'm seeing the issue here is that I have to add a check for being a letter, because we need to ignore all non-letters. So I need to add a test case for if it's alphabetic. Is alpha. Let's go, let's go, let's go. And gotta select the right stuff. Yeah, so if it is a letter and, well, yeah, uppercase or lowercase, you go. If it's not a letter, you don't do anything. The thing is that the else was catching non-letters and adding, thus leading to a larger total. All of them are larger. So let's run this one. Those pass. Whoops. Oh, well, yeah, it passes. Kind of skipped a step there, but let me go back here. I think. I'm locked out. I do want to show you guys it again, just to make sure you got it. All right, well, there is the total summation. There is the code. Check it out, screenshot it, study it, and that is it. So this is the winning formula. And that'll be it for this one. So I'll talk to you guys later, or you'll see a video with me talking to someone later. And that is it. I am out. All right, once again, back again with my friends. What's up? What's up, people? Back here with another Python exercise from codewars.com. Beautiful picture right here. I know you guys are loving it. I had to laugh on that one. The exercise is 789 today. 7 Caillou for what it's worth. And what it is write a function that removes every lone 9 that is in between 7s. That's what you get that's where you get your 789 from. Remove the 9s that are in between 7s. Going to be taking in a numeric string as an argument here, a parameter if you will. It'll be a numeric string. So it'll be a string with digits. What you got to do is really sort of modify the string, even though really strings aren't modifiable. You're going to produce a string that, if the original string has 9s, a 9 in between 7s, you will remove that 9 in your result. That's what it's going to be. So this one, you see you got a 9 here in between 7s. That 9 is removed in your result. Second example, you've got 2 instances of 9s in between 7s removed in the result. So that's the thing. Really, you're going to be, here is a strategy. You can copy over to another string the stuff that you want, and the stuff that you don't want will not be copied. The stuff that you don't want, namely, will be the 9s that are in between 7s. So really, this is kind of a simple copy from one string to another, and you just won't copy certain things, those things being the 9s in between 7s. I think I really said that already, but reiteration is not too bad. So let us continue. Into the code. Let's move over here to our training area. And with this string modification, I'm just going to be, like I said, copying from the source string to another string. So I need to create a destination string that's going to begin empty. So I'll do that. Call it new str, make it an empty string. My source string is going to be str underscore up here. And I'm going to loop through that sucker using a for loop. Very traditional. Just loop the length of it, and I'm going to copy over what I want, and what I don't want, I'm not going to copy. Yeah, I'm going to say that 1,000 more times, guys. Guys and gals, if you will. So Now here I need to create a condition because I'm not going to copy every single character over. I'm going to copy every character that is not a 9 in between 7s. So I'm going to create a condition for that. I also kind of want to do boundary checking because I'm going to be doing syntax where I'm going to be addressing elements before and after a certain element, and to be able to do that, you don't want to address beyond the array, or sorry, beyond the list to the left. It's not a list, it's a string. Actually, you don't want to address beyond the string to the left and beyond the string to the right, being out of bounds. So I need to do checking to ensure that I'm within boundaries, and then I can do my checking, or not my checking, my actual condition. Searching for the words here today, folks. It's all good. So I'm going to start with if I is not 0, because I don't want to do this check if I'm on element 0, because the check that I'm going to do is that I'm going to check for a 9 in between 7s. There's no possibility of a 9 being in between 7s if you are on your first element of the string. It just can't happen. You have to at least be on the second element. So that'll be my first exclusion. I not equaling 0. And then I also want to make sure I'm not at the end. I'll just say I less than the length of my string minus 1, because I'm going to address before and after the element that I'm on. So I want to make sure that those boundaries are solid, whatever the hell that means. Okay, here's my actual condition. So now that I've got the checking before and checking after out of the way to make sure I'm within the range, I'm actually going to do a not condition where it's going to be, I'm going to say if the current element is not a 9 in between 7s, I am going to copy it over. So this is going to exclude really this situation. If the current element is a 9 and it is in between 7s, I am not going to copy that 9. That is really the point of the exercise. So that's what I'm going to do. And here is my code for that. Going to be a little long, but bear with me. If my string or my character is, and keep in mind a not is before this, but I'm going to code truth inside the parentheses, and it's going to be negated by the not on the outside. So if it's equal to 9, actually, I'll do it in order. I'll do, I think my insert is on. I want to check for the one before being 7, the current being 9, and the next one, I plus 1 being 7, and not y, and this needs to be a string. So what we got over here is this addresses the left character, like if the previous character is a 7, if the current character is a 9, and the next character is a 7, it means I have a 9 in between 7s, and I don't want to copy that. Hence the not. Kind of writing over myself, but hence the not right here. The not saying if it is not this, then let's copy. If it's not 7, 9, 7, then we're going to do a copy to our new string. You got all that? I know you do, because you're smart and you're worthy. All right, now that we got all that out of the way, if all that's true, we're going to do the copying. Well, really concatenation. I call it copying over because I get the view of like the old like Windows 95 copy when you would see the documents going from one place to another in a little graphic. I don't know if anybody's old enough. I'm sure some of you are old enough to remember the copy graphic when you would copy a bunch of files. All right, whatever. Doing my ramblings. All right, this is going to be str_i or index I. All right, that's going to do that. And so that handles one side of the coin. I have to also handle the side of the coin. What if I is 0 or I equals the length minus 1? Got to have that condition as well, because I still need those characters. So I'm going to do this down here too. Looks good. And so I think I'll return in this scenario because I'm excluding 9 in between 7s and including everything else. I think we're good. So I will run it and see what we got. Alrighty, what did I do? No colon maybe? But not. Let me see what we got here. Definitely no colon, that's important. And then check parentheses. Oh. Yeah, I think it was, you need an and here. Oh yeah. If, oh, yeah, I crafted this wrong completely. Let me do this. I really want this nested. I kind of screwed that up. Yeah. Because, yeah, I could do it one strong, run strong, one long kind of string, but I want to break this up. So here's a better way to look at it. Yeah, if it's not the beginning or not at the end, you go inside nested, and then if it is not this condition, then we will copy. Yeah, don't know what I was thinking. See, yeah, check this out. You got your if, then your nested if for the not condition. Then we do our concatenation. That's what I need here. Yep. And yeah, I've got my return inside my loop. What am I doing with that? And there we go, folks. Programming is a humbling business. If you think you know it all, you don't. And if you think you're perfect, you ain't. All right. Got to do the attempt portion as well. Good, good. That fits, or that works. And give it a once over. Check out the beauty. There we go, there we go. Shiny, nice new solution. And when the solution hits, when we get that green, that means I'm out of here. So I am out of here. So see y'all and hear y'all next time. Welcome back, and I'm back 2, 3, 4, 5, 6, and what we're doing now is simple remove duplicates from codewars.com. Yes, yes, and this one's going to be in Java today. Taking a break from Python, doing some Java stuff. Yes, I do code in other languages other than Python. So looking at this one, simple remove duplicates. And yeah, it seems like a lot of these exercises in the basic arena, even past the basic arena, deal with duplication a lot. This one does as well. I'm quite sure I haven't done the video on this one before, but if I have, oh well, this one will be better than the one I did before. Okay, simple remove duplicates. What it is given input of an array of integers, you're going to remove the 3 at index 0, the 4 at index 1. Actually, I am ahead of myself here because I'm scrolled down too much. Let me move up here. Yeah, I got to see the beginning of this joint. Remove the duplicates from a list of integers, keeping the last occurrence of each element. So you're going to be given an array of integers, and you need to keep the last occurrence instead of the first. See, this is different than a lot of duplicate removal situations. Usually, you're going to be keeping the first occurrence and getting rid of any extras after that. But here, you're going to be keeping the last occurrence of each duplicate. So like typically when you look at an array like this, doing a duplicate removal the traditional way, we would keep the 3, the first 4, and then we would keep this 6. It would be 3, 4, 6, and everything else would be gone. But in this different landscape with this problem, we're going to instead be keeping the second 4 and the third 3, and of course the 6th. So it'll end up being 4, 6, 3 instead of the other thing, I guess 3, 4, 6. So the outcome is going to be different because we are keeping the rightmost occurrence. So a little bit different calculation going on here. Calculation, however you say it. All right. So looking at the example, scrolling in, you're going to remove the first occurrence of the 3, the first occurrence of the 4, and then you're going to remove the second occurrence of the 3, keeping 4, 6, 3. Rightmost occurrences, 4, 6, 3. A little different. Let's look at another example. No, we're not. This is good enough anyway. I don't need to make a video that is too long. Yeah, I'm just going to jump right into the code. Hopefully you guys got what's going on. But yeah, we got to keep the rightmost occurrence, not the first occurrence. So doing this one in Java over here, and of course I'm going to have to return an array containing the remaining stuff. And you know that when you create an array, you have to have a size for it, before you can put things into it. It's got to be initialized to a size. Well, I don't know how big this array is going to be because I'm going to have a variable number, variable sizes of arrays. I don't know how many non-duplicates I'm going to be fitting into each test case situation. So I'm going to create an array list first to temporarily hold my items, and then I'm going to create an array once I know how many I have. That's a better idea. I'm sure there's other ways to do it, like I say all the time, but this is the way I decided to do it. So strap in for the ride. So I'm going to create an array list integers, and hopefully the typing isn't too loud. The keyboard's next to the mic. Maybe I'll move it soon. I've got to import though. Array list. Yeah, let me move it down here. Try it out. All right, I'm going to call this temp array list of integers. A lot of typing. Oh well. And this array list is going to hold my rightmost digits, I guess you could say. So what I've decided to do to be able to get the rightmost digits and not the leftmost, so really getting, I guess you could say, the last occurrence of each one, to be able to do that, I'm just going to loop backwards through the array. So I can grab the first occurrences, and then any remaining occurrences I will not take into my array list. I'm just going to go backwards. And so I'm going to do a for loop of doing just that. And that's wrong. I'm going to go backwards through the array. And I'm going to make a condition here that says if my array list does not already contain this element, I'm going to put it in there. This is kind of it's a somewhat classic way of avoiding duplication, where you loop, you put things into an array or a list, and the next time you come through with the same value, you say, if this value is not already in there, I'm going to put it in there. If it is already in there, I'm going to not do it and keep going. You're able to avoid duplication using this tactic. So if it doesn't contain it, I'm going to throw it in there. Yep. All right. So once this is done, I'm going to have my non-duplicates, and I'm going to need to reverse this array list because right now it's in backwards order. But I need to put it into something. Really, I got to put it into an array as I reverse it. So I'm going to create an array. But now I have an array size because I know how big my array list is, and I'll make my destination array the size of the array list. So array, I got caps lock on or something. Size of the array list. And I think I want to do solve, not solve. All right, now that I have that together, I'm going to loop backwards through the array list, and on each turn I'm going to put an element, really copy an element from the array list to the new solve array. So I'm going to do a for loop, go in backwards, and I'm actually going to need some extra stuff here, but I'll tell you here in a minute. Greater than or equal to 0, I'm minus minus. I need to add some more to this loop because my my array, I'm going forwards through my array, I'm going backwards through the array list. So I can't use I for both of these. If I use I for my array list, I'm just going to have things in the same order as my, if I use this for my array, I'll have them in the same order as my array list. But I'm actually thinking it may actually work out because, yeah, it'll go backwards to forwards. So yeah, let me try this out. I did it a different way initially, but I think this is going to work. Let's do this. TMP get I, because yeah, even though I'm going backwards through the array list, I'm copying to the higher elements of the array, so it's probably all good. Because yeah, wait a minute. Well, let's see. I'll switch course if it's wrong. You can always delete. So yeah, once this is done, I'm going to return my array. And let's see here. I know because the type is so big, you can't see the whole code, so it's very piecemeal, I guess you could say. Integers. There's no wrapper class integers. Blah, 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 blah. Yeah, I think this one, size -1, greater than 0, minus minus. Yeah, I think I need to go backwards and forwards. So I'm going to create a j equal to 0 and j plus plus. I'm not sure why I thought this would work. Because really what I am doing is the array list is in reverse order, really, and I need to make it forwards order. So I'm going to loop in reverse, but I'm going to have my my destination array going forward, low to high index, and it will reverse the array list and put the array in the right order, if you can follow that. Good luck. Confusing myself here. But let's see. And that works out. Yeah. I thought it would. I had some temporary insanity right there. If you guys have been following, maybe you know what I mean, but yeah, I was wrong for a few minutes there. Had some odd thought. But yeah, that passes, and then this passes as well, so that's good. I'm gonna change the size so you can see more of the code, because this is a little you're seeing like one letter at a time because the type is so huge. Try this. Yeah, I'll do it like this. See, I can at least get more of it per. You have this balance where you have to kind of have the size big enough to be seen by you guys on YouTube, but not have it be so big that you can't see all the code or whatever. So it's there's a balance here. All right. Well, let me run through real quick. Create an array list to hold my non-dupes. Then I loop backwards because I'm going to capture the first occurrences. Well, really, I'm going to capture the last occurrences of each duplicate because that's what the exercise is asking for. Capture the last occurrences by saying if it doesn't contain, if my array list doesn't contain this already, I'm putting it in there. Add it in there. Then I create an array, my final array. Then I loop backwards through the array list here. And as I loop backwards through the array list, I copy the items to the destination array that is going forwards. And see, what I'm doing here is I'm using two variables, really two iteration or two indexing variables in my for loop. I'm using I to go backwards, and I'm using J to go forwards through the destination array. So you see this, I and J, one's going forwards and one is going backwards. You got I here, you got J here. Condition doesn't need any changing, but I backwards, J forwards, J, I. Yep. So hopefully you guys get that. I've been on here long enough. We got our green, we have passed, and the The destination has been achieved, so to speak. So with that, I'm good. Hope you're good. And I am out of here. I am back. Yeah, once again back. Yeah, it has been a while. And yeah, of course, got to pay the bills, got to keep working. And work is kind of taking over my ability to do YouTube videos. But got a little bit of time now, so I'm going to hop in here, get y'all a video. And today, I'm going to be looking at increasing triplet subsequence. From LeetCode, and it is a Python exercise. Increasing triplet subsequence. Yeah. It's a good one. So, given an integer array nums, return true if there exists a triple of indices I, j, and k such that I is less than j less than k and nums index I is less than nums index j and less than nums index k. So we need to find three, I guess you could say, elements or indices where the indices are increasing as they go up and the values are increasing. So the values of the elements and the indices are going to be increasing. So of course it's going to go, I will be the low index and k will be the higher one. And then the values are going to be going up as well. So increasing indices and increasing values. So that is the stage. So let's look at the examples. Example 1, nums is 1, 2, 3, 4, 5. These are all increasing. And of course, indices always increase left to right. So any triple is going to be valid here. Whether it's 3, 4, 5, 2, 3, 4, 1, 2, 3. Take your pick. Any triple here, any triplet is valid. Fits into this increasing triplet subsequence. So this is all good. Very, easy to eyeball that one's going to work. Looking at example 2. 5, 4, 3, 2, 1. You notice as you go up in indices, these are all descending. So no triplet exists because you're not increasing left to right. So there's no possibility of a higher index having a higher value than a lower index. It ain't happening. Let's look at example 3. 215046. There's a triplet at 3, 4, 5. Index or indices 3, 4, 5. Because nums 3 is 0. Nums 4 is 4, and nums index 5 is 6. And that's going to be right here. Index 3, 4, 5. Of course, the indexes go up, 3, 4, 5, as they always do, left to right. The values are going up as well. 0 is less than 4, and 4 is less than 6. We got our triplet. There we go. Now we got to figure out how to do this programmatically, not just eyeballing. Yeah, so this is where the elite coder skills are coming in. Yeah, so let's hop over here. Try this thing out. Actually, we're going to dominate. We're going to kill this thing, actually. We're going to destroy it. Okay. A thing right off the bat, because we're getting a triplet subsequence, meaning we're looking for 3 things, 3 indices and 3 values. It's got to be 3. So the first thing I'm going to do is check that there are at 3 unique values in this list. Because if there are not 3 unique values, then we can just stop right there and say false. So here's how I'm going to do it. I'm going to do it by taking the list and turning it into a set via the set function. Then I'm going to check and see if the length of that set is less than 3. If the length of the set is less than 3, then there are not enough unique values in the list to continue. So it'll look like this. If that is less than 3, then we're returning false, because if you don't have 3 unique values, you cannot develop an increasing triplet. If they're all the same, you have 3 1s, there's no increasing value. If there's like 2 2s and 1 1, that's only going up 1. So there's not enough. So got to be at least 3 unique values. So that'll eliminate some of the issues there right off the bat, as they say. So now I'm going to get into my regular, I guess you could say, strategy. I want to illustrate it for you really quickly. Let's say this is our list or array. We're going to start traversing with a variable I. And, maybe I will start at 0. Let's say I begins traversing at 0 because it's going to, like when we start. For each I, we're going to create, we're going to go in deeper and do a variable j that begins at I plus 1, and then the j will go forward. And then for each j, we're going to create a k, which is j plus 1 that goes forward. And what we're going to try to do is, for each I, we're going to have j traverse the rest of the list to see if there is a j that is greater than I. And then for each j, we're going to have a k variable that traverses the rest of the list to see if there's a k that's greater than j. To see if we can develop, this kind of thing where not only indices but values. And when I say greater than, when I said it earlier, I'm talking about values. We're trying to find values. We're going to do this via nested loops, where we're going to have an I loop, then a j loop, and a k loop, where I is going to go forward, and then j is going to go forward 1 past I, and then k is going to go forward 1 past j. So we will do nested looping, and you guys are going to see what it is right now. I'm going to leave you in suspense for the rest of it. Take that off. Let's go. Alrighty. Start my for loop. So talking about the end of the limit of my outer loop, I'm going to limit it at -2 because I want to leave at least 2 places for j and k, because you're going to need to have 2 elements that are higher indices and greater than I value-wise. So I is not going to need to go all the way to the end. It'll end at -3, which is where this is going to end. The length of -3. So that leaves the length of -2 and the length -1 for j and k. And we're going to do a k loop, or sorry, a j loop. Nope. I'm going to start this one at I plus 1 because we're looking for values in the list that are at a higher index and a greater value than where I is. So of course J is going to need to start higher than I. So it'll start I plus 1, then it'll go length. This will go length minus 1 because you want to leave 1 over for K. Good, okay. All right, now, so I've got a J loop, or yeah, going past I want to check if I found a value with my J index that is higher than a higher value than what my I index is holding. So I'm going to do this. Oops. Because if I have a J that has a higher value than what I currently has, then I'm part of the way to my solution. I found one increasing value. So if I find that one increasing value, I'm going to start another loop, because I want to loop further past the J and see, now can I find an element with a value higher than J, so that I can complete the triplet I, J, K. So I'm going to do a K loop, and this one, it's going to start at J plus 1 because it's got to be past J, because the index, of course, has got to be higher. But I'm going to go the full length, or all the way to the end, because I have nothing to leave space for at the end. So I'm going to just do length of nums. And then here, this will be my final if condition, where I'm going to see if I find a K value that's higher than my current J value, I've completed my increasing triplet subsequence. Yeah, so I'm going to do that. If nums K is greater than nums J, then I got my triplet. I'm going to return true. So I've got this kind of like cascading nested loop. It almost forms like a right triangle or something. But hey, it is what it is. And this is not a very efficient way to do it, but I think it's easier to follow and easier to explain than some other ways. And right now I don't have another way because I haven't figured another one out. So when you guys figure them out, you can post them, put links, whatever, in the comments. Feel free. I'm all ears. So we found our triplet on line 10, apparently. So if you don't find the triplet, you're going to return false, because this returns a Boolean, true or false. So let's do that. Because really, if you go all this length through all these traversals and you don't find a triplet, you got to return false. Yeah. So let's see if this one works. I have a good feeling that it will. Aha! K greater than J. What's my runtime error? Oh yeah. Oh wow. Yeah, my indentation's screwed up. Indent that. Indent that. Alrighty. Alright, the basic cases have passed. Now I'm going to try to submit. Alright, that passes. As you can plainly see, at the bottom of the list as far as efficiency, but hey, it got accepted. That's it's a step in the right direction. So the code works. So I'll leave it up to you to be way more efficient than this, but at least you got a solution, at least you got a pathway as far as how to do this one. But there are much better ways. But I thought this was an interesting problem, and I had a little difficulty with it here and there, but it was a good learning experience. So triplet, let's say increasing triplet subsequence. Whoops. Yeah, this one's done. You can see the code. And yeah, with that, I am done. See ya. Okay, back up in here with another one. Yeah, another one. And today, we're looking at delete occurrences of an element if it occurs more than n times. It is codewars.com. It is Java today. Java. Important. Not doing Python today. So we're going to do a Java exercise from Code Wars. Let's dive in here with the explanation. You look at this explanation, it's got an annoying it's got an annoying backstory. So, and it actually has no relevance to the actual problem. So I just skip over the backstory and start with task, because this actually tells you what you're going to do. Given a list and a number, create a new list that contains each number of the list at most n times without reordering. For example, if the input number is 2 and the input list is what that list is, you're going to take 1, 2, 3, 1, 2, drop the next 1, 2, since this would lead to 1 and 2 being in the result 3 times, then take 3, which leads to what it shows you. Let me explain this one here. The point of the assignment is that you're going to be given, in Java, you're going to be given an array and a number. And what you have to do is ensure that each value in the array occurs no more than n times, n being the number that you're given. In this case, we want to ensure that no value in this array occurs more than 2 times. So what we're going to do is we're going to go along, and for any occurrences greater than 2, we're going to get rid of them. So if we go here, we have one occurrence of each, 1, 2, 3. Then we have one more occurrence of 1. That's okay because 2 is the max. Another occurrence of 2. That's okay because 2 is the max. Then we have a third occurrence of 1. We've got to kill that because there's a max of 2. We have a third occurrence of 2. Got to kill that. Then we have a third occurrence of 3. So it ends up being, I believe, 1, 2, 3, 1, 2. Actually, no, because the 3 is okay. Yeah, there is only one occurrence. So it's 1, 2, 3, 1, 2, 3, which is this down here. Yeah. So, yeah. But yeah, if it occurs more than the integer given, you gotta get rid of it. So yeah, it says delete occurrences if it occurs more than n times, n being that max of occurrences. Let's look at another example here. It's actually right here, so you can see it. With this array down here, the number given is a 1. So no value can occur more than 1 time. So we look here, 20, 37, 20, 20, that's another occurrence. Knock that out. 21, that's the first occurrence. So you're going to end up with 20, 37, 21, knocking out that second occurrence of 20. So we will be given an array and have to go through the values, and if any values occur more than n or max occurrence size or times, sorry, you're going to get rid of it in your destination array, or however you're going to do it. That is the objective here. So I'm going to clear stuff and I'm going to get my coding area ready. Given the large type we got here, I'm just going to expand out the code, and hopefully you guys got a good idea of what we need to do here. I guess I'll just throw up a comment. I'll say delete occurrences more than n times. That's the whole objective. You go through and for values that occur more than n times, you get rid of the ones that occur more than n times. Yeah. And here in this method, n is actually this integer max occurrences. Elements is going to be the array that you get with the values. Max occurrences will be n, which will be the threshold of the maximum number of occurrences of each value. So, really what I got to do is I need a way to find the occurrences of a value in an array, or maybe an array list, which I think I'll end up using an array list. But I myself don't know of a convenience method in Java to find the number of occurrences of a value in an array list or an array. So I'm just going to make one. Maybe one exists, but I don't know. So I guess given my limited scope of Java stuff, I'm just going to create one because it's not going to take that long. So I'm going to create my own method to count the number of occurrences of a value, because I'm going to use that as part of this, so I can determine if the number of occurrences hits a max. And I'm going to create, how'd that go happen? I'm going to count the occurrences, and I'm going to do an array list, because I'm going to use an array list as an intermediary data type. I'm going to return an array, but while I'm getting my stuff together, I'm going to use an array list, because I don't know how many numbers I'm going to be dealing with. Because I don't know how many numbers I'm going to be dealing with, I can't really create an array, because I don't know the size of the array right now. So I'm going to use an array list, and I'm going to use have an integer n as a parameter, because n is going to be the value that I'm going to supply. Like if I want to find out how many 3s are in my array list, I'm going to supply a 3 here. So you have to count the occurrences of a certain thing. All right, whip this up really quickly, get this train moving. So if the current element equals n, I'm going to increase the count. All right, and then once the loop is over, I'm going to return the count, because that'll be how many I got. I think that's good. Yep. So now going into my main method here, and in this method, I'm going to do the actual determination. I'm going to create an array list first, because my method is going to be to, I'll make a little comment here. I'm going to copy over values to an array list until values count. Let's say value counts hit threshold. That threshold being max occurrences. So I'm going to copy over values, and then I'm going to, as I copy over, I'm going to get a count of the values in the array list using this function. And as long as the count is below my threshold, I'm going to keep copying over. If it's greater or equal to the threshold, I'm not going to copy it. And this is going to ensure a solution because, well, because of what I just said. Remind it. Don't need to repeat myself too many times. Roger that. All right. Create the array list to hold my kind of intermediate data. I call it like destination. And I do have to import Java util at the top. Looks like I am already. Okay, cool. Had that taken care of. All right. I'm gonna loop through the original array. And as I loop through the original array, I'm going to do my copying or potential copying over to the array list. I'm going to say if I'm going to be using my use my method up here. I'm going to get the count in my array list of the value. I'm going to say if this value is less than, if the number of occurrences of this value in my array list is less than the max occurrences, I'm going to go ahead and do another copy. So if it's less than max occurrences, then I am clear to do a copy over. The copy over is going to be via the add method for array lists. Copy that over, and once this loop is done, I'm going to have my proper number of values in my array list. Now the array list has to be converted to an array. And I know there's a method to do this. I'm not going to use it. I'm going to do it the longer way. So I'm going to create an array. The array is going to be the size of my array list. So now I have a size for my array because I've got all my items together. And then I'm going to loop through my array list using I once more. I is getting a hell of a lot of use in this code. All right. And then inside this loop, I'm going to place the values of my array list into the array because this method requires the returning of an array. So I'm going to honor that guideline. Index I equals, and I'm going to get the value from the array list. And that is pretty much that. Once I've got my values in my array, I can return my array. And this array is going to have all my values that are the number of occurrences of these values will not be greater than max occurrences. So that's kind of how it wraps up. Let's see if I've made any mistakes. So I'm going to contract my interface and then run this code. See what we got. All right, passes the initial tests. Passes the full tests. That's good. So I think I did a good job. So now I'm going to re-expand it so you can see the completed code there. So here we go here. I created a method to do the counting of the occurrences. And if anybody out there has some kind of library method out there that exists that you can tell me that counts instances of a value in an array or array list, let me know. Maybe I'm just blanking on it, but can't think of it right now, so I just decided to create one. So I got that. And then my main idea method here is, array list, loop through, copy over, unless I've hit the threshold of a value. Then I convert to an array and I return the array. There we go, there we go. So there is your code for this. And that brings this one to an end. So have a good day, have a good week, have a good life. I'm out of here. See y'all later. Yep. I am back with another one. This time in Code Wars. It is common substrings, and it's in Python. Maybe I said that already. I know I said it's from Code Wars. Code Wars, common string. It is common substrings, actually, not common strings. So, common substrings in Python from Code Wars. Take 3 is the good one. All right, very good. And so let's get up in here and look at the instructions here. Given 2 strings, your job is to find out if there is a substring that appears in both strings. You're going to return true if you find a substring that appears in both strings, or false if you do not. We only care about substrings that are longer than 1 letter long. So you're given 2 strings, and really you have to find a common substring between the two. If there's no common substring, you return false. So this function is going to return Boolean value, true or false. So look at example number 1, something and fun, and you can eyeball it and see that it returns false because there's no common substring. Probably easier to look for the word or for the substring for a substring from fun in something because fun is shorter. Moving on to example 2, we have something and home. This does return true because there's an ME in both of them. There's a matching substring. So this one does return true. And I'll check out the write-up a little bit here, see if it's got any other cool little tidbits. Yeah, in the above example, example 2 is true because both of the inputs contain ME, something, and home. And we know why example 1 returns false. There's no commonality. What we also see here is that lowercase and uppercase letters are the same, so this will be a case insensitive match, as they say. Uppercase A equals lowercase a. And we are only counting substrings that are greater than 1 in length. So a simple character match is not good enough. If they both have A's, that's not good enough. You have to match greater than 1. So at least 2 characters in the substring. Important stuff. And that's kind of it. Match and see what you whatever the hell that means. But yeah, you're going to be given 2 strings. Find common between both. common substring. So let's expand out here and do the code. I'm also going to, I think, increase the size here. I'll mess that up. Make it huge. It ain't that big. I'll write out the instructions, a little snippet of the instructions here, so we know what we're doing. Yep, that's a good synopsis. Find a common substring between S1 and S2 and false if there is not. So, how would you do this? How am I going to do it? What I'm going to do is take one of these strings and find all of the possible substrings of it, and then for each substring I find, I'm going to see if the other string contains them. So I'll write that out in a comment. There's a little write-up of my kind of general algorithm that I'm going to use. Find all the substrings of one, and for each substring that I generate, I'm going to see if it's in the other string, and if it is, it's a true. If I get through all the substrings and there's no matching the other string, we're going to return false. So here's how I'm going to generate all the substrings. I'm going to, you can just pick either string, S1 or S2, find all the substrings of it, look for it in the other string, and that's it. It doesn't matter whether you choose S1 or S2 to get all of the substrings of, because it's just I guess you could say a one-way comparison. I'm not sure if that's the right way to say it, but you only need to pick one of them, and it doesn't matter which one. Anyway, enough rambling there. I'll choose S1, and I'm actually going to loop until right before the end. So I'm going to stop at the length -2 because the substrings have to be at least 2 characters long, and I'm going to do a substring from I to J and create a range from there. So J is going to go to the end, and I is going to go at most one before the end. J goes all the way to the end, and J is going to start at I plus 1. And so I can draw this up a little bit. Say we got an array or a list here, and say I starts here. Getting all the possible substrings, J is going to start here. Let's say this is element 0 and element 1. J is going to start here and go all the way to the end, while I stays right here. So my my substring, really, it's going to be, looking at it in slice form, it'll be I and then J plus 1. And as J hops to each subsequent element, it's going to expand. It's going to go from I to all the possible lengths. So like if I is at 0 and J starts at 1, you know, J will end up being 2, 3, 4, 5, 6, 7, 8, whatever down the line. And for each slice, I'm going to see if that slice of the string is inside of S2. So that's a little snippet of how it's going to work. I know I didn't explain everything, but I try to make these a little brief. So hopefully you picked up a little bit there. Maybe you will in the code. All right, so what I'm going to do here is I'm going to compare a slice, which will be a substring, to see if it's inside of S2. Like, is this substring inside of S2? I'm getting a slice of S1, and like I did in the drawing, it'll be from I to J plus 1. I'm going to see if that snippet, or if that substring, is in S2. If it is, I'm simply returning true because I'm good, because that's what we have to do. See if the other string contains it. That's it. So that's that. And I'm doing J plus 1 here because I want to capture J as well. You know that the upper limit is not inclusive for slicing and for the range. So I want to really capture from I to J. So I'm doing J plus 1 so that it includes the J element in my slice. So yeah, I return true if there is a match here, and otherwise I'll return false, but not really otherwise here, because I'm not going to do an else in the loop. I'm going to do an else after everything is done, because that's how you know if there are no substrings of S1 that are in S2. You got to go through them all, and you go through them all by doing the looping completely. So there we go. Once you're done with all the looping, if you have not returned true, return false. So there's your general algorithm, and I realize I am missing one thing. I remember that this needs to be a case-insensitive comparison. So for each substring that I create, I'm going to make it lowercase and S2 lowercase, so that we have a case-insensitive match or comparison. It's only a match if they're true, or if they're the same. All right. I think it's good. Gonna minimize this and then do the running. See what we get. Looks like something's missing up here. Where'd all the stuff go? Anyway, I'll just do the testing. Screw it. Missing the colon. My colon is swollen. Alright, that passes. That passes. So this code is good. As I thought it would be. So I'll put the code back up bigger. So yeah, this is going to find, it's going to loop through S1 and get substrings of S1. See if those substrings are in S2. If any of them are, return true. Otherwise, return false if you've gone through all the substrings of S1 and have not found them in S2. And to create the substrings, I use looping and slicing, where I do a nested looping situation where I is going to be the beginning of the substring and J will be the end of the substring. And I use slicing to create the substring. You see, from I to J plus 1, I to J. Lowercase it, compared to lowercase other string, If they're the same, return true. There is your synopsis, and we got a passing grade on this one, so I am out. See ya. Okay, check, 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 check. Mic 1, 2, 3. Good morning, good afternoon, good night. I'm back here, and hopefully I can be heard. If I can't, oh well. Today's today's exercise is cut array into smaller parts. Python from codewars. Back in the codewars, back with Python. Back home. Okay. Write a function make parts that will take an array as an argument and the size of a chunk. So takes an array and the size of a chunk. Your arguments are going to be a list in Python and an integer indicating the size of a chunk. Not a lot of explanation here, but let's look at this example. If an array of size 1, 2, 3 is given and a chunk size is 10, there will be 13 parts, 12 of size 10 and 1 of size 3. Kind of a bad example because it's just so large. An array, a list or an array of 123 items, you break it up by tens. Let's instead look at the test cases here on the bottom right to see what's really going on. Let's slide down here. Here we see the inputs for this first test case. A list of 1, 2, 3, 4, 5, and then an argument of 2. So those are their two arguments, the list and the integer. And the result is a two-dimensional list where each sublist is it's a chunk of the original list, and its size is the same size as the second integer argument. Here each chunk is of size 2, 1, 2, 3, 4, 5. And you notice that 5 only has one element because that is what is left over. So the last sublist it may not be the specified size because there may not be enough left over. So if that is the case, then you just put what is left. That is a brilliant explanation, isn't it? So yeah, each chunk or each sublist is going to be the size of the second argument. Looking at the next example, 1, 2, 3, and 1. So with this one, each chunk is going to be size 1. So each sublist is 1. Very good, very good. I know you guys are getting this out there. You're picking it up. Look at the third situation. Have a list and the chunk size is 10. Well, there's only 5 elements in this list. So a chunk size of 10 would return just the entire list as a sublist. So there you go. We're going to break the original list into sublist chunks of the size of the second argument. That's what we're doing. So let's get in here and do it. I'll expand and increase here. Yep. Gonna make some chunks. All jokes aside, I'm sure you guys have got jokes out there. Chunk it up. Okay. So I'm gonna first do this kind of the longer way, then I'm gonna do it in the list comprehension way because this solution can definitely be done in list comprehension. So I'm going to make a two-dimensional list situation. So I need to create a list to put the two-dimensional chunks in, as they say. And then I'm going to loop. So the dimensions here is I'm going to use options of the range to actually create my chunks, so to speak. Let's take a look at a sample situation. Let's say I got this list and I want to do chunks of 2. Well, of course I'll start at index 0, and I'm going to create a chunk of 1 and 2, a sublist. On the next iteration, if I was doing a normal range, on the next iteration I would get to 2, and it would end up making a chunk of 2 to 3, which I don't want to do. What I want to do is jump. So I want to do 1, 2, and then jump to 3, 4. So I don't want to iterate consecutively one at a time. I want to be on the one I'm on and then jump 2 forward. So I've got to change my range options. So really what I want to do is, once I've got this 1, 2 chunk, and let's say I is here, I want to jump to this 3 and put I here and make a chunk here. And then I want to jump 2 more and make this 5 a last chunk. Gotta love saying chunk, right? All good. Okay. So how I do that in the range is, remember range, the setup or the options are, it's start, stop, and step. Well, step is when you basically skip a certain amount, and my jumping here is going to be, I'm going to want to skip, where I want to start on this index 0 and then skip to index 2, then skip to index 4. Step is the skip. And to be able to use step, I've got to use the 3 argument version of range. So I'm going to start at index 0 with my range. I'm going to stop at a traditional stop, the length of my array or my list. And then my step is going to be 2. My step is 2. And here's something you can remember about step. Step really says that you are going to skip 1 less than the number that's put there. So I'm going to skip 1 in between using a 2. And so I'll go to the next line. And yeah, that's how I'm going to do it. 0, length of the list, and then step of 2. That's how I'm going to end up jumping after every chunk. So now I can make a chunk, and I can do that with slicing, where I can just append to the 2D list. I can append a slice, which will be a sublist, really. So I'll do this. I'll go starting at I and then ending at the chunk size plus I. Because of course, as I moves forward, as I moves forward, the ending point is going to be the chunk size plus I. I can't simply have chunk size by itself here, because chunk size in the original example, chunk size is 2, and of course I is going to eventually get past 2, probably after the first iteration. So the ending's got to be chunk size plus I, so that as I moves to the right, chunk size is offset by the right amount. I don't know if that's the right term, but you guys probably know what I mean. So move some spaces here. All right, so we got our sub list. Line 4 is going to create the sub list and append it to 2D. And I'm going to erase my drawings. After this, I simply return 2D because it's going to contain the chunks. Gotta love the containment of chunks. So I'm going to retest this, see where we get. Oh yeah, I can't just go by 2. It's got to be chunk size because I hard coded it. So don't hard code it. You got to use the size that it's supposed to be. There we go with that. There we go with that. Great. Now I'm going to show you all real quick how to do this with a list comprehension. If you don't know what list comprehension is, it is a way to create and populate a list using a for loop all on a single line. It is a way to condense your code, really, where I can take lines 2, 3, and 4 and turn it into one line, and also return it on the same line. And I'll show you how the conversion works. Here we go. I'll just grab the header and I'll do this. And really I can just grab, I'll just grab the header here because it'll go in, fit in nicely. And I'll make my sub list. Yeah, so here is list comprehension, creating a two-dimensional list where you see the outer brackets and you see the inner brackets. Yeah, and I think there's too many brackets. This is not right. There, that's it. So I'm going to create my sub list here with the slice. Yeah, for each turn, whoops, screwed that up. For each turn of the loop, I'm creating a slice, which is a sub list, and then appending it to the overall list. Kind of the same thing as line 4. So I'll delete the first part, or maybe I'll comment it out. And let's run or test. Looks good there. Looks good there. So there you have it, y'all. Let me expand it out here again. And here you are, 2 solutions to this exercise. So with that, I'm good and I'm out of here. I hope you're good, and I'll see you next time that I make one of these videos. See y'all later. What up? Once again, back again. Yeah, back here with a Code Wars exercise in Python, and it's called Your Order Please. This is one with string content, whatever the hell that means. Okay, enough laughing. Let's get into the exercise breakdown, the instructions as they're so beautifully put in Code Wars. Your task here is to sort a given string. Each word in the string is going to contain a single number. This number is the position the word should have in the result. The numbers can be from 1 through 9, so 1 will be the first word, not 0. If the input string is empty, return an empty string. the words in the input string will only contain valid consecutive numbers. Let's look at some examples. Maybe not easy to understand from just the words here. I think this is one that definitely needs an example. So let's look at this one. Is to this, blah, blah, blah. I'm not going to try to read these because they've got numbers in them. Your input is going to be a string, or actually, yeah, it's going to be a string of strings, pieces of text separated by spaces. Each word is going to have a number in it. And the job is going to be to sort these words by the number that it's in it, that is inside of each word. Each word will contain only one number. And so the one with the number 1 is going to go first, like it is here. Number 2 goes second, 3, and then 4. So they are sorted in the order in which the numbers are in the words. And so that's how it goes. Moving on here, you got this string. And yeah, so how that string ends up is, got this, looking over to the right, we see that it's 1, 2, 3, 4. So yes, the output is going to be, it's going to return a string where the words are sorted in order of the numbers that are inside the words. So the numbers inside the words dictate the order. You see 1, 2, 3, 4 going down. So that is the landscape. And what I'm going to do today is I'm going to do the code in PyCharm and then bring it back into codewars. So I'll give that a look-see. So I'm going to bring PyCharm over here and get started. And I've conveniently got the write-up in the comments up there so you can continue to take a look as I move forward. So got my function here, and number 1 is I'm going to be outputting a string once I do my sorting. So I'm going to create a string to put that new string into. This will be my sorted sentence. I'll just make it empty for now because I'm going to be copying stuff to it. The string that I will get as input is going to be separated by spaces. So I can very naturally split it so that I can process it word by word if need be, and need will be, so I'll do that. So I'm going to split it. Of course, put it into a variable. And the input argument will be sentence. Split that by spaces. So then now I've got each word in an element of a list. And I'll bring over one of the test cases in here so you guys can see what the input's going to look like. There's an example test case. Yeah. All right. As I proceed, what I decided to do with this one, so I'm not actually going to use any kind of sorting algorithm or using the sort function or sorted, anything like that. I'm going to do it in a more, I guess you could say, straightforward way, where I'm going to loop the numbers 1 through 9, because, and of course that'll loop 1 through 9, and because there's going to be a consecutive, or there's going to be one number in each of the words, and they're going to be in the order of 1 through 9. It may not the string may not contain all the numbers, but you know you're going to have them in an increasing order. So I'm just going to loop through, and I'm going to be able to put them in order, because I'm going to say for each one, I'm going to basically grab the word that has that number in it, and then they'll go in order because I'm looping in order. I'm looping 1 through 10, so of course I'm going to be able to grab the one with the 1 in it before I grab the one with the 2 in it, because of how it's looping. 1, 2, 3, 4, 5. They'll be grabbed from the string in the same order. So it fits nicely where I don't have to sort. I'm just going to loop with consecutive numbers, and for each consecutive number I'm going to grab a word from the string if it's there. So I'm going to handle the if it's there. I'm going to say if this. Yes. So what I'm going to do is, as I loop 1 through 10, I'm going to get that number converted to a string, because of course inside this string the numbers are in string form. So I'm going to convert the number to a string, the integer. I'm going to say if this number is in the entire if this number is in the entire string, then I'm gonna pull it out and put it into my new string. And this is how I'm going to do that. If it's in there, I'm going to loop through my split list. Sentence. I'm going to loop through my split list, and I'm going to find the word in my list, because the words are separated into elements, so I can pull out one word, leaving all the others. It's a more convenient way to pull out the words. So I'm gonna loop, maybe a little inefficient. I'm gonna loop through the list from beginning to end to find the word that contains the number. So I loop through, and then I say if, once again, stri. This time, I'm going to look for the number in the specific word as I loop through the list. So, you know, yeah. So there, and then if it's in this word, I found the word that I'm looking for. Namely, on the first iteration, I found this word. So once I find that word, I am going to add it to my new sentence. I'm going to concatenate it and a space. Yeah. Because I'm going to put the word and then a space after it, because the sorted string of words, there will be a space after each word. And I'll handle the code for the last word a little bit later. I'll use strip to take off the last space. And then once I do that, once I've added my word, I'm going to break, because I don't need to do anything else. I found my word, so I don't need to keep looping through the list. I can move on to the next number and find that one. All right, so I'm going to break there, and once I break, the loop is complete, and now after the loop is done, I'm going to return the new sentence, because new sentence is going to have the words in sorted order by virtue of this code. Now I do have to do one thing to the new sentence, because it's going to have a space on the end because of line 20. It'll have an extra space on the end after the last word. So I'm going to strip it. I'm going to get rid of the last space because strip removes leading and trailing white space from a string. And there will be a trailing white space, so I got to do that. All right, let's check out this code a little bit. Oh, what's that doing there? All right, looks pretty good. So I'm going to test it with the test cases from codewars. Got this one, copy that in. Let's change this a little bit. Name of the function. All right, let's see what we got. And let's see the output. We have 1, 2, 3, 4. See how that works? Number 1, number 2, 3, 4. Notice the difference from the input. So it is sorted in order of the numbers in the words. Very good. Grab another test case and then we'll put this in codewars. Okay. Try this one. Okay. You see down there 1, 2, 3, 4, 5, 6. So these are now in order. And they're in order for the good of the people. Very good. So now let's take this and drop it into codewars. See what the haps is. Don't need that. Where's my code? Where's the button? There's the button. Passes the test. Passes the attempt. There we go. There is your solution. So, went through it. It works. And hope you guys like it. And as always, I say you can post your own code and your own solutions, and it's always good to read other people's code. So I'm sure you can come up with something more efficient. So try it, do it, get back to me. All right, that's it for now. This is your order, please, in Python, and that's it. See ya. Okay, back here looking at another codewars exercise. This time is C++. Maybe an atypical language for me in these videos, but got to branch out a little bit. Changing letters is the exercise, and yeah, it is from codewars. The stage has been set. You have been warned, my dude or my dudette. All right. When provided with the string, capitalize all vowels. For example, here's your input, and there's the sample output. And you'll see that all vowels are capitalized. And yeah, so all the vowels are capitalized. And Y is not a vowel in this exercise. Very good. So this is a simple idea. It's just the input's going to be a string that probably going to contain some vowels. You're going to capitalize them. And I guess if the vowels are already capitalized, they'll stay capitalized and whatever. So pretty simple idea. So not too much explanation needed. So I'm going to pile right into the code and clear this out. And I'm going to code today using online GDB. Just let me prep it a little bit here. Yep, I'll bring it over, and here we go. Let's take a look here. Yeah, incoming and outgoing, just a pretty simple idea. Nothing to explain, even though I keep rambling. All right, so gonna get a string here, and I'm gonna capitalize all vowels. So what I'm gonna do first is I'm gonna create a string containing vowels that I can use as a reference to be like, if it's one of these, it's a vowel. So I'll do my A-E-I-O-U, no Y's, and I don't know, well, if a letter's already capitalized, I'm not going to need to capitalize it, so I don't even need to check for capital vowels. Okay, so I got that, and I'm also going to need to have a destination string to hold my modified string data, because this parameter is constant, so I can't change it. So even if I wanted to, I couldn't change it, even though, yeah, you can modify strings in C++, but this directive keeps me from doing that. So I'll create a string to hold this stuff. Call it a new string and make it empty. Then I'm going to loop through my original string, or step through it, as some of the fancy people say. Standard for loop situation. And here's where I'm going to do the key logic of the exercise. I'm going to create an if statement, or statement that says if the character that I'm currently focused on through the iteration, if the current character is a vowel, I'm going to uppercase it. Otherwise, I am not going to uppercase it. So I'm going to use the find function in C++. So I'm going to do vowels.find, and I'm going to look for the current character from the input string in my set of vowels. So I'm going to say str index I, which means the current character. If this character is found in vowels, meaning if it is A, E, I, O, or U, almost singing right there. If it is one of those, then I am going to uppercase it. So the test would be if vowels.find current character is not equal to this directive, impos, because this impos means it's not found. So if it is not found, that's a triple negative or something. Yeah, but so really it's if it's found. If it's found, it's a vowel, and we uppercase it. So I do this, concatenate to my new string. It'll be to upper. Yeah, using the C function, to upper. Now remember, if it's yeah, there's no underscore here. To upper, and then that character. Yeah, because this is going to change it to uppercase. Yep. So I change it to uppercase there, and I do need an else for this situation. I need to say otherwise I'm just going to concatenate the non-uppercased current character. Very good, very good, very good. Okay, so then I got that, and I'm going to, if once I get through the modification of this data and placing it all into new string, I'm going to return said new string. Yeah. Gonna return that, and I can test this out now. I'm gonna eliminate some of these spaces just to save some space, because when you have the large type, space is at a premium. Yeah, so me clearing up the space kind of shows you a little sliver of main down there. So let me use main, and I will let's say here call it so I'll just call this string S, and then pass it a string. Let's see. Forget my STD. Never forget your STDs, folks. Okay, so yeah, I'm on line 37. I am calling the function and placing the result in S, and I'm going to see if it's uppercased, because we should have an uppercase E, O, and O from this hello world. So let's check it out and do it. Yeah, those vowels look to be uppercased. Yeah, even though these look like zeros. Yeah, looks good. So I'm gonna copy this sucker into codewars and give it a go. Give it a go, mate. And gotta see what I copied. Did I copy the curly braces? I did. So, good to go. Let's drop the code in here and run this sucker. Slow. codewars is slow today. Alright, correctamundo. That passes. So, looking good here. So let me show you all the final code, and then I'll say my goodbyes. Final code once again, it's right here. So take a gander at that, and as I always say, look at it, improve it, because this ain't the best way. It's just a way that I decided to do to explain to y'all. But yeah, always be improving, always be getting better. I'm doing the same. So this one's done, and that means I'm done with this video. So with that, I'm gonna see y'all later. Peace. Okay, welcome back, bitches. What's up? Today, gonna get into an exercise called remove duplicate words, codewars, and this is gonna be in C++. C++. Okay, let's take a look here. Your task is to remove all duplicate words from a string, leaving only single first word entries. And we got an example down here. Many times it's better to look at the examples and then the instructions, because the instructions leave a lot to be determined. So let's look at the example where we have the input here. Yeah, so we have the input here. We see the duplication where there's beta, beta, gamma, 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 delta, blah, blah, blah. So the idea is to only keep the first instance of each word. we see in the output here, it's just the first alpha, the first beta, gamma, delta. So it's removal of duplication by keeping only the first occurrence of a word in the string. And yeah, that's the only one. We'll look at let's look at the other test case that's here. Move your eyes to the bottom right down here, where you see my cat is a cat fat. So the result is the removal of the second cat instance. So it just says my cat is fat. So removal of that one. So yeah, remove subsequent duplicates. So everything's got to stay in the same order. It's just if there's duplication after the first occurrence, you remove that. Now we're on a good page to begin doing this one. So I'm going to do this one in an online GDB. And I'm going to copy stuff over there and move it over here. It's good to have a little workspace to do your stuff in Code Wars. Not just the submission interface that they got. So let me clean it up here. I don't know how useful this is really going to be up there. So I already know what to do, and I don't know. Just being an example for y'all out there. Yeah, won't be able to see it while I'm doing the exercise anyway. And I'm going to copy the outside of the function, I guess the skeleton of the function, or the whatever the hell you call it. All right, I'm ready to work. Organization be damned. All right. So yeah, what I'm going to do is remove all duplicate words from a string, leaving only the first word entry. So only the first occurrence of each thing that I'm going to keep. So when I think about this, I think about, look at the way this is laid out. You've got one string with words separated with spaces. The natural thing for me is a thing like split in other languages like Python. You can take a list of strings, you can take a string with words separated by spaces and split it up by the spaces, and it'll produce a list of string elements, those elements being the words. To my knowledge, C++ does not have a string splitting function. I was not able to find it anywhere. Didn't look that hard. So got to do this in a manual way. So I'm going to do that. I'm going to tokenize this string. I'm going to take it and break it up by spaces. And the tokens will be the words. So we're going to go ahead and set that up, where I'm going to create a vector of strings to put the words into. I'll call it words. There's my setup for tokenizing, and I'm going to type it out now, and I'm going to use a while loop, and I'm going to use getLine to break up the string into words. What this code is going to do right now, before I even do anything in the body, it's going to go through this string, and for every space, it's going to put the the previous word into token. So really, for each iteration, a word is going to be placed into the string token, and then I can do something with it. What I'm going to do with it is, for each word, I'm going to take it and put it into this vector that I created. So I'm going to have a vector of words, and from that vector of words, I can continue on. I'm also going to do another operation in here. Because my need is to remove duplication, I'm going to remove duplication as I tokenize this string and put it into the vector. As I take words and put them into the vector, I'm only putting the first occurrence of each word into the vector. So I'm going to set up a condition that says, if this word is already in the vector, don't put it in. But if it is not in there already, go ahead and put it in. This is a simple way to remove or to prevent duplication. You copy stuff into a structure unless it's already in there. So I'm going to do that. I'm going to use an if statement, and I'm going to use the find function. And I'll explain it once the typing is done. Okay. You like that typing? Okay, what we got here is, I'm going to use the find function to look for the word I'm about to copy in the vector. The if statement basically says, if the word is not already in the vector, put it in there. I'm using find to say, find is really going to look for the word in the vector. If it's really going from the beginning of the vector to the end of the vector, I'm going to look for this word I'm about to put in there. And if the word is not in there, where this Boolean expression here equals words end, if find returns words end, and I actually see that I need to, this is a function, so I need to have parentheses there. If the find function returns words.end, it means that the word was not found, which is the condition under which I'm going to copy it in. If the word is not found in the vector, I'm going to put it in there, because it means it is not duplicated in there yet. This will be the first occurrence. If the word is found in there, I am not going to put it in, because that would be duplication. And the idea here is to remove duplicate words. Okay. So then at the conclusion of this loop, I'm going to have a vector of words without duplication. And what I need to return is a string from this function. So I need to take my vector and turn it into a string with spaces in between. I've got to put spaces back, because look at this output right here. The output shows, of course, this is a string, and it's word separated by spaces. So I've got to do that, because right now I've got a vector of words. Got to turn it into a string with words separated by spaces. Let me do that. I'm going to create a string to put things into. I'll call it final result because it's going to be result. Make it empty initially. And I am going to loop through my vector and then concatenate it to the string and put a space after each word, unless I'm at the end. So as I loop through this vector, I'm going to put a space after each word. I'm going to concatenate each word and put a space after each one if I'm not at the end of my list of words or my vector of words. So I'm first going to do the concatenation. That concatenates a word. And then I'm going to conditionally concatenate a space. If I am not on my last word, I will concatenate a space. Yep. Okay. What there is left to do is return my final result. Check the code real quick. Yep. Looks good. Let me check up here. Okay, let's run this thing through the ringer. So in main, I'll create, actually I'll just use this. Remove the single quotes. Put it on the same line. Yeah. Up. Semicolon. Semicolon, semi-swollen. Let's go. Yeah, interface is doing something weird. All right. Let's call this sucker. So the result's going to be a string, so I guess I will just print it. Nope. Remove duplicate words, dupe string. Yeah. All right. The moment of truth. I'm going to run it. So it should remove some remove the duplication. What do we got here? Oh. No matching function for blah blah blah. Okay. The call to get line. Single quotes, because that's a character argument, and let's run it again. Find, okay, that might be the same. Where's find? Begin end token. So it looks like I forgot I needed a header include up top. It is algorithm for the find function. So now let's try it out. Got that going. I run it now down below and I get alpha, beta, gamma, delta. That is going to be, yeah, the interface is all screwed up, exactly like my output. So let me go ahead and copy this and put it into the Code Wars interface. Copy it over, copy it over. Got to do some includes. Hey. Got double include there. Alrighty. Okay. Heck of a lot of code. Well, it looks like a lot with a large type. Alright. Time to run. If I could find the dang button. This massive type. Alright, that passes. Slow. That passes. Correctamundo. Alrighty. So let me show this code again, if I can kind of sort of do it. It's pretty hard to show in a single thing here with the larger type. But yeah, here it is. Here's your remove duplicate words solution in C++. We got a passing grade, and that's it. And I am out of here. See y'all on the flip. Hello. Today's exercise is every possible sum of 2 digits from Code Wars, and it is in Python. I know you were waiting for that fabulous announcement. Okay. Instructions: given a long number, return all the possible sum of 2 digits of it. Not very explanatory right there, so I'll dive into it a little bit. Well, actually, let's look at this example. For example, 1, 2, 3, 4, 5, all possible sum of 2 digits from that number are. If you're not really picking it up yet, long number really means a multi-digit number, like 1, 2, 3, 4, 5. I think it's really any multi-digit number is meant by long. And then what the objective is to get sums of all possible 2 number combinations from this number. So really every pair of numbers plus each other. That's what you're getting. And if you look at this example, 1, 2, 3, 4, 5 ends up being a list of 1 plus 2, 3, 4, 5, and then it's 2 plus 3, 4, 5, then it's 3 plus 4 plus 5, and then 4 plus 5. So it's really every digit in this number, every pair of digits really, every combination of pairs of digits plus each other. That's what it is. So the sum of every pair. And then you have the outcome down here, which is that. I'm not going to say all the numbers, but and the way I end up breaking it down is like this, where let's look at 1, 2, 3, 4, 5, if we can. My idea here is we're going to do two loops, nested looping situation where we're going to isolate the first number on the outer loop, and then on the inner loop we're gonna add it to the 2, 3, 4, and 5 separately. So we'll have that combination we'll have the sums of 1 plus 2, 3, 4, and 5. We're going to get those knocked out, so those will be taken care of. Then we move the outer loop forward to 2, and then it'll be 2 plus 3, 4, and 5. I don't have to do any 1 plus anything because the 1 plus things are already taken care of on the first iteration. So then it's 2 plus everything else. Then it'll be 3 plus the remaining numbers, 4 and 5. As we see before, the 2's are already taken care of. Everything plus 2 has already happened. So now it's 3 plus the things. And then we'll have 4 simply plus 5, because those are the only combinations left. So really, this handles all the combinations of pairs of numbers plus each other. And we're going to do that in a nested loop. So let me go ahead and do that. Let the man work. All right. I'm going to do it in PyCharm instead of the codewars interface, so I can do my own little testing. And I don't really need to grab that header. I could type this. What's the name? It's num here. All right. Here's how I'm going to set it up. I'm going to create a list to put the digits. Let's see. Because to be able to add pairs of digits to each other, I've got to isolate the digits. So I'm going to put the digits into a list once I do a process. And we're going to return a list of the sums. So I'm going to create a list of the sums. Empty right now, of course. And now I'm going to do the operation of splitting up the digits. And we do that with the while loop. Here's how it is done. Yeah, if you don't know, when you modulo 10 a number, you get the digit in the ones place as a result. So you get the last digit of a number using modulo when you do the modulo 10. And I'm going to append that to my digit list, and then when you divide by 10, and we're doing integer division here, when you divide a number by 10, you remove the last digit, the digit in the ones place. So what I do here is I isolate the digit in the ones place, then I remove the digit in the ones place, and then I loop again with the reduced number. So this is going to allow me to actually separate the digits into a list. So the number 1, 2, 3, 4, 5 would become a list where it'll be 1, 2, 3, 4, 5 as separate elements in a list rather than an entire integer. And the numbers are going to actually come in backwards because of the way this is being done. So I am going to reverse the list afterwards. Because really, 1, 2, 3, 4, 5 would end up being 5, 4, 3, 2, 1. So I'm going to reverse it so I'm back forwards. Now that I've got a list of integers instead of a multi-digit integer, I can now do my summing. And I'm going to do the summing in a nested loop. Going to loop through my digits, and then I'm going to start at I plus 1 on here. The outer loop is going to isolate a number, and then on the inner loop, I'm going to loop through the rest of the numbers and add the rest of the numbers to the isolated number. Like I was saying on the first iteration, 1 is going to be the isolated number, and then the J loop is going to add 2, 3, 4, and 5 to 1 separately. And then the I loop will turn to 2, and then the J loop will add 3, 4, and 5 to 2. That's how that's going to work, if you can visualize that. And inside the J loop, I'm going to append my sum to the sum list. That'll be digit list I Yep, here I'm getting a sum of the isolated number that I spoke of, and then the number from the J loop, which would be the rest, or one of the rest of the numbers. And yeah, after that, I'm going to be done. I have all the sums, and I will just return my sum list. Now I can do some testing. Grab a test case, or 2, or 3. Let's see. Can I even, oh yeah, I got it right here. Yeah, let's grab a couple of things here. Do some commenting, creative commenting. All right, expand back. All right, so we have 2 inputs and 2 outputs. These being inputs, these being outputs. So we can do some testing. So I will. It is good to do some intermediate testing when you do code war stuff, like go into your own environment, test it out, make sure it's all good, and then you can bring your code into Code Wars. 81596. All right, see what we got. All right, 81596. Let's verify it against this. 9, 13, 17, 14, blah, 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 blah. Yeah, it's the same. So 81596, it's a big fat check. Let's can speed this up perhaps. Maybe I'll do a jump cut in the future. Whatever the hell that is. All right, try this out. Okay, 18513 blah blah blah. Yep, that one. Whoops, is a big fat check. That checks out. That checks out. 2 test cases are pretty good. So get this sucker in Code Wars and see what happens. Expand. Bap bap. All right, test it out. Pass. Good, good. Alrighty. Well, there you all go. There is your solution. I'll bring it up with some bigger type here. Yeah, check that out. There's your solution to, what the hell is the name of this one? Every possible sum of 2 digits. Yeah, every possible sum of 2 digits in Python. Check it out, print it, there it goes. And with that, you're good, I'm out. See ya. Okay, let's go. Back today with average array from codewars, and it's a Python exercise. That's what it is. Now let's look at really what it is and look at the instructions. Create a function that takes a 2D, two-dimensional array as input and outputs another array that contains the average values for the numbers in the nested arrays at the corresponding indexes. The function should also work with negative numbers and floats. Let's look at an example to really clear this one up. Yeah, create a function that takes a 2D array as input, outputs another array that contains average values for the numbers at corresponding indexes. Looking at the first example, we have, yes, a two-dimensional list, and we've got sublists, and then it stacks them here, where how it ends up is we get the averages of the values at corresponding indexes, really in corresponding indexes of each sublist. So really, we're getting the averages of the columns. Now if we stack the two subarrays like this, average of 1, 5, average of 2, 6, 3, 7, and so on. And when we get the averages of the columns, we're going to put them in a flat one-dimensional list where it's going to be each element is going to be the average of that column. So index 0 of my final list is going to be the average of column 0. So column 0's average corresponds to element 0 in the new list. So that is what we're going to do. Scrolling down again to look at, well, not again, but scrolling down to look at the next example. You got a multi-list list here, and if you stack it up right here, we see that let's just isolate on column 0. You get the average of 2, 12, 9, 67. That average is 22.5. So really looking at this, you see that these averages, like I said, are the averages of the columns. So that is what we're going to need to do in this exercise. We're going to take our two-dimensional list and get the averages of the columns. We're really just going to need to loop a certain way in order to get the column values isolated, I guess, properly, so we can add them together and get an average. I'm now going to pull over and pull out PyCharm, and we'll get started with this sucker. Already got my function header, and I'm going to create a list to put my averages into. Because this is going to take in a two-dimensional list, it is going to return a one-dimensional list, so I need a one-dimensional list for that return. And now I'm going to create a nested loop, but my nested loop is going to be a little bit different. It's going to be a column major nested loop. Column major is, I guess you could say, the opposite of row major. A typical two-dimensional A typical nested loop that you're going to use to loop through a two-dimensional list is going to be row major, where on the outer loop you are going row by row, like row 0 to row whatever, and then on the inner loop you're going column by column, which is across. With the column major loop, you're going to go columns, which is across on the outer, and on the inner loop you're going to go rows, which is up and down. Well, actually it really translates to the opposite of that, but yeah, it's kind of confusing, I guess. When you're looping the columns, you're actually going across. When you're looping the rows, you're going up and down. Yeah. So try to digest that. But we'll just make the dang loop. Or loops, actually. And I'm going to use a somewhat descriptive variable name for my range loop. When you do column major looping, you're going to loop through, or your limit is going to be the length of one row. I'm going to use row 0 because I'm pretty much guaranteed that there's going to be a row 0. Most of the time there's going to be one, so I get the length of that one. And I'm pretty sure all the rows are going to be the same length, so it doesn't matter which one I use. So I'm going to get that, and then as I loop, I'm going to need to be able to get an average. I'm going to need to get a sum of all the column values. So I'm going to create a variable to get that sum. Then I'm going to do my row loop. And for the row loop, I'm going to loop the number of rows, which will be the length of the two-dimensional list. And inside the row loop, I'm going up and down in my inner loop, so it's going to allow me to get the column values. And for each column value, I need to add it to my sum, because I'm getting a sum of these column values to get an average. So I'm going to add to my temp sum, and going to double index row call, and then after the inner loop is complete, I'm going to have a sum of a column. And what I want to do with that sum of the column is take the sum, get the average, and then append that to my average list. So I'm going to do all that stuff after the inner loop is complete. And this is wrong. It's not sum list, it's average list. I'm going to divide by the length of something. What is it? Yeah, that'll be the length of the list, because that's going to give me the number of rows, which will be the number of elements in a column. That is right. And for Python, I'm going to use the single slash, because I may get floats in this, and they said you need to be able to handle floats in this function. If I did the double slash, it's going to force integer division, which will make floats integers, and it'll mess up my return value. All right, moving along, and once the outer loop is complete, I'm going to have all my averages in a one-dimensional list, so I can go ahead and return. my average list. Now it's time for a test case. Let's see what we got over here. Test case, test case. Let's take this one. I got the negative values. Comment out, comment in. All right. So I'll print the return. There's my test data. So yeah, what we should get is this test data should result in this list. Let her rip, let her rip. Check this real quick. I just want to give a final check before we hit the ignition, so to speak. All right, let's take a look here. So yeah, my values come out as floats because of the division, but the values are correct. 0, 0, 1, 5, negative 4.5. This looks good, so I'm gonna pop it into codewars and see if it passes. Now for the real test. Pop it in there, let's go, let's go. Looks good. Looks good, okay. We got it. Show you the code once more. Yeah, there's a solution. So take a two-dimensional list, get the averages of the column values, put that in a one-dimensional list, and return it. That is how you do it. That is it for average array. That is it for the video. And you guys get out there and crush it today. Have a great one. I'll talk to you soon. What's up, what's up, what's up? Today looking at length of last word in LeetCode today. LeetCode. Jumping back there. This one, given a string S consisting of words and spaces, return the length of the last word in the string. So you're going to get a string like a sentence, and you're going to return the length of the last word. Word is a maximal substring consisting of non-space characters only. So a word here is defined as consisting of non-space characters only. So I'm assuming it can consist of letters, numbers, and symbols, perhaps, or you know, any combination of those. Just things without a space. So I think that's what we're looking for. But yeah, the length of the last word. Let's look at the examples. Example 1, hello world. The output is 5 because the last word consists of 5 letters. Yeah, that one's pretty straightforward. Yeah, you grab the last word and yeah, return a 5. This one gets more complicated, or the idea is more complicated when you have spaces at the end of your output, like you do here. Fly me to the moon. The last word is moon, of course, but if you were to split this string, you're in a little bit of a pickle because, well, you got spaces at a space or spaces at the end. And we'll see how to handle this one. But the last word is moon, output is 4. And this other one, Luffy is still Joy Boy. Is that a song lyric or something? I don't know. But of course, Joy Boy is the last word, and you output a 6. So fairly straightforward idea here. So gonna get the length of the last word of a string. And what I'm gonna do is go into PyCharm and do this one. Yep, coming over here. I'm gonna get the header though as well, or whatever. All right, length of the last word. So I'm going to get words separated by spaces in a string. So really the first thing I want to do is split the string. But my split is going to be a little bit different. I'm going to split putting a space explicitly inside the parentheses. See, when I do this, instead of the default spacing, which is, if you don't know, when you leave the parentheses empty with split, it will split by a single space. That's the default. But if I put a space in here, the behavior changes a little bit, where I can capture, I believe, all the spaces as individual elements, and that's going to allow me to actually it's going to allow me to isolate on words, really separate words from spaces, where spaces will be in separate elements, words will be in separate elements, and I will easily be able to tell what the last word is. Yeah. I can give you a little indication of this actually. Let's kind of short circuit this and test, where if I supply this function with something that has a lot of spacing in it, like fly me to the moon, see what we get here. Of course, you notice that there's a lot of spacing in here, and let's see how this explicit space split, say that 3 times fast, how does that handle this situation? Let's see here. Oh yeah, unterminated string, of course. Oh, don't want that self, because you're not dealing with a class. Okay, yeah, notice that the spaces are actually kind of put in their own elements. And what if we do it without the explicit space? Actually that works, because the space is gone. So, yeah. I'll use the regular split. I actually ended up using the explicit space split in my original solution, but I'm going to try this and just see how it goes. So I'll continue with this. So we want to get the length of the last word. The last word is moon, of course, and to be able to efficiently get the last word, we should we should look at the end of our list rather than the beginning, because of course the last word is at the end. So let me try this. I'm actually going to experiment here a little bit. I'm going to try to see if this ends up working overall. So of course it's going to work here, but I want to see if it's going to work for all the test cases. So yeah, I get a 4 here, and yeah, the last one is 4, but I'm going to drop this into LeetCode to see what I get here. Drop it in, drop it in. Yep, the indenting is kind of screwy. Try it out. Is the indentation messed up? Yeah. Unexpected indent. So indent there. Yeah, I don't see the issue. Let's see, that's indented. Yeah, I am not seeing the issue here. Yeah, it looks like the issue was a screwy interface because I just retyped it, deleted and retyped, and it totally works. And this was accepted by the basic test cases. Now let's see if it passes the full Monty, so to speak. Yeah, it passed, accepted, so this is good. Yeah, this is shorter than my original solution, so I just came up with a different thing on the fly. So yeah, to get the length of the last word, all you really got to do is split your string into words, turning, of course, the string into a list of strings, which the elements will be words, and then you get the length of index -1 of that list. That'll be the last word. Return it, good to go. You're good, you're good. And yeah, runtime 0 milliseconds, so I guess that's pretty good. All right, well, that's it for this. Got it done, good, good. Hope you guys liked it, and I will talk to you, see you, you'll hear from me next time. Okay, welcome back. This time doing an exercise called the Valid Palindrome from LeetCode, and it is a Python exercise. Let's dive in. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forwards and backwards. Alphanumeric characters include letters and numbers. And given a string S, return true if it's a palindrome, or false otherwise. These instructions tell you kind of sort of what to do in your evaluation. Convert all uppercase letters into lowercase, remove non-alphanumeric characters, and then check it backwards and forwards. That's kind of what we're going to do in this exercise. Let's look at examples. Example 1, here we have this. Notice that you've got commas in there and you got spaces in there, and what happens is, well, the output is true, and it's found to be true by removing spaces, really removing non-alphanumeric characters, spaces, commas, and the colon. You see here, it ends up being the same backwards and forwards. So it is a palindrome. So really the idea is, yeah, to take the string, remove all non-alphanumeric characters, and then see if the backwards and forwards versions are exactly the same. Example 2, race a car. It is false because when you take away non-alphanumeric characters, it is not the same backwards and forwards. So I think y'all get the idea. I definitely do. So now we're going to take this into PyCharm, start working on it. All right. I'm going to first create an empty string for the transformation because I'm going to be taking in a string that may contain non-alphanumeric characters, probably will. So I'm going to have a destination string for the transformations, as I call them. The editing, empty string. Then I am going to loop through my original string, the original string being S. And inside this loop, I'm going to remove all non-alphanumeric characters from the data. Or I'm going to retain only the alphanumeric characters, depending on how you think about the logic. I'm going to say, if this character is alphanumeric, there is an isAlNum function in strings in Python that allows you to check if the character or string is alphanumeric. And what I'm going to do, if it is alphanumeric, I'm going to copy it to the new string. So the new string will only have alphanumeric characters in it. After the for loop is done, there will only be alphanumeric characters in the new string. And one more thing I need to do to the new string is to lowercase it, to ensure that all the letters are the same case, so that when I compare it backwards and forwards, case will not be an issue. Just make it its lowercase version of itself. And then I'm going to now check to see if the string is the same backwards and forwards. And I'm going to do it in my return because checking if the string is the same backwards and forwards, it can be put in a Boolean expression. So I'm going to do that. The result of the Boolean expression will be true or false. So I'll get my true or false return value. And to reverse a string, we use this start, stop, step slicing notation. If you haven't seen this before, yeah, this right here, this is going to reverse my string because there is no reverse function for strings like there is with lists. So to easily reverse a string, you use this notation. And so what I'm doing here is I'm comparing the string forwards to the string backwards and seeing if there is a match. And that is the end of the code. I'm now going to grab a test case, test the data, throw it in there. Oh, didn't get it. Is palindrome S, so this should be 1. True. Okay, and that is actually good enough for me. So I am going to take this code and copy it into LeetCode and give it a go. Run. All right, that passes all the basic cases. Now submitting. and that passes as well. So that is good. And as I always say around this time, now your charge is to find a way to do it a little more efficiently than I did, because efficiency is not my middle name with my code. I just kind of do it and get it done. So, but yeah, there's your code. There's your solution for valid palindrome. Pretty simple exercise, but I'm sure some of you out there benefit from it. I benefit from it just simply through practice. All right, that's it for me this time. Solution done, exercise done. That means it's time for me to go. All right, till next time, see y'all later. Hey, today looking at +1 on LeetCode, and this is a Python exercise. Yeah, this is Python, that's right. Just resetting here. Yeah, back in LeetCode. So, looking at the description, you're given a large integer represented as an integer array digits, where each digit index I is the ith digit of the integer. Digits are ordered from most significant to least significant and left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. So you're going to be given a multi-digit number in list form in Python, and the task is to increment that multi-digit integer by 1 and return it in list form. Looking at example down here, see the list is digits equals 1, 2, 3, and then the output is 1, 2, 4. So we have a multi-digit number 1, 2, 3 in list form, and we're going to increment that and then return it as a list form, in list form as 1, 2, 4, as you see here. Look at the other couple of examples down below. Look at example 2 and example 3. Example 2, digits 4, 3, 2, 1 becomes 4, 3, 2, 2, incremented. And here's a good example as well. 9 by itself becomes 1, 0. So of course 9, after 9 comes 10. You got to put it in list form as 1, 0. So yeah, taking an integer list and a list of integers, incrementing the multi-digit by 1 and returning that result. So really the strategy with this one that I came up with, and I think this is a pretty obvious one that anybody would come up with, is to take your list of digits, convert it to an actual multi-digit integer, increment by 1, and then you get your result, and then you convert that result back to list form somehow, and the somehow is going to be shown to you as I do what I do. Really, it's going to be by powers of 10. Actually, well, powers of 10 will be used. Well, you're going to take the list, to convert the list to a multi-digit integer. You're going to use powers of 10. But I am going to erase this, and we're going to do the bulk of this stuff in PyCharm. I guess I'll grab this, drop it into PyCharm as well. Just so y'all can keep your eyes on the prize up here as far as like what is being done. Hopefully this ain't too much obscure what I'm trying to do. All right. And let's get a test case in here. Yep, dropping that test case. And so let me show you a little bit about what my strategy is going to be here. I'm going to take the list, convert it into a multi-digit integer. How am I going to do that? I'm going to multiply by powers of 10. And how do I get the powers of 10? I'm going to use the length of the list as a guide. Well, let's frame it like this. Take a look at 1, 2, 3, and of course it's going to turn into 123. Looking at the number 123, you could break that down into 1 times 10 squared equaling 100. And it's 2 times 10 to the first equaling 20. Then you have 3 times 10 to the 0 power. Anything to the 0 power equals 1. So it's really going to be 3 times 1 is 3. Let's add all those up. 100 plus 20 plus 3, of course, equals 123. There is your algorithm, my friends, where we will get the length of the list minus 1 and then use descending powers of 10, I guess you could say, because the length of this is 3. The length of the list is 3. Your exponents of 10 are going to start with 2 as you go left to right. I could even write it like this. Like, you look at 123, the 1 will use 10 to the 2, the 2 will use 10 to the 1, and the 3 will use 10 to the 0. You see it's descending going left to right. So the tactic is going to be to get the length of the list, minus 1, and then use descending powers of 10, where the first digit will be 10 to the length minus 1, the second will be 10 to the length minus 2, and so on, going down to and equaling 0. So there's an explanation of the algorithm. So now let's put this into practice. Clear it out. If you need to check it out again, obviously you can rewind. Be kind, rewind. So they used to say back in the VHS days, for those who are, what, 30, 40 plus maybe, 35 plus. It's, time is passing. All right, so as I start this, I'm going to create an integer to hold the multi-digit integer. I'm going to call it whole, not while, and make it equal to 0. Then I'm going to set up my exponent variable, because I need to use a variable to hold my powers of 10 exponent. And I'll call it this, exp, and it'll be the length, of my inputs. Digits is the input list. So I'm going to get the length of that list minus 1, as I was saying before when I showed you the write-up demonstration of the algorithm. Yes. Got to clear my throat this morning. Okay. And then I'm going to be doing a while loop, so I'm going to have an integer I equaling 0 as an iteration variable, because I'm going to iterate forwards through my list of numbers as I go. And now I'm going to create a while loop, and I'm going to say while my exponent variable is greater than or equal to 0, because as I was saying before, the exponentiation goes backwards from, in this example, it's going from 2 down to 0. So while it's greater than or equal to 0, my exponent, I'm going to do what I'm doing. And what I'm going to do is I'll explain this soon. All right, I'll explain this now. What I am doing here is, and actually this is right. Let's look at the right side first. Digits index I times 10 to the whatever. So here I'm getting an element from my list of numbers. And for each element, I'm going to multiply it by a power of 10. Here it's going to be, and this is exponentiation in Python. Let's look at the case of this number. Let's look at the case of the first iteration. Digits would be 1, the number 1 right here, and then this would be 10 squared. So it would be 1 times 10 squared equaling 100. So in my first iteration, that's what it's going to be for this test case. And that 100 is going to be added to whole. So after that one iteration, whole will be equal to 100. And then as I iterate next, it'll be 2 times 10 to the 1, which will be 20. 100 plus 20 equals 120. On the next turn, it'll be 3 to give you 123. So that is how it works. Element of the number list times 10 to whatever power you're on right now. All right, back to the codings. All right, so once I've added that digit to my whole, or not that digit, once I've added that quantity to my whole, I am going to decrement my exponent, because the exponents go down as I move forward, and I'm going to move I up, increment I, because I'm going to move forward through my list. And once that's it for the while loop. Once I'm done with the while loop, I have my whole number, my multi-digit number. My multi-digit number is going to be stored in whole. Now remember, the idea here is to increment my large integer by 1. So I've got my multi-digit integer done. I'm going to increment it by 1. All right, so now I've done that operation. In the case of the test case, 1, 2, 3 is now 1, 2, 4. Now I've got to take the 1, 2, 4 and turn it back into integer list form. And it's a fairly simple process. I'm going to create a list to hold my my splitting, and I'll do the algorithm for taking a multi-digit number and splitting it into its digits. And here's how it goes. Yeah, that is the algorithm. So this algorithm is going to split whole into its constituent digits, if that's the right term. Whole is 124 to begin. And so what I do here is when you modulo 10, you get the last digit of a multi-digit number, or any number, really, any whole number. So when I do modulo 10 on 124, it gives me a 4. I put that 4 into my list, and the new digits list. So let's look at what happens. You take the 4, put it into this list, you append it, and it becomes the first element. And then I do a division by 10. When you divide a whole number by 10, you get rid of the number in the ones place, the last digit. So I get rid of it. Then I loop back around and I do modulo 10 on 12, which will give me a 2. I append that to my list. There's the next element. Then I do divide by 10. Kill it. Then I come back around with 1. 1 modulo 10 is 1. Append it. And there I have my multi-digits, my multi-digit integer turned into a integer list. But of course, notice it's backwards because of how I did this looping. It's backwards. I just need to reverse it. So, no big deal. Reversing it ain't that hard in Python. So I'll do that. And how I do that? Well, I'll just do it in the return because I don't need to do anything else. All I'm doing is reversing it and then returning it. So I'll do that all on one line. One line. Here you go. There's that handy slicing syntax for taking an iterable, I guess you could say, and reversing it. That's how you can do it. There's some other ways, but I could call reverse or reversed or whatever, but this works. And it's a conversation piece, right? So now this is done. Let's take this and use a test case or test cases on it. Yeah, we can use 123. Dub. Should get a 124 in list form. Saw a flash of light. There we go. Awesome stuff. 123 becomes 124. Let's throw another test case in here. Yeah, let's do this one. The 9 to 10, because it's a telling one. Not that. Plus 1, 9 should become 1, 0. And we have the magic. The magic has happened. Out effing standing. Yes. Okay. I think this is ready to go, folks. Let's copy it. Drop it in. Drop it in. What is that? So much going on. All kind of codings. All right. Indentation. I'll probably get an indentation issue error or whatever with this. Oh well. Yeah, this code can definitely be condensed, of course, but this is what I'm going with for now. As I always say, y'all can handle that. Make it better, make it plain. Alright, so it passes those initial tests. Let's submit. See what we get. Alrighty, accepted. Good. And yeah, efficiency be damned. You guys can handle the efficiency part. See what you can do, let me know. But here's your code. I do like this one. This is kind of, especially on the beginner side, there's a little bit of trickery here, but crafting algorithms like this is kind of fun. In fact, it's super fun. But yeah, with that, got my passing grade. I'm out of here, and you're out of here. Until next time, see y'all later. Let's do it. Today's video is on alternate square sum from codewars, and this is a Python exercise. Super Pythonic. Here we go. Complete the function that takes an array of integers, really in Python will be a list of integers, as input, and finds the sum of the squares of the elements at even positions plus the sum of the rest of the elements at odd position. For empty arrays, the result will be 0. Now, it needs to be explained a little bit what positions mean, because the position is not the same as index. Like it says here. The values at even positions need to be squared, positions. For a language with zero-based indices, this is going to occur at oddly indexed locations. In Python, the values at indices 1, 3, 5, etc. should be squared because these are the second, fourth, and sixth positions. So actually the odd indices are the even positions because the positions are actually 1-based, indices are 0-based. Looking down here a little bit. In this example, got this list, and the even positions are for the 2 and the 4. Notice position begins with a 1, so it's 1-based, not 0-based. 0-based, you're going here, 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 and so on. So we're going to go 1-based to grab the numbers to square. So now that we have the position versus index, I keep saying index, of course, thing. Now we have that squared away. Good choice of words, right? What do we have to do? Well, the items at even positions need to be squared, and you're going to get the sum of those, and the items at the odd positions will just be summed, I believe. Yeah. So sum of the squares at even plus the sum of the rest. And yeah, so the sum of the squares of the even positions and the sums of the odds are all added together to create this large alternate sum. Very good, very good. So let me go ahead and I think I'll just do this one in PyCharm since it's not, sorry, I'll do this in codewars, not PyCharm, because it's just not that much to it. Gonna increase the size here a little bit more. So perhaps it'll be able to be seen even though blah, 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 blah. Let's see. Yeah. I'm going to create a variable to hold my sum because this is all about summation. So you got to have something, an integer variable to hold your sum. And I'm going to loop through the list using the range loop. And I'm just going to do a conditional where I'm going to look for odd indices, which will be even positions. And remember, you look here, your odd indices will be even positions, and that is where you're going to do the squaring. So yeah, for the odd indices or odd indexes, you're going to do squaring on those. So I'm going to do a conditional using modulo to find the odd indexes. If the index is odd, I'm going to add a square of that element to my sum. Yeah, and that is the element at I raised to the second power. Of course, it is a square. It's being added to my sum, and there you go. So for the odds, I'm doing that. For the even indexes, which are odd positions, I have an else, and I'm going to add for the even indices or indexes. I can't remember which one it is to say now. I'm kind of crossed up with this index versus index. Somebody tell me in the comments. But anyway, for the even indexes, I'm going to simply add the element value, no squaring. And really, this is all there is to it. For the odd indexes, I do the squaring. For the evens, I do just get the value. Everything's added into the whole sum, and you just return the whole, sum. Ain't a whole lot to it, my friend. To return that, we are good to go. Damn Skippy. I'll run this, or test it. Got two ends. Pass that. Pass that. Impressive, maybe not really, but yeah, this one is kind of a layup, but practice is always good, and no matter how simple. Master the fundamentals and you can really move ahead because you don't have to be looking stuff up. So do not take things lightly and laser focus on those fundamentals. This one's done. Alternate square sum. Interesting idea, maybe a little confusing with the index versus the position thing, but once you get that figured out, you are all good to go. This one's done. Got the points before, so that's it for me. Hope you all like it. And until next time, I am out. See y'all later. Okay, what up? Back here once again for y'all with another exercise, and it's gonna be maximum triplet sum from codewars.com. And this is gonna be Java this time. The language will be Java. And getting into the write-up for this exercise, given an array of n integers, find the maximum triplet sum in the array without duplications. Looking at some further notes, the array size is at least 3, so there's going to be at least 3 elements in the array. The numbers could be a mix of positives, negatives, and zeros, and repetition in the array could occur. And the duplications are not included when summing. So something to keep track of as we look here. Looking at examples, when you give an input to the method like this, it returns 17. So let's break down this idea. It is a maximum triplet sum. Really what it is, what that means is the sum of the highest 3 values in the array. That's what it is. I don't know if it explicitly says that, but that's what it is. The highest 3 values. So in this array, the highest 3 values are 6, 8, and 3. 6 plus 8, 14, plus 3, 17. Thus, you get a 17. So highest 3 values get a sum of those. As the explanation says, max triplet, maximize the sum 6, 8, 3, 17. So now we're on the right page where it is the sum of the 3 highest elements. Looking at this next one, it returns 18. Showing you here, it is 8, 6, and 4 are the highest 3 values from this array right here. Yeah, nothing else more to say about that, right? The highest 3 are going to be 8, 6, and 4. Add them together, you get 18. This next one is a little more instructive, I think, where in this example, you have positives and negatives in the array. And if you eyeball this a little bit, let's see the high values. You have 29, 12, and 0 are the highest ones. Yeah. And of course, maybe not of course, but the sum of those is 41. And yeah, if you get the highest values, really the highest 3 values explicitly are 29, 29, and 12. But in this exercise, we're not including duplicates in the sum, so we're only going to include one of the 29s. So as it says in this little snippet right here, duplications are not included when summing, so values are going to be only added once. So here we have a couple of 29s, because really the highest 3 values are 29, 29, and 12, like I said, but only one of those 29s is going to be used. All the values that you use in your triplet will be unique. Important to note. So that's going to have an influence on how we do the algorithm, because you're not just getting the top 3, you're getting the top unique 3 values from the array. All right, now let's do this sucker. I'm gonna grab this array as a test, and I'm gonna go do this in online GDB. Remember, the idea is maximum triplet sum, get the highest 3 values and sum them together. Create an array with my test values. There we go. And what is that supposed to equal? 41. All right, now I can do my max triplet sum. I have to get the highest 3 values from the arrays. So I'm going to sort, because if you sort a set of numbers, of course, if you sort them from least to greatest, the highest values are going to be at the end of the list or the array. So I'm going to use a method from the arrays class called sort. It's going to allow me to get the numbers in ascending order. Yeah. And you know what? I'm actually going to print this out just to show you what the outcome is, and then I'll continue with the rest of my solution. And I'll just right now return some kind of dummy thing. But I'm going to just show you the output. Down here in my main method, I'll run the method try sum test array, and running that Errors abound. Man, missing the semicolons. I've been doing Python quite a bit today, so forgetting. Oh yeah, I forget the fact that you cannot print an array straight up. I'll call arrays toString to print the array. Alright, so there's the sorted array, and you compare it to the original. See, we got the values at the end. Now, the need here is to get the highest three. As you see, and as I was saying, as I was explaining before, with this particular test case, the highest three values, there's duplication in the highest three. So we need to get the highest three unique. So we're actually going to be getting these three because the 29 is duplicated. And the highest three, 12, 29, and 0, adding up to 41. So that's the goal, to get the highest three that are unique. So I'm going to show you how to do that. Alrighty. Getting rid of that. I'm going to create a variable to hold the eventual sum, and I'm going to populate it with a value because once I sort this array, I already know that I'm going to, at a minimum, use the last value in the array because it's going to be the highest one. So I'm going to go ahead and populate my sum with the last value in the array because it's going to be the highest value and it's going to be included in my sum. So why not just go ahead and populate it right now? There is no reason not to. Length, yes. Nope, that's not it. -1 inside your parentheses. That's going to give me the value of the last element. And I'm going to also, I'm going to create a variable to tell me how many numbers I've added to my sum. Of course, looking at line 8, I've already added one number to my sum, so I'm going to start trip count at 1, and this is going to allow me to keep track of how many numbers, like I said, I add to my sum, because there could be duplication in my test cases. So I'm going to skip over duplicates as I find them, and I'm going to keep track of how many numbers I'm actually adding to my sum by using this variable. And then I'm going to loop through this array somewhat. I'm going to loop from the end to the beginning because my need is going to be to find the highest 3 values, and the highest values start at the end. So I'm going to go from the end to the beginning, and I'm going to get the highest 3 values. Really, I'm going to get the highest 2 because I already have one of them. So I'm going to start right here, and I'm going to find the next 2 highest from the point of the length of the array -2. That's what I am going to do, and that rhymes beautifully. Okay, for looping, and I'm going to start my I at numbers.length -2 because I've already got the value I've already got the last value, so I'm going to start at the second to last value in the array and move backwards to get the next two highest ones. Nope. Minus minus. In the body of the loop, I am going to I'm going to create a conditional statement that says if the number I'm about to add to my sum from this array is not equal to the last number that I added, then I'm going to go ahead and add it. That's a way to deal with duplication, because if the array is sorted, so if the last number is the same as this number, of course it's a duplicate, and I'm not going to add it to my sum. I'm going to wait till the number is unique, and all duplicates will be in consecutive because this is a sorted array. Hell of a breakdown, isn't it? All right, so if the current element is not equal to the element before it, then it is a go. I'm going to add it to this sum. And for every one I add, I'm going to increase my the count of the numbers that I've added. So yeah, and then if my triple count is equal to 3, then I'm done. Yeah, it's probably a better way to do this, but I'm not doing it right now. That's my story, and I'm sticking to it. Once I'm done with this whole thing, I'm going to have my top 3 values in sum, and I will simply return sum. All right, my test code needs to be modified a little bit. I'm going to create an integer to store the outcome. Then I'm going to print it out. Print it out. This is all ready to run. Take it for a spin. Maybe it's not ready to run. Didn't look it over very well. All right, we got 41, which was expected. Try these other test cases. This one should equal 18. Copy it over. Good, good. And this one should equal 18, as I stated before. Right? Very good. It is time to put this sucker in to the training area in codewars and see if it's all good. There's the code, and I have, in case you don't know, to use the arrays class, you must import java.util, either the whole package or the arrays class specifically. All right, that is in there. I think I've said all right too many times in this video. Maybe I say it all right. Maybe I say it too many times anyway. Yeah. That passed. That passed. Good job, sucker. All right, this thing passes. Let me show you the code again. There is that beautiful, beautiful method that passes the code wars test. I'm passed. We got the greens, got the points a long time ago, and see what you guys can do with this one. But for me, that's it. I'm a skedaddle. You will as well. And next time, you'll see me do another one or something else. I don't know what the hell I'll do, but I'll be back very soon. See y'all later. Hello. We meet again. And now it's time for longest palindromic string, substring actually, from LeetCode. And this is a Python exercise. Settle back and enjoy. All right, looking at the instructions. Given, let me clear my throat. Given a string S, return the longest palindromic substring in S. A palindrome is a string that is the same backwards and forwards, and a palindromic substring would be a substring within a string that is the same backwards and forwards. So we're going to be given a string. We got to find the longest portion of the string that is a palindrome. Could be the entire string, maybe a substring. Who knows until we get in there and figure it out. Looking at example 1, we have babad. Maybe that's how you say it. But the longest palindromic substring is BAB. Of course, BAB is the same backwards and forwards. And also ABA is a valid answer. So we got to go in and kind of parse and figure out a substring that is the same backwards and forwards. Example 2, CBBD, the longest is BB, there in the middle. No other portion of the string is palindrome. So yeah, the instructions here are short and sweet, but the idea is pretty obvious. Given a string, find the longest portion that is the same backwards and forwards. So digging in here with the code, it's slightly larger. Because I'm going to need to find the longest substring that is palindromic, I am going to maintain a record of which length is the longest so far and which actual string is the longest. So I'm going to create two variables to hold each of those things. One variable for the longest length, one variable for the actual longest string. So one for the longest, and I'll start that at a 1, and this will be the longest string. And I'm going to make the longest string currently just the first character of S. So longest length 1, longest string right now is just the first character of S. I start longest length at 1 because you're not going to have a 0 length palindromic substring, and realistically, a single character is a palindrome. So it's a given that any single character is a palindrome. We're going to find one either longer than that, or each single character would be a palindrome. So I guess long story short, At a minimum, your longest palindrome is going to be one character. So go ahead and set it to 1 for the length and the first character of the string. So here's my strategy with this, and I'll draw it out. Let's say we have a string AB. Let's say the string is, even though this is, of course, there's no palindromic portions of this string, but I'm going to use this string to illustrate the strategy. So I start with this. I'm going to use a nested looping situation where I'm going to, in my outer loop, I'm going to loop through the characters of my string, and on the inner loop, I'm going to then, really what I'm doing is I'm using each character as a starting point to create substrings in my inner loop. So here's what I mean. For each character, I'm going to loop through, and in the inner loop, I'm going to start at the next character. So let's say on my first iteration, my I loop is going to start with A. I'm going to then loop through B, C, D, E, F in my J loop, where I'm going to make a progressively larger substring with my substrings will be, on this first turn, they will be AB, A, B, C, and then A, B, C, D, and then it'll be A, B, C, D, E. Because really on each iteration of the J loop, the substring gets larger and larger and larger until it's A, B, C, D, E, F. And then I'm checking each one of these to see if they're a palindrome in the process. And then on my second turn of I, what will happen is A will be out of there, and I'll start with B. And so it'll be, starting with B, it'll be B, C for the first turn, and then it'll be B, C, D, and then it'll be B, C, D, E. So you can look at this one as like my I equals 1 will be these substrings, and my I equals 2 will be this set of substrings. You see the I equals 1 is going to start with A, the I equals 2 will start with B, and so on. And then when I is 3, it's going to be starting with C and going for the rest. This tactic is going to allow me to get to all of the substrings, and then I'll be able to, for each substring, check if they're palindromes or not. All right, on to the code. So going in here, I'm going to start my loop. Length of S. Yeah. And I'm going to go actually the length of S minus 1, because my the shortest palindrome, or the shortest substring that I'm going to check for really is going to be a substring of 2, because I've already established that the shortest palindrome really is going to be 1, a length of 1. So there's going to be no situation where I'm at the end of my string and I'm going to check to see if the last character by itself is a palindrome. So I'm going the length minus 1 to see if I'm at the end or near the end, it would be the second to last and the last. See if those two are palindrome substring. So there's no reason to go all the way to the end because I'm not going to check for a single character. So yeah, do this. And then on my J loop, Oops, enrage. My J loop, I'm going to start with I plus 1 and then go the length of S. The J loop goes all the way to the end because if I'm at the end with I or near the end, if I is on the length minus 2, J will be on the length minus 1. Those will be the last two characters, and I'll check for those two together being a palindromic substring. So J will go all the way to the end. I will go one before the end. And I'm starting J at I plus 1 because all of the substrings I'm going to check for, I will be the beginning. I is going to be the beginning of each substring that I'm going to check for. So the next set of characters after I will of course start with I plus 1. So that's why my J loop is starting with I plus 1. And I'm going to create my substring here. I'm going to put it in a variable because it'll be easier to check as it's in a variable. I'm going to create a substring through slicing, where I'm going to take a slice of S going from I, which like I said is going to be the beginning of my substring, I to J plus 1. I'm using J plus 1 because I want to include the character at J in my substring. So I got to go J plus 1 because the end of a slice is not inclusive in Python. So I got that. And there's my substring. So now I can check the substring to see if it is a palindrome. I do that with an if statement. And here's some handy dandy syntax to reverse a string using slice notation. So I'm going to say if the reverse of the string equals the string, or really the substring. So if the reverse of the substring equals the substring, then it is a palindrome. And I'm not only going to check for it being a palindrome, I also want to check for it being longer than the longest established one so far. Because the reason here is we're trying to find the longest palindromic substring. Well, if it's not longer than what we have already, it doesn't matter. So I'm going to check for it being a palindrome and the length of it being greater than my established longest length. If it is, then we are good, and this will be the longest. So I will assign longest len to this one, to this substring. And actually it'll be the length of the substring because this is the integer length. And longest string will be this. And once these loops are over, I'm going to have my longest palindromic substring. So what is left is to return. Return longest str, because the task here is to return the longest string, not the integer longest length. All right, I'm ready to check this one out. Run it. Accepted, passes the test cases. That's good. Now, drum roll please, I will submit to the real test cases. It is accepted. Very good. Not the most efficient situation, but it works. And this ain't the most efficient code, but it is perhaps a little easier to break down and easier to explain. So this is what I went with. So this is the solution. This is a solution, actually, to the longest palindromic substring from LeetCode. And that's it for me. Enjoy your day. And I am out. Out. Okay, 3, 2, 1, we're looking at missing number from LeetCode, and this is a Python exercise. And let's dive right into this sucker. Let's take a look. Given an array nums containing n distinct numbers in the range of 0 to n, return only the number in the range that is missing from the array. This function that we create is going to take in a list of numbers, and there will be one number missing from the sequence. What this doesn't really tell you up here is that you're trying to get a consecutive sequence, or you're trying to find the missing number from a consecutive sequence from 0 to n. And what is n in this case? It says it down below in this exercise. N is the length of the list. So n is the length. So you're trying to find a number, or not trying to find a number, you're the reference sequence is from 0 to the length of the list. And again, it doesn't tell you that it is supposed to be consecutive from 0 to the length, and you're supposed to find the number missing from the list that would make it entirely consecutive from 0 to the length of the list. Looking at examples, we have this one, and with this one, the length is 3. So I guess you could just say n equals 3. So 0 to n would be 0, 1, 2, 3. And you look at what we have here, obviously 2 is the missing one. And so yeah, all numbers are in the range of 0 to 3. 2 is the missing number since it does not appear in this list. So that's a pretty easy one to eyeball. Looking at the next one down here, example 2 is a little trickier, where you have a 0 and a 1. Doesn't look like anything's missing from that sequence, but let's get the length. N equals 2, and remember we're supposed to our reference sequence is going from 0 to n inclusive, so we're measuring against 0, 1, 2 as our sequence. If you measure against 0, 1, 2 as a sequence, you see clearly that 0, 1 is missing a 2. And as you see, this is the answer. Explanation is that n equals 2 because the length of the list is 2, and the range we're looking against is 0 to 2. 2 is the missing number because 2 is not included in this 0, 1. So that one is a little confusing. We'll look at one more. Down here, we have this collection of integers. And what's the length of this? 1, 2, 3, 4, 5, 6, 7, 8, 9. N is 9. So our reference sequence is from 0 to 9. And if you eyeball this one, you see what's missing. You just count 1, 2, 3, 4, 5, 6, 7. I don't see an 8. 8's the missing one. Yes. So that's the explanation. That's really how you approach this one. Let's see how we approach this one in code. Move this one over. Maybe I will increase the size. Because the guideline here is to go from I have to have a reference sequence going from 0 to n. I need to find n. What the hell is n? Because, in any given a list of numbers, I need to find the length so I can have my reference sequence. So I'm going to say flatly that n equals the length of nums. Because I've got to have, I know my sequence is going to start with 0 and it's going to go to n. And I need to build my reference sequence because I need to measure the list that comes in as an argument against the consecutive sequence. So I got to build the consecutive sequence. And in Python, the easy way to build a consecutive sequence is to use the range function. So I'm going to do that. And I'll call it numList. And I'm not even sure I need to convert it to a list, but I'll do it anyway. So I'll call range, and I'll call range at n plus 1 because I'm doing the argument of n plus 1 because the ending is not inclusive. So I want to include 0 to n, so I'm including, or I am placing n plus 1 as the argument so that I include n. So now that I've got that sequence from 0 to n, I can just I can compare the argument that comes in to numList, and the missing number in between those is the missing number, the difference basically. So notice I said the difference because really, yes, the difference between the argument that comes in and my sequence here, my reference list, is going to be the missing number. And in Python, you can do difference via a set function or a set operation. Yeah, there's a data type in Python called a set, and it has the set operations of union, intersection, difference, and symmetric difference, kind of like mathematical sets. And we can find the difference between a set of two numbers. It is ideal for this situation. So what I will do here is I'm going to convert my numList and the argument to sets, and then I will simply do the difference. And it's going to look like this. So my indentation's kind of messed up. All right, got that. And I can do this all in one line, so I'll do a return statement. Because once I get the difference between these two sets, I will simply return. So I'm going to put I keep calling my reference list in a set. And then I will put the argument in a set. So when I gotta explain this here, the minus operator, when applied to sets, does the difference. So this will get me the difference, or really the differences between the two sets. and it'll put it in a set. So this returns a set, and I guess the situation is once this returns a set, it's going to be in set form. The function is needs to return an integer, so I'm going to remove the first element of whatever the set is. There should only be one element because there should only be one difference. But anyway, I need to remove it from the set so that it is an integer. So I will use the pop function to remove that single element from this resulting set. So I'm going to pop it, and that'll give me a single integer that will be the difference between the two sets. You got all that? Good, good. And I think that is it, because I've got in, I've generated my sequence to check the incoming list against, and then I've converted each to a set and gotten the difference, and then I'm going to remove what should be a single element from the difference set. It is time to run and test. That passes all the test cases, and these are the test cases that I went over with you, so that's good. And I will submit for the final testing. That works. We got acceptance. We're in. We've graduated. So that is good enough for now. Good. Okay. So there is a solution to missing number in Python from LeetCode. And until next time, keep coding and keep grinding. I'm out. Three, two, one, what's up? Today, we're looking at from A to Z, done in Java from the site codewars.com. Let's look at the instructions for this one. I like this one. Given a string indicating a range of letters, return a string which indicates all the letters in that range, including the last letter. Note that if the range is given in capital letters, return the string in capitals also. So with this one, you are producing a range of letters. Looking at the inputs over here, you have letter dash letter, the first letter being earlier in the alphabet than the second letter. You're kind of asked to fill in the yada yada, fill in the blank, or fill in the dash with actual alphabet letters in consecutive alphabetic order. And you need to also handle capital letters as part of this. So it needs to be, I guess, case sensitive, as they say, where if you get uppercase argument, you need to produce an uppercase range of letters. So really, yeah, it's first letter dash second letter, and the output needs to be an entire alphabetic consecutive range in your return. Take in a string, return a string. There's your inputs and outputs. So how might you do this? In programming languages in general, there's no internal knowledge of the order of the alphabet. So you can't just, with some function, just say, oh, let's go from D to T and give me all the letters consecutively. There's no real built-in thing. So you could either create a string that contains the consecutive letters of the alphabet and use that as a template to produce the range. Another tactic that I'm going to use in this one is going to be to use the ASCII character codes of the letters to produce my range. Because when you look at the ASCII chart, of course, the letter characters are going to be in alphabetical order. So you just kind of, you map to that, and they're going to be in alphabetical order. They're going to have numerical equivalents. So to get the order, you will convert them to their ASCII decimal equivalents, and then just iterate through the numbers forward consecutively to produce the letters. So some may ask, what the hell is the ASCII chart? Well, I'll show you very quickly. Of course, you can Google it or chat GPT it, but I'll give you this little skinny very quickly, and not that. There's an ASCII chart right here. Let's see if I can increase a little bit here. Yeah, it doesn't do anything. So hopefully you can see it, but the ASCII chart is really internally characters on your system. They are mapped to numbers internally, and of course computers deal with numbers internally, and they're mapped to characters so that we can read them, but internally they're going to be numbers. And this chart really details the conversions from characters in various numbering systems to numbers. So let's focus on really on these two columns over here, because these contain alphabet. You see uppercase over here, lowercase over here, in the char column. Now look at the uppercase A. If you go over here, you see that uppercase A maps to a decimal 65. That is A's ASCII decimal code. And in Java, you can convert back and forth between a character A and a 65. Really, my tactic in doing this this exercise is going to be to take whatever letter it is, convert it to its ASCII decimal equivalent, and then iterate forward consecutively until the end of the range. And for each number I go consecutively, I'm going to convert that number to its ASCII equivalent, or its character equivalent. Let's think about let's say we're going to go from, if you can see this up here, capital A to capital J. That'll be our range. So with A, you would convert it to a 65, then you'll just count forward until you get to whatever J's code is, which is 74. So you convert to 65, let's kind of iterate forward a few turns. Iterate forward to 66, really like using a for loop. Or start at 65, go to 66. 66 is B, so we would convert 66 to B, and that would be the next letter in our range. So like we can just start this where the A would get converted. Well, you've already got the A. Iterate forward to 66, there's your B. Forward to 67, there's your C. Forward to 68, there's your D. And hopefully you can get kind of follow the pattern. And it's going to go all the way to J, which is 74. So I'd kind of set up a loop where it says, the loop would say, starting at whatever the character code for the first letter is, the condition would be iterate forward until you hit the character code for the second letter. And for each iteration, you're going to be converting the decimal to a letter and concatenating it to a string. So there's a condensed form of what I'm going to be doing, a condensed explanation of what I'm going to be doing in the code. And I've already got the code together, so I'll shift over to that tab so I can explain it to you. Over here in Online GDB. Shout out to the folks at Online GDB, one of the better online IDEs, and no, they are not a sponsor. I just use them frequently. Okay, this method right here is the solution. Let's take a look. Takes in a string, And this one right here, this variable, this is going to be my final string that I'm going to put my range into. Initially, it's going to be blank. And the real meat of this method is simply a for loop, where in my for loop, I'm going to create an integer I as my starting point, and the integer I is going to be the decimal equivalent of the ASCII character. So that is done via this conversion right here, really this casting. In Java, when you cast a character to an integer, it gives you the ASCII decimal equivalent. And then if you take a decimal, an integer number, and you cast it to a character, it'll give you the character associated with that integer. So it's kind of a cool back and forth where that conversion happens. So yeah, play around with that a little bit and check it out. But what I'm doing here is I'm getting the integer conversion of whatever character is at the beginning of my string. Let's use the example of A to J once again. I'm getting the integer equivalent of that character code, and A's character equivalent, I'll do it down here, it's 65, as we saw from the chart. So if we were doing from A to J, this would be starting at 65. So you could kind of hard code it mentally to say I equals 65. And then the condition over here is going to be, while I is less than or equal to another ASCII conversion. And this would be my ending point, while my starting point is not equal to my ending point. And this is going to be the character at index 2. When you have a string like this, A to J, A is 0, dash is 1, and the second letter is 2, index 2. So if we're going to mentally hard code this, this would be the integer ASCII equivalent of J, which is 74. So you can break this loop down to say I equals 65. While I is less than or equal to 74, I plus plus. It's going to give me my range. And then what am I going to do in the body? In the body, I'm going to concatenate the character equivalent, really converting back from the ASCII integer to the character. So this will end up being the number 65 through 74 as you go along. First time I will be 65. 65 converted to a character is going to be an A. 66 converted to a character is going to be a B, and so on. So it's just going to go run through all of them, and for each one concatenate to range. Range will be my range of alphabetic characters, consecutive. And once I'm done with that, I return my range, and that's it. Let's take this one for a spin. I've already got my code set up here down in my main method. So I'll run it. And I've already got my test data of R to X. And we see that it works, and it works for uppercase. And the cool thing about this method is that it is already case sensitive. It already handles uppercase, lowercase because of the way we're doing it. I'll just leave it at that. Let's do lowercase a to lowercase j. You see that totally works. We'll do on the last one. Let's do C to Z. Get a lot of letters up in there. C to Z, that one's good. Awesome, awesome. This is ready to drop into the Code Wars arena. So Code Wars is right here. Let me drop it in. Get these, well, I've already got these points. I did this one a long time ago, originally. I'm just going to show you that it passes. Hopefully it does. You never know. Don't get too braggadocious. All right, that one passes, and that's good. So here's the code once again. And this one is from A to Z in Code Wars. Now go about your day, keep coding, have some fun out there, and I'll talk to y'all again soon. I'm out. Okay. Today we look at an exercise called Rotate for Max from codewars.com. And yeah, it is a Python exercise. We are ready to go this morning or something. It's almost afternoon. Okay, let's begin with an example. Take a number 5, 6, 7, 8, 9. You'll rotate left and you get 6, 7, 8, 9, 5. What is happening here, this is a common thing in programming, computer science, whatever you want to call it, where you have a set of something, whether it be a number, list, whatever, and rotation is shifting the data, where here rotating left is shifting every number to the left one spot, and the number that's all the way on the left gets shifted to the other side, really to the right. So you see the 5 ends up going to the right, and then the 6 becomes the first number. You see 6, 7, 8, 9, they shift to the left. 5 goes from the beginning to the end. That's kind of your classic rotate left scenario, where everything moves to the left by one spot, and the thing on the that is all the way on the left, when it moves over one spot, it wraps around to the right side. So that's a rotate left. So that's the beginning of this thing. And as you get further into it, keep the first digit in place and rotate left the other digits. So this is going to be a rotation with a twist, where once we rotate, we're going to keep a progressively larger number of digits fixed on the left side. And you see here it says keep the first digit in place. This is where it begins, where we shifted left to begin. We shifted everything to the left. And then on the next turn, we're going to shift everything except the leftmost digit. Then we will shift everything except the 2 leftmost digits. Then everything except the 3 leftmost digits. So we have a progressively larger number of numbers from the left becoming fixed as we rotate. So getting back in here, keeping the first digit in place, rotate left the other digits. Interesting English. So we keep the 6 in place. We rotate the other 4 to the left. These began as 7, 8, 9, 5. When you do the rotation to the left, you get 8, 9, 5, 7. Because the last 3 move to the left and the 7 wraps around to the right. So as you see, 8, 9, 5, 7. So on that turn, the 6 stayed in place, so we got a 6 in the beginning. On this next turn, it says keep the first 2 digits in place and rotate the other ones. Now on the next turn, we keep the first 2 in place and we rotate the last 3, and this is going to become 5, 7, 9. So then it'll be 6, 8, 5, 7, 9, as you see there. And then after this, you're going to keep the first 3 in place and shift the last 2. Guess this is going to become 9, 7. And so you go through as many rotations as you can, really. And let me clear this out. Moving down a little bit. Keep the first 3 digits in place, rotate the left the rest. Now it's over, since keeping the first 4 remains only 1 digit, which is rotated is itself. Well, whatever this says. But really, you rotate until there's no more digits to fix. So yeah, you keep fixing a progressively larger number of digits from the left, and really, the result is a set of rotations. This one is the original. The one on the left is the original. Then this is rotation 1, 2, 3, 4. And if you really pay attention here, the number of rotations that are possible is going to be equal to the number of digits in the original number. There's 5 digits in the original number, and you see here there are 5 rotations. 0, 1, 2, 3, 4 equaling 5. So the length of the number in terms of digits will be the number of rotations. So you can kind of take that to the bank, and you can use that as a condition for a loop, where I'm going to keep making rotations as long as I have not hit the length of the number, digits wise. So after all that, what you actually have to do in this exercise is get the maximum of the rotations. So the maximum value out of the rotations. So here you have a set of rotations. What is the maximum out of these 5 rotations? And it tells you that the maximum is 6, 8, 9, 5, 7. So this is just a quantity maximum. Which one of these rotations is the largest? So what we got to do here is take in a number, get all the possible rotations using this algorithm, or this format. Then from those possible rotations, which one is the largest? Yeah. And on codewars, this is a 7 Caillou. I think it's a little bit harder than a 7 because there's some complexity here. So maybe miscategorized, but it is what it is, homie. All right, let's now go into code, and I'm going to show you the code that I used to solve this problem. And no, there ain't going to be no jump cut. I am simply dragging it over, not getting fancy here. I'll leave that for my later videos. Okay. So in this function, n is going to be the multi-digit number that I'm going to take in. And I think as I explain this, I will have a multi-digit number by my side to kind of walk through the joint. And the multi-digit number I will use is 1, 2, 3, 4, 5. Very simple. So yeah, let's say n equals 1, 2, 3, 4, 5. All right, so as we come in here, I'm going to convert it to a string because doing the rotations on a string, it's just going to be easier. Yeah, you could totally do this numerically, but I didn't feel like putting in the effort to do that. So I'm going to convert to a string where I can manipulate the numbers as characters easier. So I convert it to a string, and then I set a variable I to 0 because I'm going to do looping. And here I set a variable suffix to the length of my number, really. And I'm going to be using that in the rotation process in a couple of places, because having the length is useful in doing the rotation, I guess you could say, formula. So that's what I'm going to use it for. On line 6, you have rot list, which this is going to be the set of all the rotations that I create. Once I do a rotation, I'm going to append it to this list, and then I'm going to get the maximum of the list at the end of my function. I start my while loop, and in this while loop, I'm going to produce all of my rotations. And I'm going to produce one rotation per iteration of the loop. So as I keep going, one rotation per iteration. And it'll loop while it's less than the length minus 1 of the string, or I guess you could say the number. And so line 8 is where a lot of the things happen, where line 8 really does the rotation, where I make my new string equal to this rotation formula. And I'll break it down a little bit using my test data that I have written up here. So we went over what rotation was, so let's see how this works in action. Let's go through iteration number 1, and maybe we'll do a couple of iterations. So the string with a slice ending at I initially, of course, is going to be 0. So this would be on the first iteration going from 0, or really the beginning, to 0, and really it will be nothing. So on first iteration, this quantity will produce nothing. And so then I'm left with the rest of it. And yeah, this is a concatenation where I'm going to do the rotation through certain syntax along with concatenation. So, okay, that's going to be nothing on the first one. So then what is this? Looking in the brackets, we have negative suffix minus 1. Suffix is the length of the string, which is going to be 5. Let's say s equals 5, the length. And 5 minus 1 is 4. So suffix minus 1 is 4. And then we have a negative on it. So it's really going to be brackets negative 4 next to the string. So negative 4 is going to be, of course, negative index. So let's see what that is. Negative 1, negative 2, negative 3, negative 4. It's going to be this 2. And so I have a slice starting at the 2 and going for the rest, which is going to be this quantity, 2, 3, 4, 5. So that's what this is. It's 2, 3, 4, 5. And then we concatenate with what? Negative suffix. Suffix is 5, as we see here. So negative suffix is negative 5. So index negative 5. Index negative 5, it's the 1. So this would be plus 1. So my result after the first rotation is 2, 3, 4, 5, 1. And there we go. There's your first rotation. Let's do one more iteration of this. Do a little bit of clearing here. And actually I haven't completed this iteration, because if we go down here on line 9, I append it to the rotation list. Because I did my rotation, now I'm going to append it. Then I subtract 1 from suffix. And this is done to, well, it's going to aid in the rotation. So subtracting 1 from suffix becomes 4. I goes up by 1 because I'm going to be iterating forward, and then I loop back around. Okay, so looping back around, now my string is 2, 3, 4, 5, 1. So let's clear this out and put 2, 3, 4, 5, 1 up there. 2, 3, 4, 5, 1. There's my new string. And this is what I'm going to start with for this next iteration. Okay, let's look at this. Line 8, strnum, and then this slice I. Here, I is now 1 on this next iteration. So this would be 0 to 1. And so that would give me index 0 of my incoming string. So index 0 is the 2. So that's going to be the beginning. And it's 0 to 1, which will be the 2. So that'll be my beginning. 2 plus something. It'll be whatever this is. So that's kind of step 1. And remember that we have a progressively larger number from the left remaining fixed. And that's what this 2 is. 2 is going to remain fixed from the last rotation. See, the last rotation is this, and 2 is there. It's going to remain fixed in this next one. And as we move forward, we're going to have a larger number remaining fixed. Okay, 2 plus. And then here with string num, it is negative suffix minus 1. Suffix is now 4. It was 5, but now it's 4 due to this minusing. So it's 4. 4 minus 1, 3. So negative 3 to begin. So we're looking at index negative 3 colon to the end. It is going from index negative 3 to the end. Looking up here, negative 3 to the end is this, 4, 5, 1. So let's go 4, 5, 1. That's the next piece of our rotation. Then we're going to do a plus for this, and look at the rest. Okay, negative suffix. Negative suffix is 4, negative 4, and this is simply an index, this is not a slice. Negative 4 is going to be the 3, which is going to be at the end. So, after this iteration, we have 2, 4, 5, 1, 3. That is the next rotation. You take that rotation, append it, and then suffix changes now to 3, and then I will change to 2. So those are the first 2 iterations. And because of the depth of these and how long it takes to explain them, I'm going to stop here. But you continue on this path, get all the iterations, get all the rotations, and they're going to be put into the rotation list. And what I'm going to do now is I'm going to run this code with 1, 2, 3, 4, 5 as the input, and you're going to see that the first 2 rotations are in fact 2, 3, 4, 5, 1 and 2, 4, 5, 1, 3. Here are your first 2 rotations as I explained. Because on line 12 I'm printing them out, and you're going to see those first 2 rotations along with the rest of them. I'll go ahead and run it. There we go. And yeah, I didn't explain this, but in the code I put the first rotation, I kind of preload it with the first rotation on line 6. Because the first rotation is the original number that is the argument. So that one goes into the list first. Then the next rotation is the actual first rotation that we do with this algorithm. Okay, so first rotation is 2, 3, 4, 5, 1. As you see up there, and there it is, 2, 3, 4, 5, 1. The next one is 2, 4, 5, 1, 3, which is right here. So there's proof positive of the operation of the algorithm. And if you don't get the algorithm, go back and run through it again, and then try to analyze it a little bit. But pretty interesting stuff with this one. Yeah, there's some depth here. All right, so there's the set of rotations, and I'm going to clear this out and now run the test cases, or a couple of them, from codewars, and make sure things are correct. I'm going to comment this out, and let's look at codewars, and let's see, get in here, dip in, and looking at test cases down here. Let's see this, yeah. This test case results in this output. So let us go side by side here a little bit. I don't know what the hell that was. It's kind of messed up. Okay, yeah, we see a test case. Okay, that should result in 858 blah blah blah. Let's throw it in there. 858 blah blah blah. Same. Good. Let's do another one. That should result in 988 blah blah blah. Blah 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 blah. And it does. Test cases look good, outcomes look good. So let me drop this in to the codewars training area. Let's patch this up and keep it moving. All right, run the test. That's good. Run another test. That's good. Let's go. Time to flex. Impressive. And that is it with this one. This is Rotate for a Max, and I'll show you the code again real quick. There's your code for Rotate for a Max from codewars. Python exercise. Keep coding, keep grinding, keep flexing. I am out. Back again, once again, with descending order, a Python exercise from codewars.com. Yes. Do I really have to say .com? I don't know. Anyway, the description. Your task is to make a function that can take any non-negative integer as an argument and return it with its digits in descending order. Essentially, rearrange the digits to create the highest possible number. So it is in descending order. So you're going to get an integer that may be a multi-digit integer, whether it is or not, whatever. But yeah, you're going to get an integer, and you need to really sort it in descending order. Sort the digits in descending order. See, this one becomes this, and descending order is the highest possible because you have like the highest value at the top, at the left, then the second highest value, then the third highest. It ends up creating the highest possible value from the digits when you do this. It's like a byproduct. So the task really here is to sort the digits in descending order, and descending order is greatest to least. I almost said it wrong. Y'all almost got me. You didn't get me. Okay. I'm going to show you a couple of solutions to this one. This is a pretty easy problem, I guess, depending on who you are, what you've been exposed to, blah, blah, blah. I'm actually going to, the first solution is going to be a one-liner. Of course, Python, you can do a heck of a lot of one-liners, and there's some Python programmers who all they do is try to get all their code into one-liners. I'm not typically that person, that dude, but I like it for this one because this is can be short and sweet. So with this, when you've got an integer that may be multi-digit, you're going to need to isolate in order to sort, because you can't really sort the digits while it's an integer, because an integer is a kind of a joined together quantity. It's a single entity, and you can't break it apart as is. So you've either got to break it down digit by digit mathematically, or you've got to convert it into a string and then a list, maybe, possibly, but those will allow you to have single elements as your digits. So anyway, I'm going to convert it to a string and then a list, and then sort the list. Because if I convert to a string, a list, then I sort the list, it'll sort the numbers. Even though the numbers are characters, character ordering is still the same as numerical ordering, so it ends up working out. So I'm going to start it with a conversion. And this will be kind of innermost. I'll convert it to a string, then I'll convert it to a list, because I'm going to sort the list, and I could probably actually sort the string, I think. Yeah, let me try that. I'm actually going to not do the list conversion, leave it as a string, and then sort the string using sorted, and it'll sort it. Sorted is going to sort it in ascending order, and I think I can do a reverse equals true. Let's try that. I'm going a little off from, I almost put turd. We're going a little off what I did before as an experiment. So I'm going to sort the string, and doing the reverse is going to make it descending greatest to least. And then after sorted, I'm going to have a list, sorted from greatest to least, and then I want to join that list back into a string. So I'm going to put join around it. And then, need a dot, I'm going to convert it to an integer, because that is my final submission format. Can't find the words. Okay. Let's see how this one works, because it should do all the things. As long as my syntax is, and some of my operations are right. All right, that passes. That passes. Okay, good job. So that, my friends, is solution number 1. Yeah. I even obscured the thing. That's solution number 1. A nice little one-liner. Let's do the non-one-liner solution. Get rid of that. Okay, your non-one-liner solution, what it's going to be is I'm going to split up the digits mathematically using modulo and division, and then I'm going to, as I do that, I'm going to put the digits into a list, sort the list, reverse the list, then do the process of converting that back into an integer. And first I'm going to do a little little checking here, because this will be an issue using the algorithm I'm going to use. So I want to eliminate 0. So if they don't need the semicolon, if the argument is a 0, I'm just going to return 0 because that's the answer. I'm not going to put 0 through the algorithm because it's not going to work out well. I'm sure I could account for 0, but I'm not going to bother. And so I'm going to create a list to put my digits in, because I'm going to split the digits up using a loop along with modulo and division. set up my while loop, and I'm going to say while num is greater than 0. I'm going to append a digit to the list. And I'm sure some of you more experienced people, you could probably do the sorting while you do the while loop, but I haven't thought about that yet, and so I'm not there yet. So modulo is going to get you the leftmost, the ones place digit. I'm going to put that into my number list, and then I'm going to, via division, I'm going to remove that number in the ones place from the number. And once this loop is done, I think I got one more thing here, because yeah, i's got to, actually I don't need an I. What am I doing here? Yeah. The condition is the number being greater than 0, so I don't even need an iteration variable. Yes. So, scratch that. Once the loop is done, it is time to sort the list, because I'll have all my digits in the list. I will sort. And the sorting will be done in reverse, meaning descending. That's done, and then once I've got the list sorted, it'll be a sorted list of integers. Now, how do you get that list of integers back into an integer? Well, a few ways. The way I'm devising, the way I'm going to do it is I'm going to convert every element to a string, then join this list together, and it'll be a single string. Then I'll convert that string to an integer. Watch me work, folks. Using the, I keep doing that, capital I. Using the map function, I'm going to convert every element of numList to a string, and then I'm going to convert the map object to a list, and it'll go into numList. So after line 11, numList will be a list of strings. And now that I have this list of strings, I can do a little one-liner where I take the list of strings, convert it to a string, then convert that to an integer. And I'll do kind of what I said in backwards order. Int, join, and numList is a list of strings. Join, of course, will convert a list to a string. And that is it, my friends. So let's see if things work out. That works. And that works. Okay. Here is solution number 2. Number 2, like Derek Jeter. Okay. That's what I got for you. Got solution 1, solution 2. We're full of passion. We're full of code. We're ready to face the day. This is it. I got it. You got it. And with that, I'm out. See y'all later. Alright, good morning, good afternoon, good night, and now I'm going to look at the intersection of two arrays, part 2 from LeetCode, and this is a Python exercise. How's everybody out there doing? I can't hear you anyway, so it doesn't matter. But I know you're doing well because you're alive and you're watching this video. Alright, so Given two integer arrays, or in Python lists, nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. So what's an array of their intersection? The intersection of two, I guess you could say, data structures is it's the values common to both. That's the intersection. And let's see how this breaks down in this particular exercise with the examples. Looking at example 1 of nums1 and nums2, 1, 2, 2, 1, 2, 2. Intersection, values common to both. Value common to both is a 2. And you see here the output is 2, 2. And this kind of goes back to the write-up here that says each element in the result must appear as many times as it shows in both arrays. So the output is 2, 2 because, yeah, the common, the intersection is 2, but the common number of occurrences is 2 as well. There's 2 2s in each one. So the need here is to not only get the intersection, but it is to get the common number of occurrences as well. That's the thing with this exercise. So not only intersection, but the number of occurrences that are common to both lists. Example 2. 495 and a bunch of numbers. I don't need to spell them out. You can see them plain as day. The intersection is 4, 9. And yeah, we have the values 4 and 9 in each. nums2 has more 4s than the other one, but the number of occurrences that are common is 1. So there's 1 4 here, 1 9 here. So yeah, common number of occurrences and common values. That is what we are finding in this exercise. So let's get it going here. Not much else to say. Yeah. I'm going to do this right here in the LeetCode interface. So my approach to this is kind of in 2 stages. It's get the intersection and then deal with getting the intersection in the proper quantities. So I'll lay it out here a little bit. Yeah. Once I've got the intersection for step 2, it's going to be putting it in the proper quantities, because that's what we got to do. Okay. Getting the intersection is not terribly difficult, because in Python you have the data structure of sets, and intersection is a set operation. So what I can do here is convert each list to a set and then do the intersection operation to get the intersection of the sets, and then I can use that later on to get the quantities. So I'll create a variable, and it'll be like this. I'm going to get the set conversion of nums1, and the and is the intersection operator. This is going to get me the intersection of these two, the values that are common to both sets. And what it's going to do, it's going to produce a set. So intersect will be a set. And it'll be a set of the common values. And then what I can do next is, because I'm going to return a list from this function, I'm going to create an empty list that I will populate with the intersection values in the common amounts. Empty list to hold my results. So now I'm going to move into step 2. Step 1, I've already got the intersection. Step 2, I'm going to get the intersection in the proper quantities. And how do I determine what the quantities are going to be? I determine what the quantities are going to be. I'm going to get the, see, I have to get the common number of occurrences. So really, it's how many times does it occur? What's the minimum number of occurrences across the two lists? So if it appears twice in one list and once in the other list, the minimum number of occurrences is 1, and that's the number of occurrences I will use. So we have to get the common number of occurrences across both lists. So the minimum, the smaller number of occurrences across both would be the common. That's what I have to get here. What I'm going to do is I'm going to loop through. I'm going to loop through the set so I can get each value, and then I'm going to get the minimum quantities of each value and use that to populate my final list. Looping through the set, I'm then going to loop through what am I looping through here? I'm going to get the what I'm going to do here is I'm going to get the minimum number of occurrences. I'm going to loop through that value and then use that to populate my new list. Show you what I mean here. Sure curly or parentheses are good. I think I've got too many. Yes, yes, yes. Okay, yeah, what am I doing on this line? What I'm doing is for each value in the intersection, I am then I'm getting the minimum, or let's focus here. I'm getting the count of each. I'm getting the count of that one value in both of the lists, and I'm getting the minimum across the two lists. So if there's 3 in one and 2 in the other, this would return 2. Getting the minimum, which is the common number, and then I'm looping an amount equal to that number of times so that I can then populate my new list with that number of values. So if I need to put 2 2s into my list, this loop on line 10 would loop 2 times so I can populate it with 2 2s. See, what I'm going to do is I'm going to populate the list with that intersection value a number of times according to the occurrences that I want. Line 10, that loop is going to handle the number of occurrences, and then I'm going to populate it that number of times. And that is going to solve it, because once I've got the proper amounts in that list, I'm going to return that list. Good, good, good. Okay, I believe this one is complete, because yeah, at the end it's going to have the intersection values in the proper amounts. All right, let's run this and check it out. Invalid syntax. What did I do? How did I screw it up? Nope. N. Open, open, yes. No close there. All right, accepted case 1, case 2. Let's go ahead and submit. Whoops. Hit the run again. Submit now. Okay, there is your solution, my friends. This is the intersection of 2 arrays, or maybe it's 2 lists, intersection of 2 arrays in Python from our buddies at LeetCode. All right, have a good day, have a blessed day, have an amazing day, and have an amazing night as well, and another good day tomorrow. Anyway, that's it for me. I'm out of here, so see y'all again later. All right, what up, what up, what up? Welcome back. Today, we're looking at how many are smaller than me, not me. Python, gotta love the picture. And yeah, let's do the damn thing. Now, write a function given an array, really a list in Python, given a list, returns a list containing at each index I the amount of numbers that are smaller than ARR index I to the right. Example 1, 54321, output 43210. Looking at the name and thinking about the description, what you're supposed to do is at each index, you're supposed to determine, or really you're supposed to count how many values to the right of that element are smaller than it. And you go element by element. So on element 0 of this list, you look to the right and you see 4 is less than 5, 3 is less than 5, 2 is less than 5, 1 is less than 5. You get 4 total. And that's why there's a 4 in your output, because 4 values to the right of 5 are smaller than it. That's really how it works. And if you look at the rest of them, you'll see that idea play out. Like, let's look at 3. The 3, you have 2 next to it that are smaller than it. Look at its index in the result, and you see 2. There's 2 less than it. So it is for each element, you look to the right and see how many are smaller, how many values are smaller than that element. The next one, let's look at the index 0 here. How many to the right are smaller? 2 is not smaller. 0 is smaller, so there's 1, which results in a 1 in the output. Looking at the next element 1, which is a 2. How many are smaller to the right? 1, which is the 0, 1. And you may be seeing a pattern here where actually, this is what I want to key on. The rightmost value is always going to be 0 because there's nothing to the right of the last element in each of these or in any of these incoming lists. So there will be 0 elements to the right because they don't exist. There's always going to be 0 as the last element of your return list. Just wanted to make that simple point. It is time to do some coding. Let's go. Get in here, erase this garbage, and get in here and do some coding. How many are smaller than me? So I'm going to use a nested loop, and really for each element I'm going to loop through the elements to the right. So in the outer loop I will isolate on an element, and then in the inner loop I'm going to loop through all of the elements to the right of it. Here's how it is going to look. I will first create a list to hold my eventual counts in because we must return a list. Then I'm going to begin my loop through the length of ARR, and in my inner loop I'm going to loop through the elements to the right of the I element. I need to create a variable to hold the counts of the elements to the right that are less than my I element. We're trying to get less than, smaller than. So I'll create a variable called smaller, make it 0 because I'm going to count the number that are smaller to the right. In my J loop, I will begin it at I plus 1 because I'm going to the right. I'm starting from the right, and then I'll just go the length, I guess. And yeah, the mechanics of this, let me get this pointer out again. The mechanics of this is, let's look at this list. This would be I on first iteration, and this would be J. And J is going to go through all of these and see how many are less than I. Is 4, is 3, is 2, blah, blah, blah. The J loop, this J loop is going to count from I plus 1 to the end. And then on the next turn of I, you squash this, and then the 4 becomes I, and the 3 becomes J. And then the J is going to go to the end, looking for ones that are less than 4. Looking for elements that are less than 4. All right. Back to the code. And we'll just do a simple comparison up in here. So it'll be, if the I element, which is the one to the left, if it is greater than the one in the J, or the one to the right, then we are going to increase. Smaller by 1. And after the inner loop, we are going to take our count of smaller than, we're going to add it to our list of counts. This must occur after the inner loop, after the J loop, as I call it, is done. Okay, and then once the I loop is done, the overall outer loop is done, we are done. We've got all of our counts and we are ready to return our count list. Don't say count without the O. Don't do it, don't do it. Okay, let's see here. Aha. Missing semicolon. Semicolon, semi-swollen. Alright, that passes. That's good. It looks okay. And there is your algorithm for how many are smaller than me from codewars. I didn't say I was on codewars today, I don't think, but pretty damn obvious if you look at the URL on the top. Okay, we got this done. Another one bites the dust. You got the points. Maybe you did. Maybe you figured out a better way to do it. Maybe you got some critiques, some hate, whatever. Throw it in the comments, whatever you want. But right now I'm out, and I'll talk to y'all, or I'll rap at y'all later. See y'all later. Alright, what I got for y'all today is find the odd int, short for integer, from codewars, and this is a Python exercise. So here we are, given an array of integers. Of course, once again in Python it is a list, given a list of integers. Find the one that appears an odd number of times. There's always going to be only one integer that appears an odd number of times. Looking at examples, a list consisting of only 7 should return 7 because it occurs one time. And again, you're returning the value that appears an odd number of times. 0. Of course, if you have a one element list, of course, that's what you're going to return, that one element, because that's one time. 1, 1, 2, the 2 occurs an odd number of times because it's one time. 0, 1, 0, 1. Oh yeah, the zeros in this one occur 3 times. Yeah, there's always going to be at least one that occurs an odd number of times. Looking at this list, it's 4 because 4 appears one time. So you got to kind of peruse the list and see which value occurs an odd number of times. Pretty simple idea, and really the implementation of this is pretty simple as well. Going to show you 2 ways to do it. Let's strap it in. Let's go. I have no idea what I mean by strap it in, but it is a good, clean, whatever. No dirty minds out there. Alrighty, so I'm going to go through and find a value with a number with an odd number of occurrences. I had trouble getting that out. So yeah, the natural thing is to loop through this thing and count the accumulation of values. Before doing that, a way to reduce the number of iterations, I think, is going to be to create a set out of the values. So I have a set of unique values from the list, and I will loop through those unique values, and then from those unique values, get the counts of the values in the original list, and if and when, or it's not going to be an if, it'll be when, when I have an odd number of values or odd number of occurrences, that is what I will return when I will return my value. If you can follow that madness that I just said. If you can't, you're going to see the code soon, so bear with me. I'm going to create a set. And this is to get unique values from my original list. The original list is called SEQ, I guess sequence. So now I've got unique values. I'm going to iterate through those unique values and then look for, really get the count of the occurrences in the original list. Looping through unique values using a for each loop, and then I'm going to get the counts in the original list. But what I can do is package this in a conditional if statement and say if the count of this value is an odd number of counts or occurrences, return it. That's really what you need to do as far as this exercise, so I can just do that. If I'm going to call the count function on the original list. If the count of this value is odd, and you get odd, you find odd by creating a Boolean expression with modulo 2 and if it equals 1, because an odd number divided by 2 will produce a remainder of 1, so we're going to check for that. If the remainder is 1, we're going to return that value because we found our value. Yeah. And that might be it. Guaranteed to have an odd value, so I don't really need to check for the situation of not finding an odd value. In a normal production scenario, of course you would, but this ain't production. Yeah, I think I can just run this one or try it out. And it works, and it works. Good, good. Impressive. It's like Mortal Kombat or something. Shout out to Mortal Kombat. Boone and Tobias, what's up? I watched that Midway documentary recently that came out on YouTube. That is a good one. If you haven't seen that, check it out. All about Midway, like the trials and tribulations, like the come up and then the heyday and then the takedown. So, or not takedown, but like, you know, they kind of went by the wayside because, you know, arcades went out and then the home market is kind of, you know, I guess maybe for them wasn't so good, but at least Mortal Kombat is still going. Enough of that. Get back to what I'm doing here. So the first version of this works, and so here's your first version, dudes and dudettes. Now I'm going to do a version that is all about condensing, list comprehension style. So got that, and I'll do this one. This list comprehension one, I'm going to list comprehension definitely isn't necessary because I'm going to be returning a single integer. So really nowhere do you really need to create a list. I'm simply doing the comprehension to do this on a one-liner. And I'm sure there's another way to do it. Maybe if you got another way to do it without, if you can create a one-liner without list comprehension to this, go ahead and post that in the comments. Okay. Could have just taken what I had before. Okay, so I'm going to loop through that, and I'm going to do an if on it because, well, I need to. It's the count of S, E modulo 2 equals 1. Yeah, so this is all setting up the condition. If I have an odd count, then I'm going to place S And yeah, so this will end up being a one element list. And I'm just going to grab element 0 of that list. Yeah, this list comprehension is going to produce a list consisting of one integer, that one integer being the odd value. And I'm going to take that odd value list, get index 0 of it, the only element, and return it. So using list comprehension in an unnecessary way, only really necessary to produce the one-liner type of situation. I think I can really do a one-liner by getting rid of this as well. But let me make sure my syntax is good by running this. That's good. That works. So there's version number 2. And let me just go ahead and condense a little bit further. This should be good and okay. Replace the variable with the function call. That's good, that's good. And yeah, pretty obvious that it would be good, but you gotta stay humble in coding. You can't just always assume, oh, this is gonna be great, blah, blah, blah. I'm humbled every damn day with this stuff. This ain't easy. All right. Yeah, this is, I guess, version 3. So there's your list comprehension there, and check that out, memorize it, whatever. Take it, pass it, get the points, whatever, and do your own cool version that's way better than this one. But that's all I got for you right now. Got a couple of solutions. This is it. And with that, I am Ghost. I'm out of here. See y'all later. Yes, I'm back today looking at inverse slicer from codewars. It is a Python exercise. Yeah, so inverse slicer, what it is says you're familiar with list slicing in Python, and of course what list slicing is generally, of course you can do it with other things as well. You can do it with strings. But what list slicing is, it is getting a subset of a list based on a range. Like here, 2 to 4 is going to give me 0, 1, 2, start here, and then 2, 3, 4, cut off here, because this is index 2 and this is index 4. And the upper limit in Python, of course, is not inclusive, so I'm not going to include the 4. It's going to give me these 2. Of course, a regular slice is it is a sub-range of a list or a string. It's probably something else too. I think you can get them for tuples as well. Yeah. So it's a sub-range, and like this one, starting at 2 and going to the rest of the list. 0, 1, 2. Actually, this is from the original, of course, so 0, 1, 2, 63 to the end. But yes, a slice is it specifies a beginning and an ending index, and it gives you the sub range, returns a list. So this one, it is about, let me clear this out, it is about getting write a function called inverse slice that takes 3 arguments: a list, an integer, a list and 2 integers, really, A and B. And the difference here is that instead of the slice being the sub-range, we're going to include what would normally be excluded. We're going to include that. So, and if you come back here and you're doing like your 2 to 4, for this inverse slicer, we'd be including the excluded parts instead. 0, 1, 2, 3, yeah. You'd include the excluded parts for the inverse slice. So we're going to get the opposite of the slice. And so we're going to get a list and then the beginning and end of the slice, and we're going to get what would normally be excluded from that slice. This one ends up being rather simple, at least one of the ways you can do it. Check it out. Here's how we can do it. What we can do is, the name of the list is going to be items, and we are going to we're going to do a slice where, so you can do the inverse slice with slicing. What you can do is we can get everything before the A and combine it with the B and everything after. And this is a sort of list concatenation where we're going to take this one sublist and add it to the second sublist to create the full sublist. And really that is it. That's all you got to do. Because, you know, you think normally A to B is going to include the elements from A to B in the list. But the inverse slicer is going to include the stuff before A and the stuff after B. And that is the slice we are getting here, or really the slices. We're going to take two slices and add them to, or concatenate them. Concatenate together. Good stuff. And that's it for this one, this particular one. I'm just going to go straight forward to the attempt. And that one totally passes. So there is, I guess I'll do two of these. This is solution one. There's no jump cut. I'm just going to erase everything and go from there. Let me do a longer version of this one. So I'll create a list. If you wanted the more spelled out version, here you go. We can loop through the list and say for indexes that are less than A or indexes that are greater than B, we're going to append them to this new list. And this really had the same idea as the last one, where we're getting everything before A and everything after B, because those are the pieces that would normally be excluded, and we're going to include them in this inverse slice. And that's it. I'm going to return this new list, take it to the bank. Let's go. Big Bank Hank. Oh, not quite. I think I'm forgetting this. The standard equal to B, inclusive, right? Yes. Got to include that equals because you want to include B. See, it's from B to the end. So B, the B side is inclusive. The A side is not inclusive. So if you're scoring at home, the A side is not inclusive. That's why there's no equal sign. If there was an equal sign, it would be inclusive. And of course, if I do that, we got problems. So A side is not inclusive. All right, that is solution number 2. Short and sweet, however that looks. And those are the solutions I'm showing you today. That is it. That is all. Whoops. Didn't mean to submit that, but it's okay. But anyway, there we go with that. and I've lost my solution, so that means I need to bail out. Well, you guys can rewind if you want to see both solutions, but that's it for me right now. I'm out of here with this one, and catch you on the flip side. See y'all later. Alright, what we got here is highest scoring word. This is a Python exercise from the good people at codewars. Yeah, highest scoring word. Let's get it, let's get it, let's go. Okay, given a string of words, you need to find the highest scoring word. What the hell does that mean? Each letter of a word scores points according to its position in the alphabet. So A is 1, B is 2, C, so whatever. So I'm going to go through a string and go word for word, and the letters are scored according to their position in the alphabet. For example, the score of Abad is 8, which is A plus B plus A plus D, position in the alphabet. You need to return the highest scoring word as a string, and if two or more have the same score, the word that appears earliest is the winner. Yeah. And all letters are lowercase. That's important, and all inputs will be valid. So look over at the test cases at the bottom right over here. It tells you a little bit where what you're going to receive is a string with words separated by spaces, and you got to find the word that has the highest score in it and then return that word. In this first one, it's going to be taxi, really probably because of the inclusion of the X, as every letter has a score according to its position in the alphabet. If it appears later in the alphabet, higher score. Yeah, so with that we can begin this one, and because we're going to have words separated by spaces, the first thing you're going to want to do is split it up using the split function so that you can get the words isolated as list elements. So definitely the first thing I'm going to do is split the string into split turns the string into a list where the elements will be the words, because the words are going to be separated by spaces. Turn the string into a list. You've got words. Each element in the list will be a word. And I'm going to set up a couple of variables here. I'm going to create a variable to store the highest value, the highest word score that I've found so far. Make it initially equal to 0. And I'm going to create a variable for the highest scoring word that I've found so far. Make this empty because I haven't scored any words yet. So once I score a word, I'm going to pluck it in there and put it as the highest. Now I'm going to loop through my list of words and score each word. I'm going to use a nested looping situation to do this, because on the outer loop, I'm going to loop for each word. On the inner loop, I'm going to loop for the characters in that word in order to score the word, because the word scoring occurs letter by letter. So I'm going to go letter by letter in the inner loop. Loop through the words, and I'm going to create a variable right here for the score of each word, because in the inner loop I'm going to be accumulating a score for each character. I need to add it to a variable so that I can get the total. Score is going to be that variable. And for my inner loop, I'm going to get the length of words I, which will be the length of one word. I'm going to traverse or iterate through one word so I can get the individual letters. And if you didn't know, that's how it works in Python. When you loop through a string, you get the individual characters. I guess that's fairly obvious now that I think about it. Okay, so I'm going to take to accumulate my score, I'm going to add it to, and here is where I'm going to get the score for each letter. How am I going to do that? So you got a letter, how do you get a score from it? Well, what you see over here is the scores according to the alphabet position. How do you get the alphabet position? Couple of ways to do it. I could type out an alphabet like as a string and then use the indexes as the score points, like A is 1, B is 2, whatever. Another way that I found to do it, and this is not anything unique, many have found this way to do it, this is old news at this point, but use the character, the letter's ASCII value to generate the score, because every character on your computer has an associated integer value associated with it called an ASCII value. I'm not really going to go into all the ins and outs because I don't even know all the ins and outs, but you can convert the letter to a numerical value, and what I can do is use an offset of that value to change the scale from what it is to from a scale or to a scale of 1 to 26, meaning A is 1 and 26 would be Z. And the ASCII chart or ASCII values, they're stored in alphabetical order, so I can just use this chart as the order. And in Python, to convert a letter to its ASCII integer value, you use this ORD function. That'll convert from a character to its numerical equivalent. And so I've got to get the character by indexing. And words I is my word. I've got to double index. Words IJ will give me a character. And this next part is important. This will be the offsetting part, minus 96, because the ASCII chart works such that A in that ASCII chart is 97. And I want to convert an A to a 1 and all of the subsequent ones kind of along the same scale. So if A is 97 and I do 97 minus 96, of course that gives me a 1. And I wanted to map A to 1, so there you go. I can use the minus 96 for any value along this, really any lowercase value. So like think about the letter C. The letter C in ASCII should be 99. So let's do the offset of 96. 99 minus 96. I think you know where I'm going with this. It's a 3. And of course, C is the third letter of the alphabet. Its score is 3. So it totally works out. All of your lowercase letters, you convert them to ASCII and then you minus 96. And that's going to give you your 1 to 26 score for that letter. All right. Now that that's broken down, let's continue with the work. It's about the work, my friends. Okay, so I've got that score. And now pulling out of this inner loop, once I've got my full score, I need to compare that word score to the highest, because I'm doing kind of a linear find the highest score kind of or linear find the highest value kind of algorithm. So to do that, I get my value, then I compare it to the highest so far, and if the highest so far, or if the score that I have, if my current score is higher than the highest value so far, I will change the highest to the value of my current score. If you don't get it, maybe you can get it in code. Like if my current score is greater than the highest score already, if it is, then the highest score needs to be set to this, because the point of the highest score is to be the highest, right? Yeah, pretty damn obvious, right? But the algorithm's not so obvious if you haven't seen it before. So if you're seeing this for the first time, hopefully you're getting it. So, okay, yes, if the current score is higher than the highest I found so far, the highest will become that new score, because the point of the highest is going to be to assume the highest as it finds higher and higher scores, so that by the end of this operation, highest score will actually contain the highest. And whenever I change the highest score, I need to change the highest word, so that I've got a matching situation, matching the score with the word, and there we go. Okay, this is pretty much it. Once the outer loop is done, my finding of the highest score and the highest word is done. So I simply return the highest word. Take it to the bank. I think that's it. Whoa. Got some misspellings, I guess. Words. Let's see. Yeah, it's words everywhere. Got that. Got that. Good to go. All right. Nice. Maybe not the most concise, but there it is. We got it. Highest scoring word, Code Wars, Python. Enjoy the coding. Keep coding. Don't stop. Stay consistent. And let's do the damn thing. All right. With that one, I'm done and I'm out. See y'all later. Well, all right, it's Saturday night, let's go. Super excited, right? Yeah, it is the number of anagrams in an array of words, Python from Code Wars. Let's check out the description. An anagram is a word, a phrase, or sentence formed from another by rearranging its letters. An example is angel, which is an anagram of glean. Yeah, an anagram is a word or a string that has the same characters or letters as another word or string. And yeah, they have all the same letters. So really a kind of a short circuit way to determine if two strings are anagrams of each other is to sort both of the strings, and they're going to be in the same order, or actually they're going to be in, I guess, alphabetical order. And if they match, then they're anagrams, because anagrams have all the same letters. So the sorting will be the determinant. Write a function that receives an array of words, returns the total number of distinct pairs of anagrammic words inside it. Looking at example 1, there's 2 anagrams in the list. In the second one, there are 7 anagrams in the list. So the idea is to find distinct pairs of anagrams. And really what you're going to be doing, or what I'm going to be doing in this video, is you end up comparing all the pairs to each other. so you compare every pair. So let's say like index 0 right here. I'm going to compare it to this one, and this one, and find how many anagrams there are. Then I'm going to eliminate that one on index 1. I'm going to compare it to this one and this one. How many anagrams are there? Blah, blah, blah. Then kill it. Then I'll go to this one, index 2. So you just go down the line, and for all of the ones that are left, you compare the pairs. Simple as that. Like, well, there it is. And I will hit up PyCharm now. Try this thing out. Bear with me for a moment while I set up. No jump cuts here, homie. Setting up the environment over here. Alrighty. Thanks so much for your patience. Of course, you could just fast forward the video, whatever, or just closed it. So glad you guys didn't leave, but I know some of you did. Anyway, let's get in here. So starting this function, and yeah, what's the name of it? Oh, let me go into the training area. Anagram counter. Let's just grab all this so it looks the same. I'm going to compose in PyCharm so I can test my result before going back into codewars. So how many anagrammic pairs are there in the input list? And as I was saying before, I'm going to compare all the pairs. So I'll start, let's say I'll start with one and compare this one to all the others. Then that one's done. Then go with this one, compare it to all the others. Then that one's done. Take this one, compare it to all the others. Then that one's done. So it's just you're gonna loop forwards, and for each string or each element, you're gonna compare it to all the others. Then you're just gonna move forward. This will be a nested looping situation. So let's set it up and let's get going. I'm first going to create an integer variable to hold the count. And I'm going to begin looping. I'll loop the length of words. And I'm going to put my, the first word I'm going to isolate, I'm going to put it into a variable. So I'll call it word 1, and it'll be the current element. And I think I'm going to go ahead and sort it because, actually, sorting, yes, turns it into a list. But that's fine because I'll do the same thing with the other one. I'm going to sort it because I'm going to compare this string to all of the other strings in the list, and to determine if two things are anagrams of each other, they need to each be sorted. Sorting will put it in an alphabetical order, and if they are exactly the same after that sorting, they are anagrams of each other. Going back into the code, I'm now going to do another loop, a nested loop, because I think it's I plus 1, yeah. And actually, I think this would be -1 because I don't need to go that far. Yeah. Got a little error over here. Let me check this out. This is like an indentation garbage. Yep. That's good. So in my inner loop, the inner loop is to loop through all of the rest of the elements. Because the outer loop is your, I guess, your I element, your element on the left. And then you loop through all the elements on the right in the inner loop, and then you compare your isolated I element to all of the elements in your J loop on the right. So I'll take the current element of my J loop, and also I will sort it. Where it's J, I'll sort that, and then I'll compare the two. If these two are equal, it means they're anagrams of each other. And I will increase the anagram count. Clear that out. And I don't think there needs to be an else because there's no other action to take place. I'll loop this. And of course, I'm going to return the anagram count. Doop, 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 doop. What am I doing here? Is this even right? I feel like I'm missing something, but I'll see when I run this sucker. I will use my test data, beautifully provided by codewars. So this one should give me a 7. Hey, there it is, 7. Hallelujah. Okay, another one. Weird sounds into the mic. ASMR. 2. Yeah. So things are looking good here. And yeah, you see the outer loop and the inner loop. Outer loop. Take that element, sort it, turns it into a sorted list of letters. Your J loop is going to start at I plus 1, which of course is 1 past I, and it's really going to get the rest of the elements. So let's say, just to give you a little more explanation here, on the first iteration, this del would be I, and then this is the one that's going to be isolated and compared to all the rest. And then you go into the J loop. This would be J to begin, so you compare del to whatever, however you say that. You sort each of them, and are they the same? Yeah, they're going to be the same because they do have all the same letters. So that would be one of your anagrams. Yeah. Then the J loop is going to move forward, and the I is going to stay the same. So the J loop will move forward because, of course, when you have a nested loop, the nested loop goes through all of its iterations for one iteration of the outer loop. So J will end up going all the way down each of these, and each of them will be compared to del to see if they are anagrams. And yeah, there will only be one anagram of del, but the rest of these are going to end up being anagrams of each other, because you look at these letters, it's pretty obvious that they are. But yeah, the J will go down, and then once the J loop is done, then you get a new I, where we move on from del, and then the I becomes this one, and then the J would be ABC. This would be the highlighted one, and it's going to be compared to this one, this one, this one, and this one in your J loop. Okay, just wanted to give a little more explanation in case some people didn't get what I said earlier. Alrighty, I think this one's done. I'm gonna grab this sucker. I seem to say that same thing all the time. Been repeating myself on these lately. Gotta come up with some new lingo. Lingo. Alright. Let's get in here. That looks good. Nice and tightly formatted. The most beautiful. Let's test it. Looks good. Looks good. Correctamundo. The dopeness. I like it. I know you like it. So this is the number of anagrams in an array of words. Really a list of words in Python. And yeah, so you do a nested loop and you compare. We'll really end up comparing all the pairs to each other sorted. And really that's how you find anagrams, is you take each word, sort them, compare them to each other. There you go. All right, got a solution, passed. So that means I'm out of here. And until next time, I'm gonna see y'all later. Okay, here we are looking at index capitalization, Python exercise on Code Wars. I've done this one, I've done a video on this one, but I did it in C++ last time. So doing a Python version of this mother. So, given a string and an array of integers representing indices, capitalize all letters at the given indices. So you get a string and a list, and the list will contain indices. And the job is to capitalize all the letters in the string at the given indices. So the first one, 1, 2, and 5, you're looking at 1, 2, and 5, capitalized at those indices. On the second one, it's 1, 2, 5, and 100. So it's 1, 2, 5, and 100. Well, of course, there is no index 100. So really what this is telling us is that we need to observe the fact that we're going to get some out of range values. We need to be able to handle that situation. So it's not always going to be valid indexes. It will be sometimes invalid indexes. We got to have a strategy, be ready to handle that ish. So gonna do that. But yeah, it's as simple as that. Capitalize at the given indices. I'm gonna get into the training interface and see what we can do with this. Tackle this one. So S is the string, end is the list of indices. I'm going to create a new string to hold my capitalized string, because as we know, strings are immutable in Python, so you can't directly modify the string that you get. Yeah, you could turn it into a list of characters and do that, but I'm just going to create a new string and sort of copy over what I want from the old to the new, making changes along the way. So guess I'll call this one new S, or new-ish. I'll call it new-ish. Let's do like a hip-hop angle. And it'll be empty string. I'm going to loop through the list of indices. And for each one, I'm going to make a change to the string at that index. So I'm going to do for I in range IND. I could probably do a for each loop, but I'm so used to doing these that I'll do this. And for each one, I am going to, let's see. Actually, you know what? Actually, I need to do this differently. Yeah. I don't know what I'm thinking here. I need to loop. I'm going to loop through the original string, and then I'm changing midstream. I kind of forgot how I did it before. I am going to do this. I'm going to loop through the original string, and I'm gonna do an if statement that says if the current index is in this list of indices, then I'm going to uppercase this letter. So I'll say if I is in this list of indices, then I'm going to uppercase it. So S I, gonna uppercase it, and I do need an else, because the else is going to take care of the other letters, because of course there will be letters that are not uppercased. So if the letter is not appearing in the, or if this index is not in my list of indices, then I will not uppercase this letter. It'll stay lowercase. So I'll concatenate that lowercase letter to it. Yeah, that's that. And new-ish. Yeah. So see if this works. Yeah, I kind of changed midstream, so I didn't look at the solution that I did before and just kind of went off the top of the dome. Realized it wasn't going to work the way that I had it before. Yeah. So that passes and that passes. So there's my validation. It does work. Yeah. So now that I know that this worked, let me recap it a little bit. Because like I said there early on, I was having a different thought pattern, but I realized that was wrong. So I had to switch course a little bit. Yeah, so what I'm doing here is I'm looping through the original string, like this one right here, looping through the original string, and for each character I'm saying if the current index is in this list of indices, if it's in there, then I'm going to uppercase the letter at this index, and then I'm going to concatenate it to my new string. Otherwise, if this index is not in the list of indices, if it's not, then I'm just going to concatenate the original form of the letter, meaning the lowercase letter. I'm going to concatenate that to my new string. So this would be the lowercase, this would be the uppercase, and I've covered all the bases. Uppercase up here, lowercase down here with the else. Once I'm done, I return it, and there you go. And this also, I'm able to avoid the out of range situation, because I simply say if the index is in the list of indices, if it's there, then uppercase. If it's not, you really avoid it, because of course I never get to index 100 because index 100 is not in this string. So this is nice. It avoids the out of range and it does the job. So good on all fronts. And that's it for this one. This one works. Reasonable solution. I'm satisfied and I hope you are too. But whether you are or not, I'm out of here. And this one's done. I'm gonna see y'all later.